Hello students, welcome to Vedantu NEET English. I'm Diksha Ma'am, your chemistry master teacher. So everybody let me know in the chat box if I'm visible and audible to all of you or not. And firstly, yes, the class has been postponed. The reason was because I was not well, so I had to visit doctor and that's why I was stuck in the traffic and that was the whole scene there. So that's why, but I am here, right, and I'm going to take your class, right. So in this class, we are going to have most important topics, right, that are short going to be in your exam, right? And next is we are also going to see some questions on that, right? Okay. So the format of this particular class is going to be, firstly, we'll pick up anything, whether it's physical chemistry or inorganic chemistry or organic chemistry. After that, we are going to do the questions based on that particular thing, right? So everybody, let me know in the chat box if you all are ready for it. And also let me know that what you want to start firstly. Do you want to start with organic chemistry? Do you want to start with inorganic chemistry? Or do you want to start with physical chemistry? Let me see in the chat box if I see maximum things. Okay, so let me just put one quiz over here. Right, let us see how many of you answer what. Right, let me just put a quiz over here. Not a quiz, a poll. Yes. What to start? Be ready with your answers. Right? Okay. So I'm just writing it over here. Physical chemistry, inorganic chemistry. Wait a minute. And then there is organic chemistry. Okay, let us see. Let us start the poll over here. Yes, let me see the maximum percentage. I'll start with that. Okay. The maximum percentage inorganic, confirm this plus. Yes, definitely more than that. More than that. 100% is 100 plus marks is guaranteed here. Right. So in NEET, there are some specific topics where the questions are asked to you. Right. So you can be assured of that will definitely be there in your exam. Right. Okay. Let us see. 46% students are saying, ma'am, organic chemistry. Is it? Okay, 44%. Okay, great. Let us see. 25% physical chemistry and inorganic chemistry. It's like a mix, but it's not a very hard difference here. Like, but majority is on the organic chemistry side. So I'll start with organic chemistry. Okay. So with organic chemistry, firstly, I'm going to start with, I know you so well. I know you so well. Even my PPT is general organic chemistry. That's the connection we have, right? So let us start with general organic chemistry right now. So because general organic chemistry directly around 3 to 4 questions can be asked directly from general organic chemistry. Okay. Yes, everybody, 3 to 4 questions can be directly asked from general organic chemistry. Yes, sure. Don't worry about that. 100 plus marks will be there. Sure. Right. More than, I would say, if you focus on the topic that I give you, right, then you can, like, if you practice the questions on this, you can even sure that 140 plus marks you can also get, right? Okay. Now, starting with the GOC here, first topic that they ask you is stability of intermediate, right? First topic that they ask you is stability of intermediate. So I'll talk about both the things. Stability of intermediates. Stability of intermediates. So whenever someone asks you stability of intermediates, always remember it is going to be, you can answer this from BARHI, right? B is back bonding, right? Back bonding, right? A is aromaticity. R is resonance. H is hyperconjugation. And I is inductive effect. Right? I is inductive effect. Right now, for all the students who want to revise all these effects, right, in a quick way with me, let us revise all these concepts. Right? Okay. So if you talk about plus side effects, okay. Uh, Firstly, I'll talk about inductive effect. Inductive effect here. Inductive effect, right? So from inductive effect, what you should know is that usually plus I effect questions are asked based on stability, not minus I. Usually you will see plus I only. So remember one thing, that always more number of carbon, that means the branching is directly proportional to more the branching, more will be the plus I effect. That you should remember, right? Plus I means when it is donating the electron, right? So plus I means when it is donating the electron, right? Okay. Now here, next thing to remember is that if they have given you any isotope, then higher mass number will have more plus I effect, right? Okay. Now, if you know this inductive effect here, that what is the effect here? This is dependent on the electronegativity as well. Electronegativity, right? Electronegativity means minus I effect will depend on that, right? So just like you have, let's say NO2, right? This is going to show you minus I effect because nitrogen is electronegative in nature, right? Okay, OH, like if you talk about OH here, this is also going to show you minus I effect because oxygen is basically electronegative in nature, right? So that you have to remember that the one which has more electronegativity will take out the electron from that atom, and the one, if you talk about the alkyl chains, that depends upon the branching, that what will be the effect. For example, you can write here that neo has maximum plus I effect, then you have iso, then you will have N, right? Okay. And if branching is same, if branching is same, if branching is same, if branching is the same, then what you will say that yes ma'am, if branching is same, then directly what you will write, number of carbons will tell you the plus I effect. Let's say you have CH3 and one is methyl, other is ethyl. Both are primary groups, right? But we know that more the number of carbon, more is the branching here, right? Okay, understood? Next is, if in a, let's say in a question you are given with, let's say, which is dominating, you have to know which is dominating. For example, there are so many factors, right? So always remember weak, plus I or minus I effect, but less distance, is more dominating than strong plus I or minus I with more distance, with more distance. Okay, that you should remember. Second important highlight here is that weak multiple groups. Let's say you have 3 chlorine groups attached and here you have just 1 fluorine attached. But in this case, because 3 groups are attached, that is why this will be more dominating here, right? So weak multiple groups, either plus I or minus I effect, whatever is there, is greater than single strong plus I minus I, right? Okay, understood? So that is a very important factor, that when two things are given to you, then how you can answer this. So I'll just ask you one question related to this, right? One question to understand what I'm telling you here. For example, you have carbon, this is positive, right? This is 1, 2, 3. Okay, just one more thing here on the next page related to this only. Let's say you have a carbocation and you have a carboanion, right? Okay, so you have a carbocation and you have a carbanion and you have a carbanion. So what you will see, which will provide the stability here, right? Short, like these are very important questions based on stability, right? Based on acidic strength, basic strength. These are very important questions. Okay. So for carbocation, always remember that this is the carbocation. You always need something which is donating the electron. Okay. So when you are donating the electron, you are making it stable. When you are taking away the electron, you are making it unstable. How to remember this? You can remember this with the help of stress. For example, this is money, right? You can remember this with money. So when someone gives you money, you are happy. When someone takes out money from you, you are sad, right? Similarly, here you have this positive, here you have carbonyl. In this, you need electron withdrawing or donating. So when someone is under stress, you give them more stress. They will be unhappy. When someone is under stress, you take out stress from them, they will be very happy, right? So you can consider it as stress. You can consider it as stress. Okay? You can take it as stress. That's how you to remember these two things, that whether you need electron withdrawing or you need electron donating group here. Understood everybody? Or you need electron donating group here. Right? Okay. Now I'll again go to the same place here. Right? Let's take an example of a carbocation. Right? In this carbocation, let's assume you have 1, 2, 3, and here you have 1, 2, 3. Here also you have 1, 2, 3. This is H, H. This is 1 fluorine. This is H. This is H. This is H. This is H. Okay. And here you have again 1, 2, 3. This is positive. Here you have 2 chlorine, and here you have 1H, 1H, 1H. So now what you will see, this is chlorine, this is fluorine, this is fluorine, this is fluorine. So they are taking out electron, right? Taking out electron, what do you mean by that? Tell me first thing, when you have a carbocation, when you have this is electronegative, this is electronegative. I told you that electronegative things are going to show you minus I effect, right? So that means these two are going to show you minus I effect, right? Now fluorine is more electronegative. That means fluorine will be having more minus I effect as compared to chlorine. That means fluorine is a minus I effect stronger group, right? Okay. But here it is, distance is more, even this is single. Here distance is less, even this is multiple. So that is why this will have a strong minus I effect, right? Now, minus I effect always makes the group unstable. When you're taking out electron with carbocation, you are making it unstable. So that means this is going to be less stable, this is going to be more stable. That is how you're going to apply these things in your exam, right? Okay. Yes, everybody, that is how you're going to apply these things in your exam, right? Next thing is similar to this, we can ask you one more question related. I'm writing it here only because that is related to this particular thing only, right? So what if they ask you regarding acidity? Okay, acidity I will write here. What if they ask you regarding acidity, right? Acidity, if they ask you, simple thing what you will do in regarding to acidity, that acidity we know that here is Ha, that give rise to H positive plus A negative, right? That means you have some H positive ion to be donated. If you are able to donate H positive ion with ease, right, then you can have a stable carbonyl, right? That means if after donating H positive, this is stable, then only it can easily give H positive. If after giving some money, you are still stable, only then you will give money, only then you will donate money. It's not like you have 20 rupees, you will give all the 20 rupees, you have nothing to eat, right? Okay, so you will give according to your capacity. So that means we will check the stability of this carbonyl. Stability of A negative will be checked here whenever you are trying to understand the acidity factor here, right? Next thing to understand is the pKa value is inversely proportional to the acidity. pKa value is inversely proportional to the acidity. If you say they are asking you pK value, that means they are asking you the acidity here, right? Okay. Next, if they ask you regarding basicity, if they ask you something regarding basicity, then it's not like how much it is positive, it is accepting. No. See, if it has good amount of lone pairs, it will accept the proton, right? So directly what you can write, basicity is directly proportional to electron donating group inversely to electron withdrawing group, or you can directly say electron availability. Electron availability, it is directly proportional to the availability of the electrons. Is that clear to everybody or not? It is directly proportional to the availability of the electron, right? Okay, so these are few things to remember here, right? Then next is We have talked about inductive effect here, right? One by one, I'll talk about all the effects. Let's talk about hyperconjugation also, right? In hyperconjugation, what you need to, in hyperconjugation, everybody let me know in the chat box, what is hyperconjugation? Hyperconjugation is the resonance of sigma electrons. Okay, it is the resonance of sigma electrons, right? Sigma electrons resonance we are checking here, right? For that, first you should know the conditions here. What are the conditions that are necessary here? The conditions are alpha carbon should be sp3 hybridized. Second condition is at least one alpha hydrogen should be there. That is the condition of hyperconjugation. And this hyperconjugation is only valid, right? This hyperconjugation is valid up to which thing? It is valid in alkenes, carbocations, and free radical. It is valid only in these three things, right? In case of carbonyls, let's say you have a carbonyl. In that case, you should have a electron negative element attached to it. Only then it will show minus of hyperconjugation. That they can ask you not in any question. They can ask you, I say that if in a carbonyl, what is the condition that they can show a hyperconjugation? In carbonyl, only when any electron negative element, a very high electronegative element is attached to it, only then it will show the hyperconjugation, that too minus H effect, right? Okay, now next is this we have done. Next is, ma'am, what is this variability? Variability is that more the number of alpha hydrogens, more will be the hyperconjugating structures, right? And more the hyperconjugating structures, more will be the stability of that compound. More will be the stability of the compound. Okay, more will be the stability of that. Means whenever they are asking you according to hyperconjugation, if they have to answer, you just need to check the alpha hydrogens there. You will be able to see that, right? Now here, 2-3 things that you should remember here from where direct question can be asked. See, when you talk about in case of carbocation, I'll just write it here. In case of carbocation, what happens? In case of, so basically when you have a carbocation here, right? Let's say you have a carbocation here, that means this is the empty p shell. So what will happen here? This CH bond, one of the CH bond, that is the alpha hydrogen here, it will break and it will jump to this case, right? And there will be H positive over here, and here it will form a pi, right? That means the electrons are jumping from sigma to empty p orbital. Okay, so they can ask you here the electrons are shifting from which position? You can just say sigma to empty p orbital. Okay, sigma to empty p orbital. Guys, I am telling you everything that they can ask you, right? Then if you talk about in free radical also it is the same. This is not empty. This is empty p, right? In free radical, what you have? This is the free radical. It has one electron. Okay, so this is not empty. This is having one electron, and this hydrogen will remain here. The electrons, the sigma electron, will shift to this position, making a free radical over here. Right? So that means it is sigma electrons are shifting from sigma to half filled p orbital. Okay, so we'll just write directly here sigma to half filled. Okay, sigma to half filled p orbital. Okay, sigma to half filled p orbital. Directly you can write this. Now last one and very important. That's why I am writing it this with a different pen. That is alkene. In alkene, there is something different. Okay. In alkene, there is something different. What is different here? So this is C double bond C. This is C. This is H. This is H. This is H. Right? Here also you have H. Here also you have H. This is, let's say this is also H, H and H. Right? So what will happen here? This electron from sigma will shift from this position. Right? Okay, and because here you don't have, already there is double bond, right? Already because you have double bond, so this will shift here. That means this electron is going to shift to this position, which is the sigma, which is the pi star anti-bonding orbital, right? So what you need to, because here you don't have any empty orbital, any empty p orbital, that is why to this carbon it will shift to the sigma star, right? So here what you can do, everybody, here what you can do, you can just directly write that this is shifting for sigma to pi star anti-bonding orbital. Okay, sigma to pi star. Baswa sir is also here with you. Yes. Okay. So now let us see the next thing. Right? Let us ask Baswa sir if he is enjoying organic chemistry or not. Right? Now, everybody, just give me a second. Okay, I think that's it for hyperconjugation. No other thing you need to know for hyperconjugation. That's it, right? Next one is, one thing you should remember. Next I am writing here is dancing resonance. Okay, next I am writing here is dancing resonance. This is also having the maximum stability. Okay, dancing resonance is when you have this kind of structure, right? Okay, you have a positive carbocation over here. Then what can happen in this case? What can happen in this case, right? What can happen in this case when you have a dancing resonance? This double pi bond will, this electrons will shift here. It will have a double bond over here, and this is 1, this is 2. It's like someone is dancing on one leg, right? What if the electrons have shifted to this position? Then you will have something like this. This electrons has shifted here, double bond over here. This is 1, this is 2. See, here you will have the positive charge and here you will have the positive charge, right? This is dancing resonance, and this is very, 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 very important, and it's highly stable, even more stable than back bonding here, right? So that's why I told you that this is the dancing. They can ask you in which of the following dancing resonance occurs. So you can say this is the important part, right? Okay. Next is inductive. We have seen hyperconjugation. We have seen what is the next part, right? Sir is here, come here to check you guys if you are studying or not, right? We teachers have to have a check on you whether you are studying or chit-chatting with each other. That's why sir came and saw, okay, everyone is studying, then I shall go, right? So next is inductive hyperconjugation we have seen. Let us talk about aromaticity. Anybody, what is aromaticity? What you know about aromaticity? Everyone, what you know about aromaticity? Let me know in the chat box what you know about aromaticity. Right? Let us talk about aromaticity here. So, talking about aromaticity, 2 things you need to know here. First thing is, what is aromatic character, right? So, firstly, for this, you need to know that if something is following PCC, right? Then in that case, I'll just write it here. PCC means, anybody in the chat box, what do you mean by PCC? What do you mean by PCC? Let me see how many of you remember this or not. What is PCC? P for planar, what is CC? Ma'am, Priyanka Chopra, ma'am. PCC means ma'am Priyanka Chopra. No, it's not Priyanka Chopra. Priyanka Chopra is with Nick Jonas. Now you have to tell me what is PCC. Our PCC is alone. See, if PCC is followed, then you have to check for the number of electrons. If it is 4n plus 2 pi electrons, or it is 4n pi electrons, right? If it is 4n plus 2 pi electrons, it is aromatic. It is aromatic. If it is 4n pi electrons, it is anti-aromatic. It is anti-aromatic, right? Okay. And if it is not following, then it is going to be non-aromatic. Non-aromatic. Okay. Understood? PCC, hi. But a PCC here, what do you mean by that? It is like PCC, pyridinium chlorochromate. Yes, PCC is pyridinium chlorochromate. That is very good, right? That you remember that. but here PC says planar cyclic conjugation, right? So here it should be planar. That means all the atoms should have sp2 hybridization, right? Then cyclic means it should be a cycle. And third is complete conjugation should be there. Double bond, single bond, whatever. There should be complete conjugation in the entire ring. Okay, that is planar cyclic conjugation, right? Okay, and one thing to remember always, let's say you have two lone pairs. Let's say you have this thing, right? Double bond, single bond, double bond. Here you have one lone pair. Whenever you are calculating these pi electrons, what you have to consider here? Do you have to consider this lone pair? No, right? Because already the conjugation is completed, right? You will only take those electrons in the pi electrons which are in the conjugation. So this is not in the conjugation. This double bond, single bond, double bond, single bond, double bond, single bond are enough. So that is why this will not be under the conjugation. Now, let us see. For example, if you have something like this, okay, one, or I can just draw oxygen here. That will be more like beneficial for you, right? So if I draw one oxygen here, now this lone pair is not considered, this lone pair is considered, because this lone pair is under the conjugation. This lone pair is under the conjugation, so this will be under pi electrons. This is included under hybridization, not under pi electrons. Not under pi electrons. So whenever you are calculating the total number of pi electrons, that will be 1, 2, 3, 4, 5, 6. Here we are not even calculating even 1. So what you can remember here, that pi electrons are those that are taking part in conjugation. That are taking part in conjugation, only those electrons will be considered, no matter how many other lone pairs you have on that atom, right? Okay, it doesn't matter how many other lone pairs you have on that atom. Next is we have anilines, okay? Next we have is anilines. So talking about anilines here, this is anilines, okay? Talking about anilines here, what you should remember, everybody, right? Okay. Talking about anilines, right? They can ask you 8 aniline, 10 aniline and 12 aniline. So one thing to remember in the exam hall, that 8, 10 and 12 are non-planar, okay? These are non-planar. 8 is non-planar because of its tub-like structure. 10 and 12 are non-planar because of hydrogen-hydrogen repulsion, or you can say because of the angle strain. Because of the angle strain. Okay. Very important question. Most probably they can ask you question on 8 aniline. I can just draw the structure for you over here, right? So structure of 8 aniline is basically like this: 1, 2, 3, 4. And you know what are anilines? Anilines are monocyclic conjugated system. Okay. And here the aniline, the number dash represents what you can write here. Number of carbon is equals to number of pi electrons. Okay. That you should remember. If they have written 8 anilines, that means there are 8 pi electrons. And here are 4 bonds here. But this exactly is not in this structure. It has a tub-like structure like this. It has a tub-like structure like this, where it is having the double bonds here. Right? So I'll just draw the double bonds here. Right? 1, 2, 3 and 4. This is having this kind of tub-like structure. Okay? Understood? Everybody? Right? And here, because of the hydrogen-hydrogen repulsions, let's say you have 10 aniline. In this, what will happen? Basically, here you will have 1 carbon, here you will have 1 carbon, and here there will be hydrogen-hydrogen repulsion over here. Because this will be in sp2 hybridization. So angle will be 120 degree only. Because of that angle, there will be repulsions because the distance will be very less. Right? In 12 also there is hydrogen-hydrogen repulsions, but as we move forward, the hydrogen-hydrogen repulsions are less in that case. Okay? Understood? Yes, everybody. Next is, ma'am, what about aromatic and non-aromatic? Here you can write that all these are non-aromatic in nature. All these are non-aromatic in nature. Now everything else is aromatic or non-aromatic or anti-aromatic. That depends upon the number of carbon here, right? So let's say if you have not number of carbon, if you have 4n pi, then it will 4n pi plus 2, wait a minute, 4n plus 2 pi, then it will be aromatic. If it is 4n pi, then it will be anti-aromatic, right? For example, you have 6 aniline. It has 6 pi electrons, that is 4n plus 2, that is aromatic. For example, you have 14 aniline. That has 14 aniline also is 4n plus 2 pi. If you put n is equals to, let's say, you're putting it is equals to 3, 4, 3, 12 plus 2, right? Again, it is aromatic. Talking about 16 aniline, that is anti-aromatic because 4 into 4 is 4n pi, right? So that is why it is going to be anti-aromatic in nature. Is that clear to everybody? Aromaticity here is done on this page. Is that clear to everybody or not? Right? Okay. Yes, everybody. Yes, definitely. I'll provide you the notes, Krishna. Don't worry. Right? I'll provide you with the notes. Right? So here, is that clear to everybody that what we are going to do here? Right? Okay. Next is aromaticity. We have done BAR. Resonance. Let us do resonance. Let us talk about resonance. Okay. Let us talk about resonance here. Resonance. If you see resonance, right, in resonance, there will be basically resonance and mesomeric effect are same only. The difference is when I talk about resonance, I have this benzene, right? I don't have any external group. But if I talk about mesomeric, I'll have a group because of which resonance will occur. That is called mesomeric effect. Okay, so now we will talk about two kinds of resonance, plus and minus resonance, that are important for you, right? So firstly, I'll talk about plus M or minus M effect. Plus M or plus R effect. This is minus M or minus R effect, right? Here, what you should remember that if I'm talking about plus R and plus M effect, just remember one thing, that if you have a benzene on which, can you give me any examples of plus M effect, guys? If you have a benzene which is connected to one group that is having lone pair of electron, minimum one lone pair is required here, right? Then tell me, this is going to show you plus M effect here, right? Any examples of plus M effect, students? Any examples? For example, you have OH. For example, you have NH2, right? For example, you have OCH3. All these are examples of plus M effect, right? Plus R or plus M effect. Yes. So next is directly we will see toluene is not under this category, but yes, it is also plus I effect. It is not plus M, you can say plus I effect, because carbon does not have any lone pairs, right? So it is plus I effect, not plus M effect, right? That you should remember. But yes, toluene is also ortho-para directing, but not because of plus M, because of plus I, right? Then here, if you see, minus effect is if you have a benzene ring, here you are connected some group which is directly connected to oxygen, right? This is having this oxygen, not oxygen, you can say some X. X is more electronegative than this G. Now what can happen? It will take out electron from the ring. That is minus M effect. Examples, can you tell me any examples of this? Like you have COOH group, you have CHO group. These are the examples of minus M or minus I, right? Minus M or minus I, right? Now, always remember that whenever you are giving like the electrons here, you will have negative charge on ortho and para. Ortho and para will have negative charge. Here meta will have, here ortho and para will have positive charge. That is why meta electron density will be more, right? So if you talk about towards electrophilic substitution, when an electrophile is attacking density more. When an electrophile is attacking towards electrophilic substitution reaction, right? Whenever an electrophile is attacking here, right? Then it is going to be ortho-para directing, right? Ortho-para directing. Here, whenever an electrophile is attacking, right? Then it is going to be meta-directing. Then it is going to be meta-directing, right? Meta-directing, right? Okay. Next is, ma'am, is this activating or deactivating? So you're providing the electrons to the ring. So this is going to be activating. This is going to be activating. Here you are taking out the electrons from the ring. So this is going to be deactivating. Deactivating. Okay? Activating, deactivating. Very good. CONH2. That also I can write here. CONH2. Very good, students. Very good. Now, anybody who can tell me, ma'am, why you have not written haloalkanes and haloarenes here? Why you have not written X here? Right? Ma'am, that is also lone pair. Because of one very important thing regarding it. Right? Shall just write it here. Yes, we have ample of pages here. Right? Now, exception of halogens. I'll just write it like exception of halogens. Anybody, if you have halogen attached to it, then what are the two effects it is going to show? What are the two effects that it is going to show? If you talk about halogens here, right? 1, 2, 3, this is X, right? It has lone pairs of electrons. So, ma'am, lone pairs of electron, you told that it is going to show us plus M effect, right? So that means plus M, or you can say plus R. Resonance also we take this. R effect, it will definitely show. Just give me a minute. Oof. Okay. Plus M or plus R effect, it is definitely going to show. Then can we say that if plus M or plus R effect it is showing, then it is ortho-para directing, right? It is ortho-para directing, right? And we also know it shows plus M effect and it also shows minus I effect. And I have written BARHI. BARHI. That means resonance is always dominating as compared to inductive. Right? In all the cases, resonance is more dominating as compared to inductive. But in this case, which is more dominating? Yes, very good, Chintu. In this case, which is very good, very good. Pranavi, very good. Minus I effect, minus I. Ashil also very good, very good. So this is also true, but ma'am, the exceptional cases, minus I will dominate here. That is why this is going to be a deactivating group. Deactivating group. Okay, this is going to be a deactivating group. Now here, based on this, if I ask you one question, that this is OH and this is and this is Cl, which is going to have more rate of reaction towards electrophilic substitution reaction, which is going to have more rate of reaction. Anybody in the chat box? Which is going to have more rate of reaction based on these. This is what I have told you. Based on this, let us see how many of you are able to answer this. How many of you are able to answer this? Let us see that. Let us see that. Yes, students? Very good. What is the correct answer? Let us see how many of you are able to answer this. I'll just type here, this is A and this is B, right? Let us see how many of you are able to answer this. Okay. Wait a minute. Sure. Let us see how many of you are able to answer this or not. right? Okay. Yes, A or B, A or B. Let us see how many of you. Rate of reaction of which will be more? Rate of reaction of which will be more? Rate of reaction of which will be more? A or B? Ma'am, B is less as compared to A. Okay, 52% of you have answered A. Okay. Now the correct answer is A only. Reason being because this is deactivating group. Both are going to be ortho-para directing only, but this is deactivating, this is activating. Means electron density will be more on this ortho-para position as compared to the haloarenes, right? So answer is going to be A is the correct answer. Okay, understood? These are the kind of questions that you should be throwing, right? Okay. Acha, one more thing regarding resonance, that is the stability. You know, the questions are also asked based on the stability of resonating structures. Stability of resonating structures. Resonating structures. Okay, now tell me the stability of resonating structures here. The stability of resonating structures here. Tell me one thing. If they have given you 3-4 structures, they are asking you least stable and maximum stability out of them. So answer will be, first is, you will see that which is neutral. So always remember, neutral species is more as compared to any charged species, that is more stable. Let's say, ma'am, neutrality or they all are charged here. Then what you will do? Then you will see that number of pi bonds. More the number of pi bonds, more will be the stability. Let's say number of pi bonds are also same. Then what you will see, if number of pi bonds are also same, then what you will see? Everybody, if number of pi bonds are also same, then you will see negative charge along the period and down the group. And down the group is stable. And down the group is more stable. And down the group is very stable. Okay, negative charge along the period and down the group is very stable, right? If ma'am negative charge is also same, if to talk about the example here, let's say you have O negative and in one case you have S negative. Now that is the reason sulfur will be more stable, because down the group also negative charge is more stable, right? Okay, next we have fourth is charge separation. Charge separation is inversely proportional to the stability. Is inversely proportional to the stability. That is, let's say you have this carbon, this carbon, this carbon, this positive and negative charge. Let's say you have this carbon, this is positive and negative charge. Less distance, less charge separation means stability will be more here. And one more thing, if same charges on adjacent position, then that is going to be, if same charges on adjacent position, then that is going to show you, wait a minute, yes, my UCD regarding the handwriting, if same charges, okay, on the adjacent position, then what you will write? You will write that it is less stable. It is very less stable. Let's say you have carbon and carbon, both are positive and positive. That is not at all stable. You have nitrogen and carbon, both are positive and positive, not at all stable, right? So that is going to be very unstable here, right? Okay. What tricks you want? Do you think with tricks you will be able to solve like everything, beta? No, don't fall into that thing. Always tricks cannot save you always. These are tricks only. You need to know the short notes, okay? Rather than going through tricks, in some ways tricks are applicable, in some ways tricks are not at all applicable, not at all useful for you. So I would not advise you for that, right? Okay. Here it is inversely proportional. So sorry. Yes. It is inversely proportional. By mistake, I wrote this. So this will be inversely proportional. More charge separation. If same charge is on adjacent position, that means it is least stable out of all of them. Right? Okay. Yes, Preeti, Ashley, Chintu, Sarvesh, everybody. Is that correct? Right? Good revision going on. Good revision. Everybody, good revision going on. So, next one is we have covered resonance also, hyperconjugation also, aromaticity also, inductive also. Last one is the back bonding. Let me know if we are left with anything else. Last one is back bonding. Back bonding. Okay, one more thing about resonance. Okay, some of you might be confused about, ma'am, which will show resonance, which will not show resonance. So directly what you need to know. First is if you have alternate double single bond. Alternate double single bond. That will show you resonance. Second is if you have these four categories, double bond, single bond, lone pair, double bond, single bond, free radical, double bond, single bond, positive charge, double bond, single bond, negative charge. Okay, these are the four categories that will show you the resonance here. Right? These are the four categories that will show you the resonance. Let me know if you want me to draw the structures how you are going to convert this. Right? Okay. But right now I am writing the notes for you. Right? I'll send it after the class. Right? Okay. Don't worry. That will be provided to you. Single bond. Let's say you have a negative charge here. So negative charge, what will happen here? Lone pair electrons will jump here. It will jump here, and the answer will be. You can see, because I know some of you are very confused about that, ma'am, how to do the resonance, right? So that's why I'm doing it here. Negative to bond pair to negative, bond pair to negative. So it will be C, single bond C, this is double bond, and this is the negative charge over here. Right? Okay, that is the first answer. Then you have C double bond C, this is C, this is free radical. Now what you will do? In case of free radical, simple thing is, this will jump here, right? Okay. There will be homolytic cleavage over here. So what will happen? C, and this will be one free radical over here. This is single bond. This is double bond here, right? Free radical to bond pair to free radical. Like you have negative to bond pair to negative, right? Next one is for if you have a positive here, right? In that case, what will happen? Because positive is totally empty, so it cannot jump anywhere. So what will happen? This pi bond, pi electrons will only jump, right? So this pi electron will jump here. This is C, this is C, this is double bond, and there will be positive charge over here. Always remember that the nucleus are going to be on the same position. It's the pi electrons will change, right? Then what you will have in the last part? This one is C, C. This is a double bond C. This is C, positive, negative. And let's say here you have this thing. Let's say here you have negative charge. We are left with the lone pairs. Let's say you have lone pairs here. Then what you will do? Lone pair to bond pair to negative charge. Okay, this last one is very important. 1, 2, 3. Double bond will be here. It will be positive charge here. And here you will have a negative charge. Okay. Oops, ma'am, here the ma'am lone pair is not possible. So I'll just write X here. Right. Okay. Understood, everybody? Huh. Now, the last kind of resonance is in the back bonding. Okay. So I'm writing the last kind of resonance, that is back bonding. I'll just directly write back bonding. Back bonding is also very, very simple. What you need to understand here is back bonding is that there should be one species which is electron deficient, other should be electron rich, right? So for example, you have, let's say you have this halogen and this is C positive. Now we know that halogen is lone pair. So this is electron rich, this is electron deficient. It will give off the electrons here and you will have C double bond, this is X positive. This kind of species will be formed here. Or I can also write something like this. Let's say you have a carbon ion. This is electron rich and you have boron here. Now we know that boron is electron deficient. So again, this is possible to donate the electrons here, right? So that you should understand that which is electron deficient and which is electron rich. If one is electron, oh my God, wait a minute. Oh, I'm so scared of lizards. I thought there is some lizard over here. Oof. I know I hate lizards. I'm sorry, guys. I know you love bio, but I genuinely hate lizards. I don't know why. Relax. I just saw a lizard over here somewhere. Okay. Now, if you see, this is electron rich, just that there should be two pairs. One is electron rich and other is electron deficient. Okay. If that is there, that is called back bonding. If that is there, that thing is called back bonding. Is that clear? Is that clear, students? Everybody? Now we have done GOC, right? Okay. Now I'll show you the first thing that we did here. That was Barhi. Let's jump to the first page, right? That was Barhi, right? Now if you see Barhi, first you will see back bonding, then you will see aromaticity, then you will see resonance, then hyperconjugation, then inductive effect. That is how you're going to answer these questions, okay? But remember, I'll just write one important thing here. Always remember, mesomeric effect is not applied in at meta position. At meta position, mesomeric effect is not applied. Always remember this, right? So if you have NO2 group at meta position, there will be no minus M effect here. That's not possible, right? Okay. You can also write it over here that where we did resonance, here you can also add NO2, right? That is a very important minus M group, right? Okay. Now, once we have done this, next part is rearrangement of carbocation. Okay, rearrangement of carbocation, that is a part of GOC, you can say, right? Rearrangement of carbocation is very important. You should know that. Ring expansion, ring compression, you should know that, right? Okay, rearrangement of carbocation right? Rearrangement of carbocation, how we will write that, okay? Simply what you have to do for rearrangement of carbocation, students, first you have is C positive here. This is the carbocation that you have. This is carbon. This is, let's say I'm drawing, this is the priority order of the shift, okay? So this is based on the stability of the carbocation, okay? So let's say you have this positive here. This is CH2. This is CH3. Okay. So now what you will see, I'll just draw it here. C positive. This is CH2. This is CH3. Okay. Now here what you will see that this is a primary. If you complete the electrons also here, 1, 2, it will be CH2. Right? Understood? Now here we know that this carbocation is primary, right? This carbocation is primary, right? And always remember the stability of carbocation is matters, right? Stability of carbocation is 3 degrees, then you have 2 degrees, then you have 1 degree. That is the stability of carbocation, right? So here that is the reason from the alpha carbon, one hydride shift will be there. One hydrogen will shift here and this will get converted to CH3, CH positive, and this is CH3, which is a 2 degree carbocation. Okay, which is a 2 degree carbocation. Okay, Understood? Yes. So that is a 2-degree carbocation that you should remember. Next thing is, ma'am, okay, this is a 2-degree carbocation. Then what next we have to do here? Right? 2-degree carbocation we have already done here. Right? Then, for example, this is okay. So I'll just talk about. Okay, I'm just drawing something random here. This is positive. Now you tell me, will there be any rearrangement? Will there be any rearrangement or not? We know that this is a 2-degree carbocation, right? And what if one hydrogen is shifted from this position to this position? Then what you will see, this is oxygen. This is positive over here. This is nothing, right? Okay. So here you can see this is 2-degree plus there is one back bonding in this case, right? Plus back bonding. We know that back bonding is going to make it very stable. That is the reason rearrangement will occur in this place as well, right? Okay. Yes, everybody. Very good. Preeti is saying 250 plus likes. Let us see how many likes you have given till now. 206. Let's make it 300 plus likes before you complete organic chemistry, right? Okay. So this is 2-degree plus back bonding. So it's not only that you will see, ma'am, that this is 3 degrees more stable than 2 degrees than 1 degree. You have to see the stability of carbocation. According to that, you will do the rearrangement. Okay. Next is, let me just copy paste this slide as well. I'll just, I think, copy paste 3-4 slides here because 2-3 topics from GOC, they can directly ask you in the reactions also, okay? So that automatically becomes very, very important for you, right? Okay. Next is, we have this thing also. Next is ring expansion and ring contraction. So I'll just draw ring expansion and ring contraction here. Let's say you have ring expansion. Ring expansion, these are the topics that they will not ask you directly. Rather than there will be some question where there will be a formation of carbocation. From there, they can ask you this thing, ring expansion and ring contraction. This is ring contraction. Okay. You might feel that, ma'am, like this topic is tough, ma'am. They will ask this. Trust me, this is not at all a tough topic. This is a very, very simple topic. So if you see this here, ring expansion, let us see whenever the ring expansion will be there. So a positive charge will be outside the ring, right? That means something like this might be there. Let's see, you have this 1, 2, right? This is positive. This kind of situation is there, right? So now what can happen here? Let's say this is 1 carbon, this is 2, this is 3. Simple thing is you have to join this 1 and 3, right? And then you have to break this 2 and 3. So what we will do? This is 1, 2, 1 and 3 will be joined, 2 and 3 will break, and positive charge will be on the second. So what I'll write here? Simple thing is that will be applied in both the cases, right? So join 1 and 3, break the bond of 2 and 3, right? Then attach positive on 2. This is what you have to follow here and here. In both the cases, the same thing you will follow. In this case, positive charge will be on the ring. Positive on ring. When the positive is on ring, the ring will contract. Okay. So let us see how the ring will contract. Okay. Let's say here you have 7-membered ring we can draw. Let's say you have this kind of situation, okay? This kind of situation we can talk about, right? Now, remember that if you talk about 3-membered, that is more stable because this thing is showing dancing resonance. So dancing resonance means this is stable. So we can we can convert it into this. Otherwise, we know that out of 4-membered, 5-membered ring is more stable as compared to 4-membered. Right? That is why 4-membered was converted to 5-membered. Right? But if you have 4-membered ring, can you convert it to 3-membered? Yes, because 3-membered ring, because of dancing resonance, is more stable. Right? Then, for example, you have this kind of structure where you have positive charge on it. Now tell me, should you convert it? Should you expand it? Sorry, should you contract it or not? No, because this will be converted to 5-membered. So it's not possible. And then positive charge is on the ring, you can only contract it. It is not possible. 6-membered is more stable as compared to 5 and 7-membered ring. Right? So 6-membered will not be either expanded or contracted. Nothing will happen to 6-membered ring. Right? Okay. Now let us see this thing here. This is 1, 2, 3. This is 1. This is 2. This is 3. Now what you have to do here is join 1 and 3, break the bond of 2 and 3, right? Join 1 and 3, break the bond of 2 and 3 here. So this is 1, 2, this is 3, and here you have to attach it. That means it is going to be this kind of situation, which is dancing resonance, which is more stable, right? Okay, understood or not? Yes, everybody understood? Again, we have done the same thing. Join 1 and 3, break 2 and 3, attach positive charge on 2. Join 1 and 3, break 2 and 3, attach positive charge on 2. The same thing we have done here as well. Right? Okay, students, so is that clear to everybody or not? Right? Okay? Yes, everybody? Now, yes, ma'am? Okay. Next is we have done ring expansion. These things they will not ask you directly, rather they will ask you this thing whenever there is formation of any carbocation that I am going to show you in the reactions where there will be formation of carbocation. All the important reactions I will show you. See, there is no point if you cram the reactions but you have no idea that what you will, like what kind of answer will be there. For that you should know these things, right? Now next is isomerism. In isomerism, I'll tell you some general things here. In detail, lecture is obviously there. So I'll tell you the direct what you have to remember in the exam, right? Okay. So firstly, there is structural isomerism. Now tell me what are the different structural isomerism that you have. These are very simple to identify. So structural isomerism, firstly I'll write structural isomerism. Right? In structural isomerism, you remember one thing, that in structural isomerism there is a chain isomer where parent chain should be different. There is the second one is first is chain isomerism, then there is position isomerism where the position of functional group should be different. Then there is functional group isomerism where the functional group is different altogether. Fourth one is functional group is different. Fourth one is position we have done. Then there is metamers. In metamers, you have this kind of situation, this some ring and this some this. This is the bridging group out there, bridging functional group. This R and this R dash in that different part, let's say this is R double dash and this is R triple dash. So that means all of these alkyl chains should be different if these are metamers of each other, and this metamerism they ask. Right? Chain position functional group, very rarely they will ask you this. They will ask you metamers here. Next is tautomerism, which is very important. That's the reason I took out this page, tautomerism. In tautomerism, remember that there is two important things, that there should be alpha carbon, which is sp3, and alpha hydrogen. At least you should have one alpha hydrogen. At least you should have one alpha hydrogen here. Right? Now, how the tautomerism is going to work? For example, you have C double bond. I'll just draw it here. C double bond O. This is carbon. This is carbon. Right? What will happen? Let's say you have a alpha hydrogen here. What will happen in tautomerism? This is 1. This is 2. This is 3. What you will do here? 2 and 3 will have a new bond formation. Okay, so I'll just write it, everything else the same. 2 and 3 will have a new bond formation, right? And here this bond will break and this will be converted to OH. This is keto form, this is enol form. This is keto form, this is enol form. Okay? Now, yes. Acha, I forgot about ring chain isomer, is it? Yes. Fifth one is ring chain isomer. Ring chain isomer means one you will have a cyclic ring, right? And other will be a chain. Mostly it is alkene and the cycloalkane ring, right? That has the same formula, that is CnH2n, right? Okay. Now see one more thing here whenever you are doing this tautomerism. One thing to remember, these are the conditions. They can ask you one kind of question, which of the following will show tautomerism, which of the following will not show tautomerism. From this you can answer that. Other is to conversion of enol, you can answer this. Now the last part is, you should remember that two things can happen. Either you can have alpha carbon, that is sp3, or it is sp2. Either you can have alpha carbon, which is sp3, or it is sp2, right? If let's say the alpha carbon is sp3, then you have to check that this is, I'm talking about the third carbon, right? Third carbon, right? That is from this oxygen, I am talking about the third carbon. If that third carbon is sp3, it will have alpha hydrogen or it will not have alpha hydrogen. If it is not having alpha hydrogen, wait a minute, I'll just write it here. No alpha hydrogen. If it is not having alpha hydrogen, tautomerism, it does not show. If it has alpha hydrogen, tautomerism, it will show, right? Then there is this thing, that if, let's say here, it is sp2, third is sp2, then you will look for the fifth carbon, right? Then you will look for the fifth carbon. Fifth carbon, if that is sp3 and that is having alpha hydrogen, then it will show tautomerism. Okay? So one is 1,3, other is 1,5. So if 1,3 is only possible if third is third is sp3. 1,5 is only possible if third is sp2. And 1,5, the fifth carbon has sp3 and alpha hydrogen. Okay? Understood? Yes, everybody? That's it. And one more thing, this is very short, I am telling you regarding the important parts here, right? One is, you should remember that GI, the standard question, I am picking out, it's a very big topic. Isomerism itself is a very big topic. But I don't want to see, if you want to go into detail, you have a separate lecture for isomerism, right? But the important topics which are easy also, that I am picking up from isomerism. First thing is, they can ask you, geometrical isomerism exists or not? Geometrical isomerism exists or not? This they can ask you, right? For that, what you have to remember, very simple thing. This is a C double bond C, right? This is 1, this is 2, this is 3, this is 4. Just remember, if 1 is not equals to 2 and 3 is not equals to 4, only then GI can exist. Then GI can exist, right? That is a very, very simple question that they can ask you. You can answer this question in seconds, okay? That's why I picked up these. Now, you know what? GOC I told you in detail. Reason is because if you are willing to do GOC, then you can easily answer 3-4 questions from there. Now, isomerism is like maybe one question they can ask you out of it. That's why I'm not giving that much importance to isomerism. Yes, I am picking out those questions which short can be there. One is GI. Other is this simple thing you can easily answer. Then there is tautomerism that they can easily ask you. Right? Now, what is cis and what is trans? If you see that you have same group opposite, and if you see that you have same group side by side. You have same group side by side, right? So this is your trans form and this is your cis form. And this is your cis form, right? Then if you see, ma'am, how to calculate E and Z, right? Okay. So E and Z, just remember that. E and Z, I'll just tell you one simple thing here. E will be where you have opposite, and Z will be where you have on the same side. So this will be solved according to CIP rule. Okay, this will be solved according to CIP rule. This will be solved according to CIP rule. What is CIP rule? That atomic number, more the atomic number or more is the mass, that will the priority will be more. Right? Okay, the priority will be more. I'll give you one example here. Right? If you have C double bond C, this is, let's say, this is C double bond OH, this is hydrogen, this is fluorine. Let's say this is chlorine and this is CH3. Right? So here how you can easily answer? First you will give priority to these two, then you will give priority to these two. This we know that hydrogen has less atomic number, the priority will be 2. It has more, so it will be 1. Over here, this is carbon and this is also carbon. But next to carbon, you have double bond oxygen, and here next to carbon, you have hydrogen, which is less priority. So this will have 1, this will have 2. As you can see, 1 and 1, same is opposite. That means same group is, same priorities on the opposite side. So this is going to be a E isomer here. Directly, very simple questions they will ask you from Z and E, not very complicated questions they will ask you here. Right? Last is confirmers here. So for confirmers, just remember one thing. Yes. Just remember one thing for confirmers, number of stereoisomer or optical isomer or geometrical isomer. The formula is 2 raised to power n. In case of geometrical isomer, n is C. If they ask you geometrical isomer, I am talking about the asymmetrical. Right? You will say, ma'am, why you are not telling us the different formulas? What is the name of the session? 100 plus. And here we are discussing only the topics that are frequently, that they can sure shot ask you. So if you are thinking of skipping this topic, don't skip this. At least just remember 2 raised to power n here. Why I am asking you to do that? Because very simple question they will ask you from here. Not very complicated questions. And they will sure shot give you unsymmetrical only. If they give you symmetrical, that becomes a very difficult question altogether. So many formulas are involved. But for unsymmetrical, it's just one formula, that is 2 raised to power n. Just remember this thing if you are thinking of skipping. If you are not thinking of skipping, then do the full part. If you are thinking of skipping this part, at least do this part, because this has been asked in JEE Mains this attempt. So directly they can ask you the same question in NEET also. Right? So here for SI, what you should remember, if you talk about the number of stereoisomers, if they ask you, N is equals to number of GI sites plus number of chiral sites. Okay. For geometrical isomer, N is equals to number of GI sites. For optical isomer, N is equals to number of chiral sites. What is chiral carbon? Which is sp3. Let's say I'm giving you one, one question here based on this. Let's say you have something like this. You have C. This is 1. This is 1, 2, 3. Right? Chalo, I'll not draw it like this. You have 1, 2, 3, 4. This is double bond. Right? Okay. And this is, okay, last one. This is the double bond. This is one Cl. Right? Okay. Now you have to answer what is the number of stereoisomers here. Okay. Number of stereoisomers. Beta, these kind of very simple questions will be there. Now, trust me, this was the kind of question that they have asked in JEE this attempt. That means in NEET also they can ask the same kind of question. Okay. Okay. I'll definitely drink water. Don't worry, Preeti. Thank you. Thank you for your concern. Now, if you see, this is the double bond. This is the double bond, right? Here you have 2 hydrogens. That means this will not show you GI. So you can't calculate this double bond. This has this bond and this thing, this hydrogen and this thing. That means 1 and 2, the condition of GI was this thing. 1 and 2 should be different, 3 and 4 should be different. That means this is the geometrical isomerism site. And this carbon Cl is different, this group is different, this is different, hydrogen is different. That means this is a chiral center. So we can say N will be equals to 1 plus 1, that is 2. Right? So stereoisomers will be 2 raised to power 1, 2. That is going to be 4 is the correct answer. Okay? Stereoisomer is going to be 2 raised to power 2. That is 4 is going to be the correct answer here. Is that clear to everybody or not? Right? Don't worry, beta. Today we are going to do less questions. I am going to focus on more on the revision of important topics and some questions. Right? But don't worry, next 1 week we are going to do only questions. There will be no theory that I'll take in the next class, in the next classes. Okay, just give me a second. Okay, now let us see this thing here. That is the conformers. Now for conformers, full part let not discuss. Firstly, let us discuss about cyclohexane. In cyclohexane, just remember one thing. The conformers, you have different kind of conformers here. Right? Okay. Just remember CTBH. Just remember the stability order. That will be enough, right, for you. If you want to see the direct question, you know why I am saying that touch all the topics. What basically right now I am doing is I am touching all the important topics here, right? Because I know if you get into detail of cyclohexane, that is a very lengthy topic. But chances are they will ask you only the stability order. So at least you should know that, right? What if the same question they ask you and you get full marks, you have not done the full revision of cyclohexane, but still you are able to answer it. That is the smart revision, okay? So here that means first is chair, right? Then you have twisted boat, then next is boat, right? Last is half chair. Last is half chair. Last is half chair. That is the order of the conformers, right? Now always remember, if you talk about simple alkenes, right? If you talk about alkenes, right? Here, remember that always what is going to happen, anti is going to be more stable. So firstly, I'll talk about what is anti and what is this. So let us say you have this thing, 1, 2, 3. I'm just going to focus on the stability here, okay? Because directly on stability, very standard questions they ask based on stability, okay? Just give me a second. Okay. So basically what you have to remember here is, if let's say both back and the front carbon are overlapping, if they had angle, right? If again they are overlapping, if again they are overlapping, if again they have angle. I'm drawing for ethane. This is CH3, this is CH3, H, H. I'm drawing for butane. This is CH3, this is CH3, H, 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 H. This is again CH3, This is CH3, this will be CH3, right? This is H, 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 right? This is again CH3, this will be CH3. Now, if you see this here, this is going to be eclipsed. This is going to be gauche. This is going to be half eclipsed. This is going to be anti, right? In usually what you have, anti is maximum stable, then you have gauche, then you have half eclipse, then you have eclipse, right? Okay. These things in case of, if you talk about ethane, in that case, if in case of ethane, you have eclipsed and staggered. I'll just draw for ethane also. Firstly, I'll just write it here. I don't have any like area to draw it somewhere, right? Okay, chalo, I'll just write it here, right? In this case, we know that gauche is more stable, No, anti is more stable as compared to gauche. Okay, anti is more stable as compared to gauche. But what if you have hydrogen bonding here, right? But if you have somewhere hydrogen bonding, let's say this is the gauche structure, right? These are the two structures that you have, right? Here, what if you have something like this? What if you have something like this? See this. It is antis like this because they can ask you the gauche effect here directly. Okay, so this is also having angle, right? So what if here you have, let's say, OH, and here also you have OH. Here also you have OH, and here also you have OH. Now if you see here, there will be hydrogen bonding, and that is the reason in this case gauche is more stable as compared to anti. That is called gauche effect. That is called gauche effect. So based on the gauche effect, they have asked you question that which will be more stable. Remember, always anti is more stable as compared to gauche. But in this case, gauche will be more stable as compared to anti because of the hydrogen bonding, that is called gauche effect. Right? Okay. One more thing here, if I can draw it over here. I know I have very less space, right? But still, I'll try to draw it here. Right? If you see this thing here, for ethane, okay, for ethane simply I am drawing, right? For ethane, one will be staggered, okay. Here we have split it staggered into gauche and anti. Otherwise, there is just simple thing that is staggered where you have opposite and one is eclipsed when it is overlapping, right? In staggered, this is hydrogen, hydrogen, and this is hydrogen and hydrogen opposite. So always remember in these kind of cases where you have one anti and one staggered, staggered is more stable as compared to eclipsed. Again, because of the repulsion. Okay, right? Okay, students. Staggered is more stable as compared to eclipsed, but here we have divided staggered into gauche and anti. In this case, anti is more stable. If you have hydrogen bonding, gauche will be more stable. Got it? Okay, that was the overall conclusion part of your conformers, right? So all the important things regarding GOC I have covered, right? In 1 hour, I have more than 1 hour I have covered GOC. That is a big deal. Even if you do this much from GOC, that will also give you like full marks, right? If no weird question they ask. Because here in today's lecture, we are only talking about the important topics, the short topics of chemistry. So that I have covered from. In fact, more than short topics I have covered, right? Not only some chintu-mintu topics I have covered, right? Really good topics we have covered. Oops. Where are you going, bro? Now, I think my arm will get some relaxation. GOC, I wanted to do it like by myself because I know you guys find it very tough. Now let's talk about the naming reactions and the important reagent part. So here I have not picked up all the reactions, right? I have picked up only those reactions that are continuously asked and only those reagents which are continuously asked to you in the exam. Continuously, that is must to do, right? In fact, from this doing GOC and this part, you can feel that okay, 1-2 questions maybe are not under this category because 1-2 question they can ask you some different question. See, in an exam, most of the questions will be repeated or simple only, slightly molded version. But at least 1-2 questions can be there, or 3-4 questions can be there, which are totally out of the box, right? For that, definitely you should have clear conceptual knowledge of everything, right? For that, it's not happening in, let's say, 4 or 5 hours. But if I can guarantee you 130 plus marks, 120 plus marks, then these are the topics that you must do, right? Okay. If predictable paper they ask, then definitely you can even get full marks in the organic chemistry, right? So let us start. If you guys are ready for reactions, then green hearts in the chat box for the organic chemistry reaction part. Okay, everybody? Let us complete the reactions part. After that, we are also going to do some questions based on that. Right? Okay, students? Is that clear? Yes? Okay, ma'am. Now let us see. First thing is naming reactions. I am going to start. First thing is Wood's reaction, right? In Wood's reaction, you have Rx, you have Ne, you have Rx. So here what you're going to do, you're going to take out NEX from here and you will have the formation of ouch. And you will have the formation of RR here. That will be through free radical mechanism. Okay, that will be through free radical mechanism, right? Okay, that you have to remember. Then here you use free radical mechanism. Mechanism you can learn or not, that's totally your choice. But free radical mechanism, it should be there in your head. Then it is symmetrical, and even number of carbons are only formed. Unsymmetrical alkanes are not formed in this case, right? Next part is Wood's fatigue reaction. See, you can understand Wood's by alkyl, and you can understand fatigue by aryl. Okay, so this is alkyl, just a way. Wood's fatigue means one is alkyl, one is aryl. Then again you take out NEX from here, you will have the formation of benzene, and over there you will have R, right? Then here fatigue means both will be aryl, so X and Na will be eliminated, and two benzene rings will together, they will form diphenyl, or you can say biphenyl will be formed here, right? Okay, very good. Next is naming reactions here. Naming reactions only we are doing. Soda lime decarboxylation. In this case, you will have RCOONA, but remember that in the answer you will get RH here, right? From RCONA, you will get the formation of RH in the presence of soda lime. So this is the caustic soda. This is caustic soda, and this is quick lime. So from there we got it that it is soda lime decarboxylation, because this carbon dioxide is getting eliminated from its position, right? And this is there is a formation of carbonyl here. So the intermediate is carbonyl. So if they ask you the rate of reaction, that is dependent on the carbonyl, right? Stability of the carbonyl, right? Okay. So in that case, you have to remember that whenever they ask you in soda lime decarboxylation, what is the rate of reaction, just see the stability of carbonyl that we have studied from GOC, that how to tell the stability of carbonyl, right? Next is Coles electrolysis. So in Coles electrolysis, again you have RCONA, but here you have the formation of RR. Okay, remember that in soda lime decarboxylation, you have the formation of RH. Here you have the formation of RR, right? Now here you have free radical mechanism. Always remember the mechanism is again free radical mechanism. So the stability will depend upon the free radical that will be formed here, right? Okay. One more thing to remember in Wood's reaction and this reaction is that, for example, they have given you something like this. This is for Wood's reaction, or let's say for Cole's reaction, they have given you something like this. In both the cases, you will have the formation of this kind of free radical, right? Now, whenever you have a free radical, two things can occur. One is intra, one is inter. Always intra is preferred over inter. So that means always intra is preferred, means always this thing will be preferred here. This thing will be preferred. But because here intra, right, intra is unstable. This is the anti-aromatic compound. Anti-aromatic compound. So this will not be preferred, rather this will be preferred. This is intra, this is inter. What I am telling you, always intra is preferred over inter, but because here intra is unstable and it is anti-aromatic, if your intra comes out to be anti-aromatic, in that case you will follow inter, right? Okay. Yes. Okay. Next is Reed's reaction and Darzan reaction. They are quite similar, right? So in Reed's reaction, you use SO2Cl2. That means you are using sulfuryl chloride. Sulfuryl chloride. And here you are using thionyl chloride. Thionyl chloride. Okay. Now, here you have CH4 and here you have ROH. Products are going to be same, that is RCl, SO2 and HCl. Products are going to be same here. The difference is in the reactant and the difference is in the reagent. Here you are using hydrocarbon, here you are using alcohol, right? That is the difference here. Next is Lindlar's catalyst and Birch reduction. That means from alkyne, how you can prepare alkene. So if you are using Lindlar's catalyst, that is you are using H2 in presence of a catalyst, that is PD. And here you are using a poison. Okay, these are the poisons. Poison means you want to reduce this reaction. Otherwise, in catalytic hydrogenation, directly from alkynes, you have the formation of hydrocarbons, that is alkanes. But here, when you use a poison, this will stop at the alkene part, and Lindlar's catalyst is going to give you cis alkene. But if you use Birch reduction, right, you use sodium and lithium in liquid ammonia, that is going to give you trans alkene. Okay, so Lindlar's is going to give you cis, and Birch reduction is going to give you trans alkene. That is the difference here, right? Okay. Next is Birch reduction in case of aromatic carbons, hydrocarbons. So here remember that one pi bond will break and two double bonds will always be opposite to each other. So here one pi bond will break and any two double bonds will be opposite to each other if you have a simple aromatic benzene ring, right? Let's say you have an electron donating group. So we know that if someone is donating something to us, we would want to stay with them. So this double bond, that means the double bond next to it will stay as it is, and one of the other double bond will break and you will have a double bond opposite to it. So you can either have this thing or you can also have this thing here as the answer. This is electron donating group. This also can be answered. The condition is the double bond that is remaining should be next to the electron donating group. If you have, let's say, electron withdrawing group that is taking out electron, here if someone is taking out something from you, you would not want to stay with them. That's why this double bond will not stay with them, and hence you will have this double bond will be one position after it. So double bond, two double bonds are always opposite in the Birch reduction, that you have to remember, right? Okay. Next is the hydration of alkenes. So based on hydration of alkenes, what you have? Acidic hydration, hydroboration, oxidation, oxymercuration, demercuration. Acidic hydration is when you are like preparing carbocation from here, right? In this case, the answer will be first you will prepare carbocation, then there can be rearrangement or there can be ring expansion or contraction. Then you will attach OH negative on this. That is acidic hydration. If you have hydroboration oxidation, in that case, you will use anti-Markovnikov rule. That means negative charge on the negative charge on the more number of hydrogen, right? If you're using oxymercuration, demercuration, then negative charge will be on the less number of hydrogen, right? That is the important part, right? That is the important part, right? Next is Groves process. So Groves process is basically when you have Lucas reagent, that is ZnCl2 anhydrous, ZnCl2 and HCl. This is actually a distinguished test of 1 degree, 2 degree, 3 degree alcohol. So here you have the turbidity formation. 3 degree alcohol has maximum, then you have 2 degree, then you have 1 degree, 3 degree, then 2 degree, then you have 1 degree. So what you can write here, that 3 degree alcohol instant turbidity will be formed, right? Here you will have turbidity after 5 minutes, right? Here you have instant turbidity, here you have turbidity after 5 minutes, and this is 30 minutes, and that too after prolonged heating. Right? That too after prolonged heating. This they can ask you that which of the following shows maximum turbidity. So according to 3 degree, 2 degree, 5 minutes, you can say that which will show you maximum turbidity here. Next is the two halogen exchange reaction. First is Finkelstein and Schwarz reaction. So both are halogen exchange reactions only. You can write here, these are halogen exchange reactions. Halogen exchange reactions. Both you will use Rx. X can be chlorine or bromine, right? So here when you're adding NaI and dry acetone, then this X will be replaced by iodine. When you're adding any inorganic fluoride, then this X will be replaced by fluorine here. That is called Schwarz reaction and Finkelstein reaction. Next we have is Williamson synthesis reaction, very, very important reaction. All I have picked it, you will see all of these reactions in your previous year questions, okay? So Williamson synthesis reaction is when you have Rx and you have NaOR. So here Na and X will be eliminated and you will have the formation of ROR, that is ether, right? But here they can ask you which of the following shows Williamson synthesis reaction, or which of the following cannot show Williamson synthesis reaction. So condition is that alkyl halide should be primary. For example, you have any reaction like this in which alkyl halide is, let's say, tertiary. In this case, and let's say you have this NaOCH. This will not show this reaction and your alkyl halide is 3-degree alkyl halide. So that is not possible if your alkyl halide is tertiary. This will have no reaction here. That is the important part here, right? That is the important part, that primary, the halide, alkyl halide that you are using here should be primary. Okay, this should be primary. Okay, only then this reaction is possible with ease, because this is a SN2 mechanism. It is having a transition state. It is having a transition state, right? So that is why according to steric hindrance, we know that 1 degree, then 2 degree, then 3 degree is preferred over here, right? Okay. Understood everybody? Yeah. Okay. Yes. Ether synthesis reaction. Next is with this only in ether, there are two kind of questions. One question is from Williamson synthesis and other is from concentrated HI. So if you see concentrated HI here, this is ROR and this is RI. So that means either this bond or this bond will break here, right? Okay. Now there are some important parts to understand in this HI reaction, that if you have R and R dash are primary, then it is SN2 reaction, right? That means where iodine will be attached to that part where less steric hindrance will be there. Because SN2 means this is according to transition state, it is according to steric hindrance, right? So iodine will be that which is having less steric hindrance, okay? So here, let's say both of them are primary. Both of them are primary in that case. If one of them is tertiary, then SN1 reaction, that means it is carbocation. Then in that case, iodine will be attached to more stable carbocation, that is where you have more stable, that is 3-degree carbocation will be your iodine in this case. Okay, let me just take out one example here. Let's say you have something like this, CH3, 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 O, CH3. In this case, when you add HI here, one of them is 3 degrees, so iodine will be attached to 3 degree. So here answer will be, this will be formed from I and this is CH3OH, right? Okay, that will be the answer here, right? Okay, this is how you are going to react with HI. But let's say you have a compound, this is O, this is CH3, this is CH2, this is CH3, right? In that case, what you will see, I is attached to where less steric hindrance will be there. None of them is 3 degree. So I will be attached to less steric hindrance. Less steric hindrance is over here. So this will be OH and this will be CH3I. Okay? Understood everybody? Right? So this is how you're going to have the reaction with HI here. Right? With HI, this is how you're going to have this reaction. Next is diazotization. So here what will happen? NH2 will be converted to N2Cl in the addition of NaNO2HCl, or you can say HNO2, right? Okay, that is diazotization. But after this, if you warm it, let's say if you warm it, it will be converted to alcohol. It will be converted to this OH, that is phenol, right? But if you see, you have R NH2 here. Let's say you have alkyl amine, right? So in that case, if you are adding HNO2 between 0 to 5 degrees Celsius only, in this case, what will happen? You will have the formation of RN2Cl, which is very unstable even at very low temperature. That is the reason here you will have directly the formation of ROH. You don't even need to warm it. You can directly have the formation of ROH here, right? Okay. Steric hindrance means, for example, when you will go for your exam, there will be so many people out there. So more the crowd, more is the steric hindrance, right? Next is from this diazotization, you have 3-4 reactions, very important. One is Sandmeyer's reaction. So in this case, when you add any copper salt, right, then let's say the salt is of chloride, so you will have the formation of chlorobenzene. This salt is of bromine, you will have the formation of bromobenzene, right? Let's say you have the formation of CN here, you will have the formation of CN here, right? You will have the formation of CN here, right? Yes, even at 0 to 5. Very good. So these are your Sandmeyer's reaction. In Getterman reaction, you use same thing, but you use copper powder here, right? So that is the reason here. See, gutter means bad smell. In bad smell, what is there? Bad smell, you need to use powder. So that's why we are using copper powder. Sand means salt, right? Sand means salt. That is why we are using in Sandmeyer's reaction, we are using salt of copper, right? Okay. Next is Ball-Schiemann reaction. So in Ball-Schiemann reaction, when in disonium chloride you add HBF4, you have the formation of chlorobenzene, and this is still here you have Ball-Schiemann reaction. What if to this side you add HBF4 along with NaNO2 along with the copper couple? In this case, you will have the formation of NO2, that you should remember, because these two reactions are quite similar. You can get confused here, but only this reaction is Ball-Schiemann. This is a general reaction with the reagents, right? Next is Hunsteker reaction. Here what you will have the formation of bromide, alkyl bromide, right? You will have silver salt of carboxylic acid. Bad criminals will be there, right? Br2CCl4s will be there, right? And they will take out all the chain, silver chain, everything from you, and you will be left with nothing but bad memories, that is RBr you will be left with, right? Okay. Take care of yourself. Okay, Preeti. Okay, all the best, right? You should charge your phone when you have Diksha Ma'am's class. Okay, next time you should charge your phone. Dow's process. Now with Dow's process, this is very important that in Dow's process, let's say you have Cl, you add NaNO2 at a very high temperature, you are doing this, right? Because this bond is very difficult to break. So this is your C. I'll just write this thing here. This bond is very difficult to break. First is because CCl has double bond character. Double bond character. Second is this phenyl cation is not at all stable. It is very unstable, right? Third is this carbon is sp2 hybridized. So that is why it is very difficult to break, right? Next is, I am writing the important parts here, okay? Next is, here the intermediate that will be formed is, any student, intermediate, what is the intermediate that is formed in this reaction? Any student, what is the intermediate that is formed in this reaction? Anyone? Intermediate that is formed in this reaction. Anybody? Anybody here? Anyone? So intermediate that you have formed in this reaction is benzene. Okay, this is the intermediate that is formed here. Benzene intermediate is formed, right? Okay. Next thing is the NO2 groups here, right? So always remember, if in this condition, let's say electron withdrawing group is at the ortho and para position, conditions will decrease. Conditions will decrease. Rate of reaction increases. Rate of reaction will increase when on the ortho and para position you have NO2 group. At meta, NO2 at meta, no effect, because at meta position you don't have, or ortho and para you have electron density because of the resonance. At meta position you don't have any electron density, so NO2 at meta there is no effect. No effect. Okay? Yes. Next is cumene process. So in cumene process, what you're going to do? You're going to have isopropyl benzene. That is nothing. They can also, this is cumene, and this is also called isopropyl. Isopropyl benzene. Okay, isopropyl benzene. So in isopropyl benzene, when you add air, right, what will happen? This H will be converted to this OOH, right? And then after hydration, you will have phenol and acetone. This question they have asked so many times. What is the final product? That is phenol and acetone is the final product that will be formed here, right? Next is Coles reaction. So next one is your Coles reaction, everybody. Coles reaction and Reamer-Teamer reaction, very important. Coles reaction, you have in both the cases you have phenol. You're adding NaOH and CO2. You have the formation of salicylic acid. Okay, you have the formation of salicylic acid. But if you talk about Reamer-Teamer reaction, you have the formation of salicylic aldehyde. Salicylic aldehyde. Right? And here one thing to remember, if you use CCl4, then you will have salicylic acid here. Then you will have salicylic acid here if you use if you use the CCl4, then you will have salicylic acid here. You will not have salicylic aldehyde here. Right? Okay? Yes, everybody, just give me a second. Okay. Okay? Now, one more question that they can ask you here. In Reamer-Teamer reaction, because of these reagents, the electrophile that is generated here is CCl2. That is dichlorocarbene. Okay, that is dichlorocarbene is the electrophile that is generated here. Right? Sukanya, yes, definitely, yaar. I'll definitely give you a break after this. But for that, I need to see your energy over here. Right? I know you guys are a little bit exhausted, but beta, we have to complete this, right? Let's complete organic chemistry before this, because we are left with only few things, right? Only few reactions we are left with for organic chemistry, right? Kirchhoff's reaction, right? Kirchhoff's reaction. Guys, please show me your energy. Otherwise, my energy is also dripping, right? So this is C triple bond C. So here what you have to remember, that one pi bond will break in this case. I'll give you one more example. Let's you have CH3. This is C triple bond. This is CH, right? This is CH. In this case, we'll form a firstly carbocation that is more stable. So this carbon positive charge over here is more stable as compared to this, because here if you have positive charge, because of the plus I effect, it can stabilize it. So positive charge is stable over here. That is the reason you will have positive charge here, and one pi bond will break and you will have positive charge here, and this will be CH2. This is CH3. After this, we know that what is this thing called? This is called positive carbocation is over here. So this is basically hydration. So on the positive, you will add OH negative, right? We know that this is the enol form. So that is how you use tautomerism. So you add just 1, 2, 3 here. And what you do, convert the double bond of this double bond will be converted to this place. and this hydrogen will be shifted here. So this is going to be CH3. That is the keto form. That is the keto form here. That is the keto form here. Right? Okay. Next is Rosenmund and Getterman reaction. Right? So this is COCl. Rosenmund reaction reduction is when you have COCl. Right? So in this case, when you add Lindlar's catalyst, that is H2PDBSO4. Right? In this case, this HCl is converted to hydrogen here, and you will have the formation of benzaldehyde. Then there is Gattermann-Koch reaction. Koch means CHO. This you can remember. That is why there will be formation of Gattermann reaction is different. Gattermann-Koch reaction is different. So here what you will add? You will add, this is COHCl anhydrous Cl3CO. This will generate a C double bond OH formaldehyde, right? This kind of situation will be there. So formyl chloride it will generate, basically this thing it will generate. From this formyl chloride it will attack here, right? And hence you will have the formation of benzaldehyde in Gattermann-Koch reaction. Okay, next we have is Stephan reduction. Stephan reaction. In Stephan reaction, you have C triple bond N, and only when you use SnCl2 and HCl, what will happen here? SN2 and HCl, it is going to break the pi bond here. So you know that here you have two pi bonds. One pi bond will break, and you will have CH double bond NH. That is imine. After hydrolysis, this whole thing will be converted to double bond O, and hence you will have the formation of aldehyde here. That is also Stephan's reaction. Okay, that is Stephan's reaction. Next is, these are all the formation of benzaldehyde or aldehydic group, right? Itard's reaction is when you have toluene and you add chromyl chloride, which is red in color, right? And you add CS2 here, then what will happen? This will be converted to this intermediate, and after that you will have the formation of benzaldehyde. Because this is T over here, you can remember we will start from toluene. Okay, that we will start from toluene here. Next is Clemmensen reduction. So in Clemmensen reduction, what you will do? You will have C double bond O here. You add zinc. Now there are two things. One is Clemmensen, one is Wolff-Kishner. So in Clemmensen reduction, what you will use? You will use zinc amalgam and HCl. This double bond O is converted to H2 here, right? Okay, so that's how you will have your answer. But here you have acidic conditions. But when we talk about Wolff-Kishner reduction, in this case you have hydrazine and you use ethylene glycol, and same thing. Double bond is converted to H2 here, but here you are using basic condition. You are using hydrazine in this case. Okay, you are using hydrazine here. Now we will talk about some tests here. That first test is Tollens test. In Tollens test, Fehling test, Benedict test, all are basically to convert CHO to COH group, right? But here one thing to remember, in Tollens test you will have the formation of silver mirror, and these are the different compounds that will show Tollens test. One is aldehyde, whether it's aromatic or aliphatic. Formic acid will show, alpha hydroxy ketone will show the test. On the alpha position you have hydroxy, hemiacetal. That means on one carbon you have OH, OR and one R group. That is also going to show this test, right? So usually students know just that, ma'am, aldehyde show this. This they can ask you formic, alpha hydroxy and hemiacetal. These are the three things that you must remember, right? Three things that you should remember: formic, alpha hydroxy and hemiacetal, right? Next is Fehling test. Fehling test, basically you have two solutions, Fehling A and Fehling B. Fehling A is copper sulfate, Fehling B is alkaline solution of sodium potassium tartrate, right? So here you have C, this is OH, this is OH, this is COOH, this is COH, that is tartric acid. If you have, instead of H, you have Ne and K here, this is called sodium potassium tartrate. That is called Rochelle salt, right? Now over here, you should remember the structure here, right? Now, from this solution, you will have CO2 positive, right? Okay. This will be converted, this will oxidize the CHO to COH, and this is converted to brownish red precipitates, okay? In Benedict solution, In Benedict, you have the same thing. Instead of tartrate, you have citrate. Instead of tartrate, you have citrate. Okay, same reaction will be there. The difference is instead of tartrate, you will have citrate. That is the only difference in Benedict. And next difference is in Fehling solution, they can ask you in a statement-based question why we use Benedict solution. Because Benedict solution, you can prepare it before the test also. You can keep it for some time. Fehling solution, you have to freshly prepare it. That is why it is difficult to do the experiment. That is why Benedict is preferred over Fehling. Otherwise, the reaction is same. Precipitate will be brownish red. Only everything is same here. Now, haloform test, usually famous by iodoform test, where you have the formation of CHI3, which is, what is the color of CHI3, students? What is the color of CHI3? I have already given you one hint. What is the color of CHI3? Let us see that in the chat box. What is the color of CHI3? Let us see that if you're able to answer it or not. Let us see that. Let us see if you're able to answer it or not. CHI3 is nothing but it is what color? Yes, it is yellow in color. Okay, it is yellow in color. So what they can do, they can give you a hint that it shows a test where yellow color compound is formed. That means they are talking about iodoform test. Okay, so this is our COO. This is CH3NaOH here. Now, if you see, these are the reagents and it does not affect C double bond C. That also you should remember. Now, what are the compounds that shows iodoform test here, right? So, one is if you have C double bond C, you have CH3 here. This kind of situation will show you iodoform test. Or you have CH3, this is COH and this is H. That will show you iodoform test here. That will show you iodoform test here. Right? Okay? That will show you iodoform test here. That is going to show you iodoform test. Right? Okay? Understood? These you should remember. Then it is going to show you iodoform test here. Right? Next is aldol condensation. Very, very, very important, students. This is very important. So if you see aldol condensation here, right? These are the reagents that you can use. Firstly, let us see how to answer. One thing is in aldol condensation, there should be alpha hydrogen in one of the reactants, right? So I'll directly show you aldol condensation. Cross aldol is the same way, okay? This is CH3, this is C. Let's say this is the first molecule. I'll show you cross aldol only, right? Let's say you have two molecules, different things can happen, right? So you have, let's say, CH3, CH2 and CH2. Now this ethanol can react with itself. This can react, wait a minute, yes. This propanol can react with itself. This propanol can react with this ethanol. Ethanol can react with itself. So many different products can be formed. I'll just tell you one product here, right, to show you that what exactly you're going to do. First, you have to identify any of the alpha carbon. You can use this alpha carbon, both will give you different products, right? So they will give you which of the following is not a product, which is a product that they will give in the reaction, okay? So this is the alpha hydrogen and this is the carbonyl carbon. So you have to join these two things together and what you will have CH3, convert the carbonyl carbon to OH, right? Then join it with the alpha carbon here. In alpha you will have one CH3 and you will have one CH2. Then you take out water from here. Water will be taken as condensation. This is the aldol part. Aldehyde and alcohol. OH will be eliminated. See, this is alpha, this is beta. So from alpha and beta, OH and H will be eliminated. So you will have CH3, CH, double bond C. This is CH3, right? And this is CH. Okay? Understood, everybody? Is that clear? Next is Cannizzaro reaction. In Cannizzaro reaction, what you are going to do? In Cannizzaro reaction, remember that you have C double bond, this is this. One will be, this is a disproportionation reaction. Okay. In disproportionation reaction, what you are going to do? We are going to convert it into, this is C. This will be, one will be converted to alcohol, that is CH2OH, same number of alcohol, same number of carbon, and one will be converted to the carboxylic acid part, right? Okay. Next is, if you have cross Cannizzaro, that is very important. Okay. So in cross Cannizzaro, one more thing, in Cannizzaro reaction, you don't have no alpha hydrogen is present, right? Alpha hydrogen is not, alpha carbon will be there, but alpha hydrogen will not be there. No alpha hydrogen will be present. Very good, Chintu. Very good, Purani. Very good, Bharat. Very good. Okay. So, cross Cannizzaro, the important part is, ma'am, which will be converted to alcohol, which will be converted to acid. So, less hindered will be your acid. So, we know that here this is less hindered. So, this will be converted to acid and this will be converted to alcohol. This will be converted to alcohol and that will be converted to acid here. Right? Is that clear? Okay. Next is Hell-Bohar-Zelensky reaction. Yes, students, I can't see your energy. I think you guys are sleeping or what? Or too much into the lecture, ma'am. We are listening to you very carefully. What is the scene? Listening to the lecture very carefully. So next is Hell-Bohar-Zelensky reaction, in which you will have alpha hydrogen. That hydrogen will be converted to halogen, right? So you will have alpha monohalo compound will be formed with the help of X2, red phosphorus and water, right? Next is Mendel's reduction, where both the pi bonds will break and you will have the formation of CH2NH2 here, right? Amine will be formed here. Next, Gabriel phthalimide reaction. Now in this reaction you have only primary aliphatic, not aromatic, only aliphatic amines are formed, right? Only primary aliphatic amines are formed. The reason is because here, if you see this, first you will add KOH, so that will be, this will be replaced by K, then you will add R here. That means you have to break the bond of R and X, which is very difficult in case of benzene because of the double bond character. That is the reason aromatic alkenes cannot be formed. So this R part is only alkyl, right? So this two bonds will break and you will have the formation of primary amine here. R should never be aromatic in nature. That is not possible, right? Okay. Next is Hofmann-bromamide degradation. In Hofmann-bromamide degradation, you will have this RCO and this CO bond will be vanished and you will have the formation of RNH2 here, right, where you are adding Br2 and NaOH here. Then there is carbylamine test. Okay, then there is carbylamine test. In carbylamine test, this is the test for 1 degree amine, whether it's aliphatic or aromatic. Aliphatic or aromatic, both the amines, or aromatic. Achha, one more thing I think I forgot to told you in Felling test. It was there. Huh? Felling test is only for aliphatic aldehyde. It is not valid for aromatic aldehyde. Okay, remember this point. Okay, next we have carbylamine test. See here the reagents are same as Riemer-Tiemer reaction. So that is why the electrophile that is formed here is dichlorocarbene. Okay, the electrophile is dichlorocarbene. This RNH2 is converted to RNC, which is very foul smelling, very bad smell it has. So they can also give you one reactant which gives very foul smelling product. What is that reactant? That reactant will be primary aliphatic or aromatic amines, right? Okay. In haloform, in haloform reaction, it's not like only this primary is possible, that is possible, right? In haloform, you can have anything, right? Okay. Gabriel phthalimide only primary aliphatic amine is possible. Right? Okay? Yes. Isocyanide test. Next is Hinsberg test. So in this case, you have this kind of reagent. So what will happen? This is C6H5 SO2Cl. This is again C6H5 SO2Cl. This is basically to distinguish between primary, secondary and tertiary, right? So if you see this here, RNH2, this is R, this is H, this is NR3. This is the thing here, right? So this is 1, this is 2, this is 3. So H and Cl will be eliminated. Here you will have C6H5. This is SO2. This is N, this is H, and this is R. Right? So this one hydrogen is telling us that this thing will be soluble in alkali. Soluble in alkali. Right? That is primary amine. If you have primary, this is secondary, this is tertiary. Here this HCl will be eliminated and you will have C6H5. This is SO2, this is NR2. That is again because this nitrogen does not have any hydrogen. So this is now insoluble in alkali. Insoluble in alkali, right? And now here what you have? Here there is no reaction because there is no hydrogen with this nitrogen to react with this Hinsberg reagent. So there will be no reaction with the tertiary amine. That is the reaction to distinguish between primary, secondary and tertiary amines. It's a very, very important reaction. Okay. Last is azodite test. We are almost to the completion of the reactions. So here also HCl will be eliminated, HCl will be eliminated, HCl will be eliminated. Here you will have a dye where you will have, this is let's say C6H5, N2 and this is benzene with OH. Right? Again this is C6H5, this is N2, this is benzene with NH2. This is again C6H5 with this thing over here. And this is beta naphthol, okay? This is beta naphthol, right, which is formed here. Now, if you talk about the colors here, with phenol, it is going to give you orange color dye, right? With aniline, it is going to give you what color dye? Aniline, it is going to give you yellow color dye. With beta naphthol, it is going to give you scarlet red color of dye. Okay, scarlet red color of dye. Okay, you can remember this phenol. Okay, means orange. Aniline is then opposite one is yellow and scarlet red is for beta naphthol. Right? Okay, very good. Now let us talk about some important reagents here. Okay, let us talk about some important reagents here. Everybody, let us talk about some important reagents. Okay. Yes. Let us see. Okay, let's make the target for you. Wait a minute. What is the target that you want to have? Chal. Just give me 2 minutes, guys. Okay. Literally very, like, I don't have like a single drop on this bottle. So I really need water right now. Otherwise, I'm very, very thirsty. Either I'll just doze off here only. Right? Okay. So just give me a minute because we are left with few things. I'm not giving you any break here. Just give me 1 minute. Okay. I have no idea, frankly. I have no idea. I just know that I need to do everything what is important for you. Frankly, I have no idea on that. I don't take like, okay, this much time I'll do the class, right? All I know is this much content. It is the target that we have today. Even if the target is completed by 4 p.m., 5 p.m., 6 p.m., I have seriously no idea on that. Okay? Yes, but I'll give you breaks in between. You just have to be very, very clear on that yes, we are here and we'll be there at the end of the session as well, because I'm doing all of this. My health is seriously not fine. Even now, my head is like completely, this area is so paining right now. You have no idea, right? It's with a very difficult situation I am taking this class. But because I know that after 1 week you have your exam, so things, health, I know that that is important. But if it would have been like some other time, I would have definitely cancelled the class. But right now, I know that even if I'm not well, something is there. I have to be here with you, right? Because I can't just ditch you at the last moment, right? Okay. So that's why duration I have no idea, right? But yes, that I can sure that if you're watching this lecture till the end, you can definitely expect around 130 plus marks easily, right? Okay, 100 plus I have written it for those students who are already scoring, let's say 30-40 marks. So their 100 marks will be added on with this, right? Now here, KNO3 and you have RX and this. So now here what you remember, first is KNO3, that is the ionic in nature. That is the reason with RX with KNO3, what will happen? You will have the formation of R. This is ONO. That will be the answer. But if you have RX with AgNO3, with AgNO2, you will have RNO2 as the answer here. RNO2 as the answer here. Right, so that is why with AgNO3, you will have RNO2 as the answer here. Is that clear? Okay, students, is that clear? Right? Okay. Yes. Similarly, if you have RCN, okay, just remember that these are some of the important reagents that I am picking for you, where you might do mistake. If you have RX plus AgCN, then the answer will be RNC. If you have Rx plus KCN, then the answer will be RCN. Then the answer will be RCN. Right? Then the answer is going to be RCN. Right? Okay? Why? Because here it is Ag with Ag, they are connected to covalent bond. So here with Ag it is connected to covalent bond. So C is not free for the bonding. That is why it has to pair up with nitrogen. Right? So here you have RNC. Here oxygen is bonded to Ag with covalent bond. That is why oxygen is not free for the bonding. That is why you will have RNO2 here. Right? Okay. Next is alcoholic OH. Right? For that, you know what you need to know. One thing is you should also know the reaction of aqueous KOH. Okay. So you can write it over here. You can write it over here. Okay, who will tell me that with aqueous KOH what happens? If you have aqueous KOH, then what will happen? With aqueous KOH or NaOH, what will happen? You will have substitution reaction. That means X will be replaced by ROH, right? But in case of alcoholic OH, you have elimination reaction. So I'm just giving you one example here. Let's say you have CH3. So let's talk about this kind of thing. Let's say you have X here, right? So if you have aqueous KOH, let's say you have aqueous KOH, then this will be replaced by OH here. Simple thing, simple answer will be there. But if you have alcoholic KOH, in that case, elimination reaction, hydrogen will be here and here. Either this will be replaced, either this will be replaced. That means two options you can have. One is formation of this kind of alkene. Other is, wait a minute. Other is formation of this kind of alkene. If from here hydrogen is eliminated, double bond will be present here. Now, which one will be major, A or B? You tell me which one will be major according to Sedgwick rule, right? No worries, Sandhya. You can watch the recorded version of what we have done till now. Most important things we have done of organic chemistry, right? After completing, we are going to start with physical chemistry, right? Okay. Or I'll start with inorganic chemistry first, right? So here it is A and D. So if you see, this is the double bond, this is the double bond. This double bond is more alkylated, so A will be the major product. Sedgwick rule says that more alkylated alkene will be formed. That means according to hyperconjugation, the alkene will be formed here. So A is going to be more stable alkene. Next is ozonolysis. So in ozonolysis, what you should remember, let's take an example. Let's say you have this C double bond, this is CH3, this is CH3, this is CH3 and this is H. Now, what can happen here? This pi bond can break, and when you break the double bond, you will attach double bond O here. When you break the double bond, you will attach double bond O here. This is C double bond O, this is CH3, this is H here, right? This is H here. Now, after this, if this is reductive ozonolysis, if let's say it is oxidative ozonolysis, right? In that case, you will see that hydrogen which is directly connected to carbonyl carbon. So that will be replaced by OH. Rest of the things will remain same. Rest of the things will remain same. Okay. If let's say you have something like this, by breaking the double bond, you have this kind of compound. After ozonolysis, you will have OH here, you will have OH here, right? Now, this is nothing but this is H2CO3. Now, this carbonic acid is directly converted to H2O plus CO2. That you should remember. It is directly connected to converted to H2O and CO2. Okay, that you should remember. Okay, students, is that clear? Next is Bayer's reagent, that is cold diluted KMnO4 if you have, then the pi bond will break and you will have the formation of OH on both the sides, right? Vicinal diol will be formed here, right? Next is mild oxidizing agent. Now, oxidizing agents, right? Very important. So, if you talk about mild oxidizing agents here, like you have PCC, PDC, or you have strong oxidizing agent, like you have cold KMnO4, Jones reagent, right? Or MnO2, that is allylic. This is a different reagent. This is not under strong reagent, right? This is only going to, chalo, firstly, let us talk about mild and strong oxidizing agent. Where you have this? Chalo, we don't have it over here. So what I'll do, no? I'll just copy paste some slide from somewhere. Let's say from here I can copy paste the slide and paste it here. What to do, guys? Should I copy paste the slide here only? Chal. Or I'll just delete it. I'll just have without borders wala slide, right? Okay. So now what you need to remember here, that you will have 3-4 things here. One is the alcohol, then there is mild, then there is strong, then there is copper, right? And this is the chart, right? Let me just draw it. This is the alcohol, this is the alcohol, this is primary, secondary, or tertiary, right? This alcohol is primary, secondary, or tertiary, right? Okay, yes, you will get definitely, right? Don't worry about that. Let's say you have mild oxidizing agent, you have strong oxidizing agent, you have copper at 300 degrees Celsius, right? Remember that mild will convert it into aldehyde. 2 degree will be converted to ketone. 3 degree will have no reaction. Strong will convert 1 degree to carboxylic acid. Then 2 degree will have same ketone only. Third, no reaction. If you have copper, 1 degree will be converted to aldehyde. For 1 degree, it will show reactions like primary and secondary mild reagents, right? 2 degree will be converted to ketone, but 3 degree is converted to alkene here. 3 degree is converted to the alkene here, right? 3 degree is converted to the alkene here. Very good, Dikshita. Then you must subscribe to the channel now, right? Okay. So if God has sent you here, then you must subscribe to the channel now, right? Okay. So this is alkene here, right? So that is for copper. And what about MnO2? That is a different oxidizing agent. Okay. So if you talk about the allylic, this is double bond next to double bond when you have carbon, that is allylic. So if you have OH over here, that is directly converted to C double bond is CCH2, right? So allylic or benzylic is converted to CHO, not any other 1 degree, 2 degree, 3 degree. Only allylic and benzylic. Okay. Next is dehydrating agent. So we usually know just one thing, that concentrated H2SO4 is a dehydrating agent. But these all are very good dehydrating agent. That means if you have, let's say C, this is OH, this is H here. So this H will be eliminated, OH will be eliminated, and you will have the formation of C double bond C here. That is your dehydrating. You will take out water directly, will be eliminated from it. That is dehydrating agent. Next is one different point regarding concentrated H2SO4 only. Dehydration of alcohol can occur in 2 ways. Let's say you have 140-degree temperature. So then in this case, you will have, this is OH. Wait a minute. Here you have OH. And you have one more compound that is having OH. This is CH2. This is CH3. Right? In this case, what will happen? Water will be eliminated. Wait a minute. Water will be eliminated. H2O. Yes. This thing will be eliminated. And you will have the formation of ether, that is CH3, CH2, OCH2, CH3. Right? If the temperature is 140 degrees Celsius. But if the temperature is, let's say, 170, more than that, then OH will be eliminated here, H will be eliminated from here, and you will have the formation of alkene here, right? And you will have the formation of alkene in this case, right? Okay. Understood, everybody? Right? Then you have allylic bromination or chlorination. In allylic bromination, see allylic carbon. Again, you have C double bond C. This is the allylic carbon. And the hydrogen attached to it will be substituted. That is the allylic bromination or chlorination, right? Okay. So in this case, what can happen? In this case, what can happen? Just give me a minute. Okay. I think the light went away. Okay. So if you have hydrogen here, so what can happen? This hydrogen will be substituted by either chlorine or bromine, whatever you are adding here. So this is possible when you have free radical mechanism. You can add Br2H mu, you can add Cl2H mu, or you can add NBS here, right? In that case, this allylic hydrogen is replaced by the halogen. Okay. Next is LiAlH4. Now you have two very important reducing agents, LiAlH4 and NaBH4. Okay. If you see LiAlH4, okay, I think electricity is back. LiAlH4, remember one thing, it can reduce carboxylic acid, ester, alkyl acid, alcohol, acid chloride, everything to alcohol. But NaBH4 is not able to, but NaBH4 does not react with RCOH, RCONH2 and RCO. That means ester, acid, amide and ester is not reduced by NaBH4. That is a very, very important point. LiAlH4 can reduce. From this also they have asked questions, okay, from this very important point. NaBH4 does not react with the acid, amide or ester, but LiAlH4 does react, right? Then Dibble is that diisobutyl aluminium hydroxide hydride. So here what you have to remember, it can oxidize, so it can reduce everything to aldehyde here. Everything, all of these groups will be reduced to aldehyde here. Then there is Grignard reagent. So in Grignard reagent, one thing to remember, but after this I'm giving you the break only, right? After this thing, what you have to remember, if you have C, let's say you have so two things are possible in this case with the Grignard reagent. One is if you have RMgX and this is reacting with any triple bond here. No, this is reacting with any proton source. That proton source can be terminal alkyne, that proton source can be water, any proton source. It will be converted to RH, that is hydrocarbon. That is the first property. Second is if you have RMgX and that is reacting with any carbonyl compound, in that case, what will happen? This is negative, this is positive, it will attack on carbonyl. Electrons will jump here. You will have OH here. 1, 2, 3, R will be connected here. That means you will have the formation of alcohol in that case. Right? Okay? But if I finish this in between, the flow will break for the reactions. Okay? So let me complete the reaction part, then I'll definitely give the break. Even I am not well. Right? Right? So it's not like I don't want to give the break. You understand this now? If I have completed, then I am again starting with inorganic chemistry, then you should say break. Right? So here it is hemiacetal and acetal and ketal. So if you see this here, RCHO, right here, just give me a minute. Okay. Okay. If you see this here, hemiacetal, acetal and ketal, this hemiacetal, acetal and ketal, let us see how it is formed. If you have aldehyde, you add H positive here, then H will be attached here, you will have OH, bond will shift here. Hemiacetal is simply when you have one R, one H, one OH and one OR. When you add one ROH here, then this OH is again converted to OR, that is acetyl group. Ketal, the same way you will use ketone here. In this, instead of aldehyde, you will use ketone. And hemiketal is when you have one carbon, one OH, one OR, two R groups. Then you add ROH here. This OH is again converted to OR. That is called ketal. Ketal is also used like this when you add ethylene glycol. This is ethylene glycol. Ethylene glycol. So when you add ethylene glycol, you replace this two hydrogen and one oxygen bond is eliminated. And in this case, you protect. Okay, this is used for protection of carbonyl group. Okay, this is used to protect the carbonyl group here. Right, whenever you want to do some reaction, you can protect this carbonyl group and then do the further reaction, then again convert it into carbonyl group. So that is why ethylene glycol is used for the protection of carbonyl group, right? Then cyanohydrin, if you see cyanohydrin here, what will happen? Let's say you have HCN here. Let's say you have HCN here. This is H positive, this is Cn negative. Cn negative will attack here, electrons will jump here. This electron is jumping here, that is why there will be O negative, which further H positive will attach, this will be converted to OH here. Right, that is nothing but this is called cyanohydrin. Cyanohydrin. Okay. Next is we have ketone. Now this reaction is very important and I'm just, give me a minute, I'll just give you one very important slide here. I really hope so. I'm able to open this here. Okay, just give me a minute, students. because there is some important NCRT table that I always forgot to give you. Give me a minute. Okay, just give me a minute. I'll just import that page over here. That's a very, very important page of your NCRT. Let me know if you're able to see this. So, this is a page from your NCRT directly, right? Okay, let me know if you're able to see this, right? So, here what you have to do is, what you should remember here, that you have this RC double bond OR, right? And here you have NH2Z. So whenever you have something like this, you just eliminate water here, right? H2 and O will be eliminated and C double bond NZ will be formed here, right? C double bond NZ will be formed here. Now depending upon N, you will have different formations here. Let's say let's say Z is equals to H, then you will have C double bond NH, because your general compound is C double bond NZ. If Z is R, then you will have C double bond NR, right? If Z is OH, you will have C double bond NOH, that is oxime. And Z is NH2, you will have hydrazine, that means you will have, instead of Z, you will have NH2. If Z is this compound, instead of Z, you will have this compound, right? That is nothing but phenyl hydrazone. Now, if you have Z is this 2,4-dinitrophenyl hydrazine, then you will have this compound, that is 2,4-dinitrophenyl hydrazone. If you have semi-carbazide here, that is NHC double bond O NH2, then you will have this compound as Z, and that is going to be an answer for semi-carbazone. Okay, so these are the different answers that you will get here. Is that clear to everybody or not? Right? Okay. Now, last part we have some electrophilic substitution reactions here. So let's say this particular reagent is going to give you X positive electrophile. This nitrating agent is going to give you NO positive electrophile. This anhydrous ClCl3 Lewis acid is going to attack here. It will give you R positive electrophile. If you have RCOCl or you have any anhydride here, that is going to give you RCO positive electrophile. If you have concentrated H2SO4 or oleum, that is going to give you SO3H electrophile. So these are the different electrophile. I have already told you where you will have meta, where you have ortho para product in the in that particular GOC, right? Now, important parts about electrophilic substitution are that whenever you do bromination of phenol, when you use CS2, it will give you ortho and para product, different product. Mono substituted product will be there. If you use water with bromine, it will give you tri substituted product, that is also white precipitate of this will be formed, right? Next is with aniline, there is no way that you can have mono substituted bromo product. For that, what we do, for this thing also, what we do here, we firstly do the acetylation, we convert this hydrogen into COCH3. Now what will happen? This lone pair is involved in this resonance, and that is why lone pair is not very active. See, phenol is still electron negative as compared to nitrogen. So phenol, the rate of reaction is even faster, even slower. Nitrogen is less electronegative. That is why it is more like, it is giving like, I'll give the electron. So as compared to oxygen, when you have lone pair or oxygen, lone pair or nitrogen, nitrogen wants to donate the lone pair with more efficiency. That is why mono product is not available. For that, we have to make these lone pairs busy somewhere. So we have, that's why connected COCH3, and then you do bromination, you will get the para product here, right? Now, another case is when you do the nitration, you have meta product also that is formed. But the thing is, this is only ortho para directing. We are saying that NH2 is only ortho-para directing. Again, you are having the formation of meta product. Why? Because in the acidic condition, we know that aniline is a base. It will have the formation of anilinium ion, which will give you meta directing product. Okay, because this anilinium ion is meta directing, right? Because here, if you see, this is going to donate the electrons. It is meta, wait a minute, no, it is not going to donate, it does not have electron, no, it is going to take away the electron, right? It is going to take away the electrons. Okay, so that is how it will show you minus M effect, that is, it is meta directing. That is why you have 47% meta directing product. Here what you have to do, convert this H, again do the acetylation, then do nitration, because here what will happen, these lone pairs are already involved in the resonance with this C double bond O. That is the reason they will not accept H positive and will not get converted into anilinium ion, and hence you will have only para product as the answer, right? Okay. Next is the, okay, last question, last one here. That is, if you have disonium chloride. Now this question is also very important nowadays, right? How to convert it into directly benzene? If you use H3PO2, ETOH or HCOH, that is directly converted to benzene ring. Okay. Yes. Now I just have 5 to 10 questions. Let's complete those questions. After that, I'll give you break of 20 minutes. 20-25 minutes break I'll give you. You can just relax. Okay? Because I want at least organic part we should complete before the break. Right? Then we will left with the inorganic and physical chemistry. Okay, students, let's finish that. Everybody, in next 10 minutes, let's finish that. Okay? In next 10 minutes, let's finish that. Okay, students. Yes, everybody. Ma'am, what to do now? I can just go and will upload photos. Ma'am. Now let us start this. I want you guys to answer this, okay? I want all of you to answer this question, okay? Let us see how many of you are able to answer this. The product in the given reaction is this. Here you have H2SO4. Now I told you that H2SO4 is a very good dehydrating agent. That means water will be eliminated and you will have the formation of alkene. So whenever you have a dehydrating agent, we know that what exactly will happen here. OH negative will be eliminated and hence you will have the formation of this kind of carbocation that I'll just draw here. This kind of carbocation will be there, right? Now you can say that this is outside the ring. So that means even this is 5-membered ring. Positive charge is outside. So I can do ring expansion here. So this is 1, this is 2, this is 3. So I'll just attach 1 and 3 here. This is 1, 2, 3, 4. I'll just attach 1 and 3 here. I'll put positive charge on 2, or I can even write it something like this. Okay, I can write it something like this. Now what will happen? This from H, because this is elimination, right? So this H will eliminate, double bond will shift here. You will have the formation of this kind of compound here. So directly you can't do this. You have to apply ring expansion and ring contraction here. Hence C is going to be the correct answer here, right? Next is, consider the following reaction. Now this reaction is given to you. See, in first case, what you have, C6H5NH2, then you add CHCl3. Now tell me, what is this reagent? What is this reagent? This reagent is nothing but that is carbylamine reaction. So that means for sure here you will have the formation of C6H5NC, right? Then you are adding water. You have the formation of two things, B and C. They are asking you what is this B, what is this C. So whenever you have NC here, what you do? Break the pi bonds. All the bonds will break here. You will have here C6H5. H2 you can give to this side. This will be NH2. And here you will have HCOOH. That means these two things will be formed because all the bonds will break after the hydration. Right? Okay. Hence the answer is going to be aniline and formic acid. That means answer is going to be B is the correct answer here. Okay, B is going to be the correct answer here. Next question is, how many hyperconjugable hydrogen atoms are there does this molecule have? So if you see here, what you have to see the alpha carbon. This is alpha, this is alpha, this is alpha, that is the main. So it has 3 plus 3, this 3 plus this 3. It has 2 here, it has 2 here, plus 2 plus 2. That means 6, 7, 8, 9, 10. That means total number of alpha hydrogens are 10 here. So answer is going to be C is the correct answer here. Am I going too fast? Why you guys are not answering? Try to answer in the chat box. Okay, try to answer in the chat box. Right? That will be in the description. Okay. Aryl halides undergo nucleophilic substitution with ease. Aryl halide means this thing. Right? Nucleophile, when it's substituted, they are saying it will undergo nucleophilic substitution. Substitution. We know that here nucleophilic substitution means they would want to see the electron density condition here. Carbon halogen bond in aryl halides has partial double bond character. What is this A, B, C, D? I don't know. I think maybe by mistake this question is there. See, all I can tell you is true and false because you know the option is incomplete, right? What they have ticked D. What is D? Right? I think by mistake, assertion, reasoning, something is not given to you. There must be options like A is the correct answer, assertion is correct, reason is correct. That must be there. So if you see aryl halide undergoes nucleophilic substitution reaction with ease. Electrophilic substitution reaction they go with ease, but nucleophilic substitution reaction does not occur with ease. In fact, it is very, very difficult because you have electron density on ortho and para positions here, right? So that is the false statement. The carbon halogen bond in this aryl halide, definitely because of the resonance, this will have a partial double bond character. That is true, right? So assertion is false and reason is true here, right? Next is 2-bromo. Next is 2-bromo pentene is heated with potassium ethoxide. Okay, 1, 2, 3. So this is pentene 1, 2, 3, 4, 1, 2, 3, 4, 5. 2-bromo means here you will have bromine, right? When this is heated in potassium ethoxide, potassium ethoxide is C2H5OK. That is nothing but alcoholic KOH. That is going to cause elimination from this side, and you will have the formation of a double bond over here. That is pent 2ene, and that too, which pent will be formed? Trans pent 2ene, because trans has less repulsion, cis has more repulsions. So trans will be formed here, right? Next is, which of the following reactions can produce RCOR? Okay, reactions you have to see. So one by one we will see all the reactions here. So okay, chalo. So I think full reaction I only have to solve. Let me just see if I can make some page over here. Chalo, I'll solve it here, isn't it? What I'll do, I'll just erase it. 2 things I'll solve here, 1 thing I'll solve there, right? So if you see, this is benzene, okay, and this is on benzene, you have COCl, right? So that is why this will be converted to CO positive. It will attack here. You will have this kind of product, that is benzene, CO, and this is benzene, which is not definitely R, so that is the wrong answer. Here you have R, COCl, and A, R, MgX. So that is the negative part. It will acid hydrolysis you are doing, no? This is also R, है ना? So this is alcohol it will give you, because it will attack here. Electrons will jump here and it is going to give you alcohol. So that is also wrong, right? This is again what will happen. Alcohol will be formed. This R will attack here. This is C double bond O, electrons will jump here. Again, alcohol will be formed. So that is also wrong. Last is R, COCl and H this. So if you have benzene, it is going to form RCO kind of electrophile, which is going to attack on benzene and it will give you COR, that is this thing. So answer will be D is the correct answer here. Right? Okay. Right, everybody? Next is, which of the following compounds cannot reduce tolerance test? See, tolerance test, I told you, that is given by formic acid. That is true. It is given by, this is nothing but this is C double bond O, this is CH2 and this is OH. So this is alpha hydroxyketone. It is given by alpha hydroxyketone. It is not given by ketone. It is given by aldehyde also. So answer will be C is the correct answer. That is giving you tolerance test here. Right? Next, dry distillation of sodium propanoate with soda lime give. Dry distillation of sodium propanoate with soda lime. Sodium propanoate is what? 1, 2, 3 COONA. Right? This thing you have. Soda lime is going to give you RH. That means this is the R part. Right? So it will give you CH3, CH2H. That means it is going to give you ethane. So answer will be ethane is the correct answer. See how directly they are asking you questions from naming reactions. Okay. The products formed in the reaction of cumene followed by O2 by treatment with dilute HCl. So if you see, cumene is going to give you two products, that is phenol and acetone here. So answer will be B is the correct answer. Wait a minute. Followed by this by treatment of HCl. Yes. So it is going to give you cumene is this thing. It is going to form cumene peroxide. Then phenol and acetone will be formed here. Right? Okay. Next. Which one is the most reactive towards nucleophilic addition reactions? Nucleophilic addition reactions, for nucleophilic addition reactions, you need to have electron deficiency on the carbon. If you see overall here, right, this is giving plus I effect. This is taking out minus I and minus IM effect, right? So deficiency is there. It is giving electrons, it is taking out electrons from here as well. That means carbon is taking electrons, right? Here you have simple resonance, that is C double bond OH. That means it is taking out electrons. Only this is the case where you are also taking out the electrons from the carbon. Otherwise, carbon is only taking electrons from one or the other thing, right? So here D will be the most electron deficient carbon with the aldehyde, and that is why nucleophile addition reaction will be maximum order will be this thing, that is D is going to be have the maximum rate of reaction for nucleophilic. Yes, D is the correct answer. Very good. Identify the product here. So this is a sequence of reactions that you have. First thing is, if you add SOCl2, this will be converted to Cl here. Then you add NH3 here, then this will be converted to NH3 amide. Then you add NaOH-Br2. What is the name of this reaction? Anybody? This is nothing but this is Hofmann bromamide degradation. Hofmann reaction. So CO will be eliminated and hence you will have the formation of this is NH2 and this is the Br here. That is the answer that you will get in the end. So answer is going to be C is the correct answer here. Right? C is the correct answer here. Product A is given by, so if you see this here, this is aniline, this is azo dye will be formed here. We know that here what we can form, this is benzene, this is N2, Cl and H from this side, para position will be eliminated and hence you will have the formation of this dye. The dye is, D is the dye that is formed. And what is the color of the dye? Yellow colored dye will be formed here. Right? So D is the correct answer here. Right? Okay. Reaction by which benzaldehyde cannot be prepared. This Can you tell me the name of this reaction? This is nothing but Gattermann-Koch reaction. So benzaldehyde is prepared by this. Here you have ZnHCl and concentrated HCl. Wait a minute. This also Itard's reaction. This is Itard reaction. You can prepare benzaldehyde. In this you have to add H2. This also you can prepare. This is Rosenmund reduction. This is Rosenmund reduction. Here also you can prepare. This is Gattermann-Koch. This is Gattermann-Koch reaction. With this you can't prepare, right? Okay. So answer will be B is the correct answer, with which you cannot prepare, with which cannot be prepared. Wait a minute. No, the answer will be B. Okay, the answer will be B is the correct answer. Okay, B is the correct answer here, right? Okay, that's it. The questions we have done, right? Now you can have your break, right, guys? Now you can have the break, right? Whatever time you want to have the break. Let's take break for, let's say, 25 minutes here. 20 minutes or 25 minutes? What is the time here? We have 2:30. To what time I should give you the break, right? Because you have studied like for how many minutes? For more than 2 hours you have studied. From I think 3 hours you have studied, right? So you deserve break. Tell me, students, after this physical chemistry we will see some important formulas here, right? And for inorganic chemistry I'm going to show you some important theories. Okay, right? Tell me what amount, how much break you want to have. Okay, ma'am. 20-25 minutes. So, yes, 10 minutes is enough to drink water. Don't you want to eat something, Harshita? So, I'll give 20 minutes break, okay? So, here you have the time is, I'll see you at 2:40 p.m. At 2:40 p.m. I'll see you all. Right? Or let's say at 2:45, okay? That's take break of 2:45 p.m. I'll see you all right after the break. Class will resume, right? Okay? You can have your lunch break. You can have your lunch. I'll also have my lunch, right? You can have rest. After this, we are going to start with physical chemistry and inorganic chemistry. Is that clear? Okay? Yes? Okay, okay. And before going, let me just show you that over here, students, for totally free of cost, we are providing you NEETpedia here. You can see the link is in the description, where most important NEET previous year question, NEET question paper for 2022 to 2024 are there. That is totally free of cost for you, right? Then study buddy is also there. That is also totally free of cost. You can just scan this code and you will get the link for study buddy. That is going to help you in next 1 week, right? Then Vedantu test series, totally free of cost. That is available to you, right? You can see the test series as well. And marathon is also going till 29th of April. That is your revision-a-thon, right? So all of these things are provided to you for totally free of cost. Okay. Now I'll just mark here. I'll just see you at 2:45 p.m. lunch break. Okay. Okay, then see you all after the break. See you. Hello. Okay, students, I'm back after the break. Everybody. Yes, students, I'm back after the break. Yes, ma'am, I didn't get to join due to my net problem. No worries. We are still left with physical and inorganic chemistry. Okay. So let me just inform the students that the break is over and we are about to start physical and inorganic chemistry. Okay, done. Sure. Now let us start with the firstly, do you want to start with inorganic chemistry or physical chemistry? Let me know. Okay, I am making a poll here. Let me know in the chat box if you want inorganic chemistry or physical chemistry. Right? According to the demand only, I'll start. Right? Inorganic or you want to start with physical? Physical chemistry. Let's start the poll. Let us see. Okay. Which app are you using for presentation? Nothing but a Google Slides. No app, nothing. Right? Okay. Welcome back. Welcome, welcome, welcome. Yes, let me see. Inorganic chemistry, 64% of you are saying inorganic chemistry, ma'am. Right? Very good. Chalo, then, yes. Now let us then start with inorganic chemistry only. So inorganic chemistry is somewhere here. So I'll start with inorganic chemistry first, okay? So inorganic chemistry, students, 4 topics we are going to complete in inorganic chemistry, where for sure the question will be there. One is hybridization, right? Then there is MOT, then there is VBT, right? Then there is CFT. So these 4 topics I'm going to cover in inorganic chemistry, right? So it will take hardly half an hour and maybe 40-45 minutes to complete inorganic chemistry. Let us start that. The first thing is regarding the shapes, right? So let's say you have all the bond pairs, okay? Let's say you have all the bond pairs. So when I say that, let's say you have ABA kind of pair, okay? So I'll just draw something like this with you. So if you have ABB kind of molecule, that is a linear shape, right? Now here you have a trigonal planar where you have AB3 kind of molecule, that is like this. As you can see, the angles are 120 degrees, so that is called trigonal planar geometry, right? Then we have tetrahedral geometry. Then we have tetrahedral geometry, that is something like this, right? That is having 104-degree angle between each other. That is called tetrahedral geometry, right? Then we have trigonal bipyramidal geometry. Then we have trigonal bipyramidal. So trigonal bipyramidal, let me just draw it for you. In trigonal bipyramidal, what you have is, you have a triangle and over here you have 2 pyramids, right? Over here you have 2 pyramids. This is above and that is below. These are the 2 pyramids that you have, trigonal bipyramidal, right? Next one is, ma'am, let's talk about octahedral geometry. So in octahedral geometry, what you have, let me just draw it for you. One square planar, just give me a second, students. I'll just draw it for all of you. Right? That is not trigonal bipyramidal. Sorry. Octahedral now we have to draw. I just need one more bond pair here for that. This is octahedral geometry, right? This is octahedral geometry. So I have shown you all the geometries here. Firstly, now what you have to see here, that ma'am, in inorganic chemistry, remember one thing, that let's say for example, Let's take an example. I'll just draw one extra page here. I'll take one extra page. Let's say if you have hybridization, that will be lone pair plus bond pair, and then this will be your hybridization, and this will be your shapes and geometries, right? So now remember one thing, that if you have this, I'll draw lone pair plus sigma bonds, right? Lone pair plus sigma bonds. This is hybridization, right? And this is geometry. This is geometry, right? So if you see, if you have lone pair, this is 2, 3, or 4, or 5, or 6. So if you have, this is 2, then it is going to be a linear shape, right? Sorry, it is going to be sp hybridization. 3 means sp2, 4 means sp3, 5 means sp3d, 6 means sp3d2, right? Now, if you see here, it is a linear shape here, linear geometry here. This is trigonal. I'll just draw all the geometries. I'll just keep it here only, right? Yes. Trigonal planar means this kind of geometry is there, trigonal planar in one plane. Then there is a tetrahedral geometry that you can see here. This is tetrahedral geometry. Then there is trigonal bipyramidal geometry where you have a triangle and you have two pyramids over here. So this is trigonal. This is trigonal bipyramidal, right? Then next one is octahedral geometry, that is this geometry. One square and two pyramids here, that is called octahedral geometry. That is called octahedral geometry. Now, when you replace it with the lone pairs, then the shapes are definitely going to change. So, let us see how the shapes are going to change. Now, let us talk about firstly, when you have one lone pair and two bond pairs in trigonal planar. This is trigonal planar. If you have all the bond pair, this is trigonal planar. Let's say instead of one bond pair, you have lone pair. And whenever we talk about shape, we only talk about the bond pairs. So now you have only two bond pairs, that is defining bent V shape. So that is why here the shape is bent V shape. Talking about tetrahedral here, let us draw the tetrahedral structure firstly. In tetrahedral, this is the structure that you have. When you take out one bond pair and you replace it with the one lone pair, then that is giving you what kind of geometry? That is trigonal pyramidal. This is making a pyramid over here, right? So that is giving you trigonal pyramidal geometry. If you have two lone pairs here, right? Let's say you have two lone pairs in this situation, right? Like water example also I have given you side by side. If on the center metal you have two lone pairs, here you have one lone pair. Then in this case, this is going to be bent V shape, right? Okay, bent V shape. Next is, let's say you have trigonal bipyramidal, and now here whenever you are putting the lone pair will be on the equatorial position. This defines the equatorial, this defines the axial. On axial position, you will put more electronegative element, and here what you will have, this one lone pair. Now can you see, this is a seesaw shape, right? So here the example is SF4, that is a seesaw shape, right? Next is if you have two lone pairs, we'll take out one more bond pair here, and this is what you have is T shape, right? So directly you can write here, that is T shape. Example is ClF3, right? Next is if you have octahedral. In octahedral, let's say how much you have, one bond pair is taken out and you have instead you have lone pair over here, right? So if you see, this is square pyramidal. That is why the shape what we call is square pyramidal, right? Next is for octahedral, if you take two lone pairs, and lone pairs should always be opposite to each other, then what you have is square planar shape here, right? So answer is square planar, right? Okay, so that is going to be your answer here. Now I'll just ask some question here on this. I'll just, because questions are important here. Wait a minute. Why some questions osmotic pressure are here? Oh, by mistake I have put some questions over here. Chalo, koi baat nahi, no worries. So these are the questions over here that you should know, right? Let us see these questions. Choose the correct answer from the following. So these are the, you have to firstly calculate the lone pairs here. Number of lone pairs on the central metal atom. So that I show you the basic. Now let us see how to apply this theory, right? So in inorganic chemistry, you should also know how to apply the theories. Just by theory, you won't be able to understand. So questions are very important here, right? So whenever, if I take about IF3, IF7, so how I'm going to look for this? Iodine belongs to group number 17, that means 7 outermost electron, and all are occupied with the bond pair. So 7 minus 7 is 0 lone pair. That means this is going to have, A is 4, it is going to have 0 lone pair, right? A is going to have 0 lone pair. Next is iodine, it is belonging to group number 17, that is 7 outermost electron, and you are gaining 1 electron here, so it will be 7 plus 1, that is 8. From that 8, 4 are already occupied in the bond pair, so you're left with 4. That means 2 lone pairs. So you can say here you have 2 lone pairs, that is this, right? Then you have xenon F6. So xenon means what? Xenon belongs to group number 18, that means 8 outermost electron, minus 6 you will have, so you will have 2 electrons, that is 1 lone pair. That means here you will have 1 lone pair. Xenon F2, what you will do? Xenon here belongs to group number 18, so it has 8 outermost electron. 2 bond pairs you have here, so that means minus 2, that will give to 6 electrons, divided by 2 means 3 lone pair, so it will have 3 lone pair here. D is 3, D means 1, so answer will be B is the correct answer here, right? Okay, B is going to be the correct. That is how you're going to solve the questions, okay? So I have specially picked out 2 different questions for you. One is this one. Other is a question like this, where you have, this was, so B is the correct answer, I think, by repeat. No. Number of lone pairs only they are again asking you, choose the correct, but I'll rather, no, this will be number of shape. This is not lone pair, this is shape. They're asking you the shape here, right? So one question was regarding the lone pair. This question is regarding the shapes here, right? So let us see how to calculate the shapes. So one by one we will calculate. One is for XCF2. So I'll just draw it the next page, right? 4. I'm dividing it on 4 boxes. So firstly, let us talk about XCF4. If you see this here, XCF4, simple is xenon belongs to group number 18. First, you will see which is the atom that it is belonging to, which is the group, that is group number 18, that means 8 electrons. With fluorine, it is always formed single bond, so that means 4 bond pairs it has. So minus 4 will be 4 electrons, that means 2 lone pairs. Now, we know that it is having 2 lone pair plus sigma bond is 4, so answer will be 6, that is sp3d2. And here if you see, if you draw the structure here, we know that that is going to be 1, 2, 1, 2, 3, 4, 5, 6. Lone pairs should be opposite to each other. So here I'll draw the lone pairs, right? And this is going to be F, 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 F. Can you tell me the shape? I just told you the shape is square planar, right? So here answer will be, because you are not going to involve the lone pairs in the shape, so it is going to be square planar, right? Now next one is first is square planar, that means A is 2, that means these two are eliminated. Next is SF4, right? Next is SF4, so I'll just write SF4 here. Sulfur belongs to group number 16, that means 6 outermost electron, right? Minus 4 bond pair, it is going to give you 2 electrons, that means 1 lone pair, right? Number of sigma plus pi bond is going to be what? Sigma bond is what? Sigma plus, lone pair, that is going to be 1 lone pair, plus you have 4 sigma bonds, that is 5, that is sp3d, that is trigonal bipyramidal. So if you draw this here, this is S, 1, 2, 3, 4, 5. On 1 you should have lone pair, that is why here you will draw the lone pair, right? That is how you're going to utilize this theory. So we can see, if you ignore this part, this is a seesaw shape. That also, if you remember, I told you how to, this is your seesaw shape, right? Here you had one lone pair, right? So this is your seesaw shape that you have, right? So you can directly write seesaw shape, right? Next one is SF4 is seesaw shape. You can see B is 1. B is 1 in both the cases. Let us talk about C. This is tetrahedral, we all know, but still if you want to answer this, this will be NH4, right? Nitrogen belongs to group number 15. This is NH positive, so nitrogen, you will take one more electron here. So group number 15 means 5 minus 1, this will be 4. 4 are involved in the bond pair, so there will be 0 lone pair. Bond pair is 4, so it will be sp3 hybridization. That means it is going to be 1, 2, 3, 4, and here you will have one positive because lone pairs are gaining the hydrogen here, right? Okay. Last one is, so it is tetrahedral. You already know the answer that C is 4. So we already know the answer that D is the correct answer, but still I'll solve for BRF3 as well, right? BRF3, if you see, right, BRF3, bromine belongs to group number 17. That means 7 outermost electron. 3 are involved in the bond pair. That means 7 minus 3 is 4. 4 electron means 2 lone pair. Now, 2 lone pairs you have. You have 3 bond pair, that is 5. That is sp3d, right? That means it is trigonal pyramidal, right? So, Br 1, 2, 3, 4, 5, right? Now, lone pairs, you have 2 lone pairs that will be on the equatorial position, right? So, I'll draw it like this, one lone pair, other lone pair, and that is going to be T shape here, right? Okay. Some student may ask, ma'am, why you can't have one lone pair here, one fluorine here, one lone pair here. In 2D, it may seem that this is different, but in 3D, it is same only, right? All these three equatorial bonds are same. Even if you take from here and here, that is same, right? Even if you take from this place, wait a minute, this place and this place, that is also going to be same. So there is no difference in that. Just for the symmetry sake, in 2D, we draw it like this, okay? Otherwise, it's the same thing only. Even if in the exam they put one lone pair here and one bond here, that is not incorrect. That is the correct thing only, right? Okay, that you should know, right? So this answer, we already know that D is the correct answer here. Let us see one more question based on this. Why I have picked out this question? Because here you have oxygen multiple bond as well. So how to answer for multiple bond, that you should also know. So here you have xenon O2 F2. So we know that xenon is the center metal atom. It belongs to group number which? 18, right? Ma'am, why not on the axial position? If you see now on the axial position, you put the lone pairs. We know from Vesper theory, lone pair repulsions are maximum, right? So here, this, if you have the lone pair over here, if you have the lone pair over here, what will happen? Lone pair bond pair repulsions will be very high because they will have 90-degree angle with each other. But when you put lone pair on the equatorial position, they have 120-degree angle, so repulsions will be less, right? For that case, because of the repulsions, we put it on equatorial positions, okay? So, xenon belongs to group number 18, that means the 8 outermost electron. Now, if you see this here, xenon, roughly I'll draw the diagram, 2 oxygens, 2 fluorine it has. Total 1, 2, 3, 4, 5, 6 bond pair. Oxygen always form double bond. So, total it has 6 bond pairs, okay? So, that means 2 electrons, that means 1 lone pair. But sigma plus lone pair is what? Sigma plus lone pair. That is 4 sigma plus 1 lone pair, that is 5. That is sp3d, right? So here you can draw that it is xenon, right? It is 1, 2, 3, 4, 5. That is trigonal bipyramidal geometry. You put one lone pair here. I'll put one lone pair here. More electronegative element will be on the axial position. So fluorine will be here and double bond oxygen will be present here, right? That is going to be your shape for this. That is going to be seesaw shape. That is D is the correct answer here. right? Okay, is that clear? Axial position, you will have more electronegative element, right? And lone pair will be on the equatorial position. Is that clear to everybody or not? Now let us do MOT theory. Okay, let us do MOT. Molecular orbital theory. Let us do molecular orbital theory. Again, a very, very important theory. I forgot to take water bottle. Okay, chalo, after inorganic, chalo, after MOT, I'll just bring water bottle. Okay, so MOT theory is molecular orbital theory, right? In this case, what we study is the atomic orbitals combines to form molecular orbitals. And what you should remember is that for less than, you just remember that less than or equal to 14, you will have 2, 1, 2, 1. And for more than 14, you will have 1, 2, 2, 1. Okay, just remember these two things. Right? Now, bond order is number of bonding minus anti-bonding divided by 2. Right? Now, let us see how to solve the questions, because with the help of questions only, you will be able to understand what exactly we are doing here. Right? So, I'll directly go to the question part here. After this, you had your question part. Right? That is somewhere here. You have the question part, right? Okay. This is the question part that we have, right? Yes. The species having bond order different from that of CO is the species which is having bond order different from that of CO. Firstly, for bond order, directly what you will learn, the one trick here, that is, right, to solve these questions, because this trick is valid everywhere. 14, this is 15, 16, number of electrons I am writing here, right? Okay, and this is 13, 12, 11 and 10. Here writing the number of electrons. Bond order of 14 is 3, rest of it will be decreased by 0.5, right? Here also it will be decreased by 0.5. So it is 2, it is 1.5, it is 1, right? Now, what is 2, 1, 2, 1, 1, 2, 2, 1? Okay, I'll tell you. What is 2, 1, 2, 1, 1, 2, 2, 1? I'll tell you here, right? Okay. So, firstly, let us solve this, then I'll tell you what is 1, 2, 1, 2, 2, 1, because that is not needed here. Bond order, we know that how many electrons CO has? CO has how many electrons? It has 6 plus 8, that is 14 electrons, right? This also has 14 electrons. This is having 7 plus 7, this also has 14 electrons. Yes. This also has carbon plus 7 plus 1. This also has 14 electrons. This has 7 plus 8 plus 1. That will be 16 electrons. Right? So that means the NO is having the different bond order here. Right? So this is the bond order, students. This is the number of electrons that you have. Right? According to that, you can directly answer. Right? That which is the bond order, which is what. Right? Now, one student is asking, students are asking, ma'am, what is this MOT? What is this? Wait a minute. Ma'am, what is this 2, 1, 2, 1, 1, 2, 2, 1? I'll just tell you that. Let us see this question. Assuming that Hund's rule is violated, the bond order and magnetic moment of. Sure. I think here also it's not that much in detail, so I'll rather show you the 1, 2, 2, 1 over here only, right? If you see 2, 1, 2, 1, 2 is this thing, that is pi 2px equals to pi 2py. 2, 1 is pi star, 1 is, wait a minute, 1 is sigma 2pz, right? Then again 2 means pi star 2px equal and pi star 2py, and this 1 is sigma star 2pz, right? Right? Z is the single person, it will always remain single, right? And 1, 2, 2, 1 means 1, 2, 2, 1. Here you will have anti-bonding and these are two bonding. This is sigma 2pz, this is pi 2py, pi 2px, this is pi star 2px, pi star 2py, and this is sigma star 2pz. Okay, that is 1, 2, 2, 1 and 2, 1, 2, 1. Right? Okay. Now, let us see the question here that we were doing. Let us see the question here that we were doing. Right, this was the question over here. Right? Now, the question is, assuming that Hund's rule is violated, the bond order and magnetic nature of diatomic B2 is? Right? Bond order and magnetic nature. So these two they are saying. So if we talk about B2 here, B2 is what? How many number of electrons? 1, 2, 3, hydrogen, helium, lithium, beryllium, boron. 5 into 2, that is 10 electrons in B2. Right? Now, what you have to do here, always subtract minus 8 electrons. Why you have to subtract 8 electrons? Because sigma 1 is sigma 2s, sigma star 1 is sigma star 2s. These are 8 electrons. These are always going to get subtracted if you have more than 8 electrons, right? So directly subtracted, you will have 2 electrons. That means now you have less than 14. Less than 14 means you will have 2 1 2 1 here. 2 1 2 1. So 2 electrons you will fill like this, 1 2, right? This is when we are applying the Hund's rule. What is Hund's rule, students? Hund's rule is that, ma'am, firstly you will, if you have degenerate orbitals, first you will singly fill all the orbitals. But if Hund's rule is violated, then what you have to do? That means here, firstly, all the degenerate orbitals will not be singly filled. This will be 1 and this will be 2. So now here you can see this is pi star, pi star, pi star, that this is coming out to be diamagnetic. That means no unpaired electron. And bond order, we know that bond order is what? Bond order is going to remain the same, right? 10 electrons means you bond order you can directly write, or here also you can see bonding means bonding you have 2 electrons, anti-bonding 0 divided by 2, that is 1. So 1 is the bond order. So answer will be A is the correct answer here. Right? Okay. Okay, students. This you should remember how to do the questions. Okay. So yes, MOT has trick for paramagnetic and diamagnetic also. Right. But I would not suggest you that, because sometimes in these kind of questions, you need proper concept. Okay. So if you are just following the tricks, then you will not be able to solve these kind of questions, which actually needs proper knowledge that what you're going to do here. Right? So answer will be B is the correct answer. Is that clear to everybody or not? Right? Is that clear? Is that clear? So answer is, sorry, A is the correct answer. Yes, A is the correct answer here. Right? Okay, I think that's it. Now we shall start with coordination chemistry. Acha, one more thing to remember in this, that for example, you have N2 positive, or let's say you have N2 negative. Now you tell me which you will apply, 1 2 2 1 or 2 1 2 1. Now here what you will apply? You have N2 negative, right? Number of electrons are coming out to be 14 plus 1, that is 15. Now what you will apply? That is more than 14 electrons. What you will apply here? What you will apply? You will think that, ma'am, here it is more than 15. So that 14, that means 1 2 2 1 will be applied. That is not correct. 2 1 2 1 will be applied, because originally in this N2 you have 14 electrons. You are adding 1 electron to that. So whenever an ion is given to you, you have to take the original thing, that is what is the neutral molecule we are having. From there you will choose whether it's 2 1 2 1 or 1 2 2 1. Okay, understood? Right, very good. As the parent atom, yes, very good. The parent atom you have to choose. Next is coordination chemistry. Students, from coordination chemistry, one is this chart is very important for you. All the exceptions are here. That cobalt 3 positive with water and oxalate is strong free ligand. Copper 2 positive with water. Water is a weak free ligand, but with copper 2 positive, it will start acting as a strong free ligand. With fluoride ion is a weak free ligand, but nickel 4 positive, it is act as a strong free ligand. Right? Now NH3, it is a strong free ligand, but with Fe2 positive or Mn2 positive, it will start behaving as a weak field ligand, right? Then 3D series elements up to +2 oxidation state form outer complexes like sp3d2 up to NH3 in the spectrochemical series. After NH3, they will not form sp3d2. Up to NH3, they form sp3d2, right? Next is compounds of platinum, PD and AU with coordination number 4. They prefer D2, DsP2 kind of hybridization, that is square planar. That you should remember. Now, VBT also, I'll just show you the question here so that with the help of question only we are going to solve this, right? Okay. Because see, application is important for you. Chalo. Now let us see this. The question is, in which of the following complexes the center metal atom is this hybridized and complex is diamagnetic in nature? Right, so one by one we will see how to answer this. First thing is you have CO, NH3, right, 6 and this is Cl3. So I'll firstly you will calculate the oxidation number. That is x plus 0 is equal to, this is 3, so this will be plus 3, plus 3. So here cobalt will be in the plus 3 oxidation state. Cobalt, we know that cobalt is what, students? Now, before this, you should also know one thing, okay? You should also know one thing before doing this. The electronic configuration. Saktiv Karman Piko Ni Pujan. Okay? This also should be on your tip. Okay? Only then you will be able to answer the questions from coordination chemistry and DNF block, right? Okay? So here it is, just draw 4s, 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 4s and 4s. This is 3D, 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 3D. Now it is from 21 to 30. So just write it here, 21, 22, 23, 24, 25, 26, 27, 28, 29 and this is 30. Now if you write it down here, this is 2, 1, this is 2, 2, this is 2, 3, this is 2, 4, 2, 5, you will just skip this. Acha, one more thing. Chromium and copper has exceptional electronic configuration, just skip this. Manganese is 2, 5, this is 2, 6, 2, 7, 2, 8, copper is exceptional. Zinc will be 2 and you are left with to complete 30, you need 10 more, so it will be 10. Now, if you see this thing here, chromium is 1 and 5 instead of 2 and 4 because of half-filled configuration. This is 1 and 10 because of fully filled configuration here. Right? Okay? Yes, very good. This is very important for you. If you know this thing, you will be able to answer the question of magnetic moment and this hybridization questions. Okay? So now let us see. Firstly, calculate the coordination oxidation number, that is cobalt 3 positive. So here we know that, if I write it down, here we know that cobalt 3 positive is nothing but 27 means 4s2 3d7. You take out 3 electrons, it will be 3d6. Now NH3 is a strong field ligand here, so it will cause the pairing here. So it will cause the pairing like this. You will have 1, 2, 3, 4, 5 S and this is P. Okay, so it will cause the pairing. It will be 1, 2, 3, 4, 5, 6. And you will be left with how many electrons? D2sp3, right? So that means the center metal atom is D2sp3. They are saying which of the following is D2sp3. So 1 is definitely D2sp3. So B and D are eliminated. 2 will also be D2sp3 because this is both in both the options, but still we will calculate it, okay? So in 2 if you see, the oxidation number is, here you have 3, so here it will be minus 3. So it will be X, this is going to be X minus 6 because oxalato has 2 negative charge, right? Oxalato is basically this thing, right? This is oxalato that has 2 negative charge, okay? So here you will have minus 6 equals to minus 3. That means X is equals to plus 3. Now if you see this here, this is cobalt plus 3, right? How we are going to make the questions here? This is cobalt plus 3. This is going to be 3d6. Now students, we have seen one exception that cobalt in plus 3 oxidation state, if you have oxalato, this will start behaving as a strong field ligand. Although oxalato is a weak field ligand. But with cobalt 3 positive, it will behave as a strong field ligand. it will definitely cause the pairing 1, 2, 3, 4, 5, 6, and you will be left with, because it has 6 coordination number, you will be left with D2sp3. That is the correct answer. Last one, let us see that. Last one, let us see that. That is zinc. Here you have zinc H2O. This is minus, this is 2, so this is going to be plus 2. Because NO3 has minus 1 charge, over here it will be plus 2. So it is going to be X plus 0 is equals to plus 2. So zinc is in plus 2 oxidation state. Zinc we know that is 4s2 3d10. In plus 2 oxidation state, it will be just 3d10, right? It will be just 3d10. Just 3d10 it is going to be. Yes. Ma'am, oxalato is strong field. Beta, that's why I told you this, na? That's why I told you this chart here, right? That was the chart. I know these things, you know, but this is the important part. These are the exceptions, okay? That's why I have written the exceptions here. Cobalt 3 positive, if you have water and oxalato, both will behave as a strong field ligand. If you have copper 2 positive, water will also start behaving as a strong field ligand. Okay, that's why this exceptional chart I told you. Right? Okay? Yes. Now let us see these things here. Okay, where is the question? Yes. Here you have. So now here you have water. In zinc, it is behaving as a weak field ligand only. So it will be 1, 2, 3, 4. This is S and this is P. Here you will have no pairing. So you will have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So answer will be sp3 D2. Okay, the 1, 2, 3, 4, 5. Right? Okay, sp3d2, that means answer is going to be A and 2 only will behave as a D2sp3 compounds. That is inner octahedral complexes. So answer is going to be A is the correct answer. That is 1 and 2 only. Right? Next is a question again based on this. Right? So match the following complexes with their magnetic behavior and hybridization. Right? So here directly we will try to solve this question. Everybody try to answer this yourself also. Try to answer this yourself. Right? So in this case, what you have to do is, you have cobalt. We know that cobalt is in plus 3 oxidation state because this is neutral. This will be X minus 4 is equals to minus 2. So this is nickel 2 positive. Right? This is X minus 6 is equals to minus 4. So it will be iron 2 positive. This is X minus 4 is equals to minus 2. So this will be nickel 2 positive. See, one thing you should remember. When you have 6 coordination number, it can be sp3d2 or d2sp3. That is octahedral. If you have 4, it can be sp3, that is tetrahedral. If you have 4, it can be dsp2, that is square planar. Right? Let us just, this is a must question, right? Okay? Right? Now here, if you have cobalt 3 positive, right, this is going to be, we know that 4s2 3d7. So it is going to give 3 electrons, it is going to be 3d6. Nickel 2 positive is going to be 4s2 3d8. 2 electrons you take out, it will be 3d8. Iron is 4s2 3d6. You take out 2 electrons, it will be 3d6. Nickel 2 positive is 3d8. Right? Now, you have to see which is strong field, which is weak field. Right? So, if you see, this is strong field. Right? This is weak field. This is strong field. This is strong. Okay. So, in first case, you will have D2sp3. Why? Because there will be pairing 1, 2, 3, 4, 5, 6. You will be left with D2sp3. So, answer will be D2sp3. Right? You will be left with which thing? D2sp3 orbital you will be left with. In this case, there will be no pairing. So, his answer will be 1, 2, 3, 4. Here it will be 1, 2, 3, 4, 5, 6, 7, 8. So, here answer will be sp3. No. Here answer will be sp3. Because coordination number is 4, right? So, it will be sp3. That is, it is going to be your Wait a minute. sp3, no? So I'll just also write the answer here. First is diamagnetic and D2sp3, diamagnetic and D2sp3. That is there. So this is for A, right? Then you have para because of unpaired electron and sp3. sp3 and para, that is for B. Okay. Then next one is strong free ligand. Here also we will cause the pairing. So it will be again 1, 2, 3, 4. So it will cause the pairing. So it is going to be 1, 2, 3, 4. No. 1, 2, 3, 4, 5, 6. Here you have 6 unpaired electrons. Again it is, wait a minute. Again it is the same thing only. So let us see. A is 3, 3, 3. C should also be 3. Achha. C will also be 3. है ना? Because C is also 3. That is also there in the option. C is also 3. Right? Because this is also D2sp3. But this is also diamagnetic. In this you have strong free ligand. Again, what will happen? 1, 2, 3, 4. Electrons will be paired here. 1, 2, 3, 4, 5, 6, 7, 8. You will be left with dsp2 and this is diamagnetic. So this is going to be D. Right? So D is 1. D is 1. D is 1. B is 2. Is it? B is 2. Yes. So answer will be C is the correct answer here. Okay? C is the correct answer here. Is that clear to everybody or not? C is the correct answer here. Is that correct? Is that correct, students? Chalo. Now, next is based on CFSC. Now, for that, we have to understand what is CFSC. Chalo, let us understand CFSC here. In CFSC, you have basically two things. One is octahedral splitting, the other is tetrahedral splitting. See, in the octahedral field, if you see, we know that it is along the axis. So those d orbitals which have electron density along the lobes, they will have high energy. That is why in octahedral, dz square and dx square minus y square, they will be of high energy and less stability because both of them are of the same thing, that is octahedral field. They are along the axis and in this case they are along electron densities along the loops, right? So this is Eg and this is T2G. Here it is 2 by 2, this is minus 2 by 5, this is plus of 3 by 5, right? Okay. So now what you need to answer here is this is delta O properly, right? And here, if you have a strong field ligand, just remember one thing. Let's say you have a strong field ligand. That means CFSC will be high. That means this gap will be high, right? If you have a strong field ligand, that means CFSC will be high. That means this gap will be very high. If this gap is very high, there will be a pairing of electrons. There will be pairing because the electron, let's say you have 1, 2, 3 electrons, fourth electron, if this gap is very high, fourth electron will fill here only, right? If you have gap is very less, then the fourth electron will fill here, right? So pairing will happen in this case, and that is why this will be a low spin complex. Okay, these are the different terms to represent the gap that you will have. They can say it's a low spin, it's a pairing will happen, CFS is high, this is a strong fill. Usually students mostly get confused in low spin complexes. What is that? Where you have strong field. Okay, so because here pairing is happening, so in that means delta O is greater than pairing energy, right? Let's say you have two options to purchase delta O or pairing, right? But pairing has less money. That means less money you need to give for pairing. Let's say this is chocolate, this is pizza, right? Pizza you are getting for less money. So you will try to get pizza, right? Okay, because you are getting that for less money. So that's why for less money you have pizza. That's why we will cause pairing here, right? Okay, that you should remember, right? Then there is this, I have already told you that for strong field reading, there is delta O is greater than P, right? Okay. Then there is spectro. Acha, one more thing that in chalo, firstly let us talk about this thing here. In spectrochemical series, you should must remember this whole series here, and remember the factors here that CFSC is more as oxidation number increases, and CFSC is more down the group. Down the group also CFSC increases. Okay, that you should know, right? Okay. Then last is tetrahedral field splitting. Here, you should remember one thing, that delta T is equals to 4 by 9 of delta O. That means it is approximately half. That means the gap is always going to be less. So always it is going to be mostly high spin complexes are formed. That means the gap is always less. Gap CFSC is always less, right? Because in tetrahedral field, even if you have a very strong ligand, even then very rare chances that it will cause CFSC, the gap will be very high, right? Okay. Now let us do some questions based on this as well, right? So I'll just show you the questions here. That is here. Okay, sure. Now let us see the questions over here. First is, you have what will be the CFSC for a D6 high spin complex for both tetrahedral and octahedral complexes. Now, tetrahedral complexes I'll draw, octahedral complexes I'll draw. Students, tell me what is a tetrahedral complex? Tetrahedral complexes when you have 1, 2, 3. When you have 1, 2 and this is 1, 2, 3. Octahedral is 1, 2, 3 and this is 1, 2. And they are asking you high spin. High spin means that is going to be weak field ligand. Okay, high spin means weak field, no pairing, right? 6 means you will have 1, 2, 3, 4, 5, 6. Here you will have 1, 2, 3, 4, 5 and then 6, right? So here if you see, from the berry center you have to calculate it. So what you will do, this will be, wait a minute, just give me a second. In points we have to see this, right? So, yes. Okay, so remember this thing, that this is going to be, in octahedral, this is going to be 0.4 and this is going to be 0.6. This is minus and this is plus. If you talk about in tetrahedral, I'll just write it here as well, right? This is going to be, because when you go through the notes, this will be minus 0.4 delta O. This is plus 0.6 delta O, right? In this case, in tetrahedral, right, this is plus 0.6 delta O, minus 0.6 delta O. This is plus 0.4 delta, right? That is totally opposite, right? Now I'll just see it in the question here, right? Now, if you see this here, calculations of this less delta, ma'am. Which delta, ma'am? 3 down, 2 up. Very good. Now, this is minus of 0.6. This is plus of 0.4. So, you just calculate it according to that. Minus of 0.6 multiplied by 3 electrons plus this is how many electrons you have? 3 here. This is plus of 0.4 multiplied by 3. So that is going to be 1.3. So 18. This is 1.8. So this is going to be 0.6. This is going to be minus 0.6. The delta O is going to be minus 0.6 here. Right? In tetrahedral, this should be minus somewhere. Okay. So this will be minus 0.6. If you draw this here, it will be minus 0.4 multiplied by 4. Right? Plus this is plus 0.6 multiplied by 2. So this is 1.2, 4, 4, 16 minus 1.6. It is going to be minus 0.4. So answer is going to be, what will be the CFSC? Answer will be 0.6 and 0.4. That is D is going to be the correct answer. Okay, D is going to be the correct answer here. Ma'am, can you repeat why gap is less in tetrahedral? Gap is less in tetrahedral, that is because CFSC, that even in tetrahedral, because of the unsymmetry there, even with strong field ligand, it is not able to cause pairing of the electrons. Okay, that is the reason, right? Okay. Next, let us see which of the order, what is the correct order for the following compounds. Now, these compounds are given to you. If you see, we know that here you have CN, here you have CN, here you don't have CN. CN is a strong field ligand as compared to water. So, more the number of CN, more will be the splitting, more will be delta out. So, third is going to have maximum, then second, because here you have 4 CN, here you have 2 CN. Here you have no CN, that is why it is 1. So, answer is 3, 2, 1. So, answer is A will be the correct answer here. Okay. Yes, everybody, A is going to be the correct answer here. Is that clear? Now, other kind of questions are based on the electronic configurations, right? Let us just see that. First, theories I have taught you, then there is electronic configuration questions that they can ask you like this. So, they will give you some ions here. They can ask you the magnetic moment, that will be based on the electronic configurations. Here you should remember one thing, that if you have, let's say, these are the number of unpaired electrons, this is the magnetic moment. So how you will answer this? This is mu, this is number of unpaired electrons, right? So mu is, let's say, number of unpaired electron is 1, 2, 3, 4, 5. So mu is 1.7, 2.8, 3.8, 4.9, 5.9. That is how you're going to answer the value of mu. But also you should know the formula. Mu is equals to under root n plus 2 Bohr magneton. That is the formula for mu, right? Okay. Now we are going to see how to answer these questions, right? Let us see that. How to answer these questions here. So if you have chromium, for this you only need to know the electronic configuration. Otherwise, this is a very, very simple question, okay? Only one student is active here. Yes, others are sleeping or what? Solving. If you're solving the questions, then answer. If you're not solving the question, then what you're doing, right? So this is chromium. Chromium, we know that it is 4s1, 3d5. 3 electrons taken, it will be 3d3, right? So answer is 3d3 here. Here you have iron is 4s2, 3d6. 2 electrons taken, it will be 3d6. Nickel is 4s2, 3d8. 2 electrons taken, it will be 3d8. Manganese is what? Manganese is 4s2, 3d5. 2 electrons taken, it will be 3d5, right? Copper is 4s1, 3d. Copper is 4s1, 3d10. 2 electrons taken, it will be 3d9. Now you just have to answer how many unpaired electron. Firstly, you see here. Unpaired electron is 3, right? If you see this here, unpaired electron will be 4 because it will be 1, 2, 3, 4, 5, 6. 4 unpaired electron. Here it will be 1, 2, 3, 4, 5, 6, 7, 8. 2 unpaired electron, right? Here it will be 5 unpaired electron. Here it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 1 unpaired electron, right? Now you just have to fill it in the formula. So that means here it will have under root n. N is 3, 3 plus 2. That is 5, 3, 15. Right? Under root 15. That means 1 is 2. 1 is 2, 1 is 2, 1 is 2, 1 is 2. This is eliminated. Right? Then you will see for iron, this is 4 electrons. So this is 4. 4 plus 2, 4 plus 2, 6, 6, 4, 24. So this will be under root 24. So that means 2 is 1. 2 is 1. 2 is 1. 2 is 1. This is eliminated. Right? Let us see for third one. It is having 2 electrons. So 2, 2 plus 2, that is 4 to 8 under root 8. Under root 8 is 5th. So 3 is 5th. So answer will be B is the correct answer. Okay. 4 is what? 4 is 5 electrons. So it is under root 5. 5 plus 2, 5 to 10. 10 into 5, 50. Huh? What? 5, 6, acha, 7 5s are 35. Okay, under root 35. So this will be 3. 4 is 3. Right? Last one is 1 electron. This is 1. This is 1. 1 plus 2, that is 3 into 1. This is under root 3, that is 4. Right? So answer is going to be B is the correct answer here. Okay, answer is going to be B is the correct answer here. Understood how to answer all of these? Right? These are some standard questions. Okay, then based on color also they can ask you the same question. Same thing you will apply. You will use the electronic configuration only. Just remember, for colorless, you should have D0 or D10 configuration. You just have to look for D0 or D10 configuration. If you see this here, copper positive is 3D10 because you take out electrons from 4s. Copper 2 positive is 3D9. Titanium is 22. So it will be 4s2, 3d2. You take out all the electrons, this will be 3d0. Vanadium is 23, which is 4s2, 3d3. You take out 5 electrons, it will be 3d0. So that means this one is your colored species because this will show dd transition. So answer will be B is the correct answer here. Rest of them are colorless, right? Brain not braining, ma'am, is it? Then you have this electronic configuration here. Very important. This is also a question from electronic configuration. Here, what all you have to remember is the electronic configurations of this thing, and this one. This, and here you have to remember the electronic configuration of 4f7 and 4f14. That means what you should remember, that lanthanum 3 positive, lutetium 3 positive, and gadolinium 3 positive, they are in stable configuration. Europium 2 positive, and you have ytterbium 2 positive, they are in stable. Terbium 4 positive, and you have cerium 4 positive, they all have the stable configurations. So out of this is going to be very, very important. Okay, this table is a very, very important. The electronic configuration that I have specially marked for you, from there they ask the questions. Okay, from there they ask the questions, right? Okay, now this exceptional trends, I will not repeat it today. Yesterday also I told you. Let me just show you in the live sessions here only. So if you see in this Vedantu NEET English live, you will see here, right? Over here you will have the NEET Organic Chemistry, right? Okay. So you have here Inorganic Chemistry, all exceptions and important lines here. All the exceptions and important lines of Inorganic Chemistry I have taken yesterday only. This lecture is for 1 hour, 18 minutes, right? So you should watch this lecture, okay? If I include in, that's why I took that lecture yesterday, so that I know at this point your brain will stop braining, right? So that's the reason I took that lecture yesterday, right? So you can go and watch that so that your exceptional trends we can do, right? Okay, because there are a lot of exceptional trends that you have, and exceptional trends also they ask you the question, 2 or 3 questions directly they can ask you from important exceptional trends like ionization enthalpy of group number 13, radius of group number 13. Then 2 questions I have picked here specially. Which of the following order is incorrect, right? These kind of, this is a sample question I am giving you, that what kind of question will be there. Which of the following order is incorrect? Okay, so if you see this, bond length order, oxidizing power is correct. Bond dissociation enthalpy, fluorine, chlorine, this is incorrect. Boiling point is also correct. This is the incorrect order. You know what happens in the bond dissociation enthalpy? Because fluorine has a very small size, right? We know that down the group bond dissociation enthalpy should decrease, right? Fluorine should have maximum bond dissociation enthalpy because it has the smallest size. Down the group size is increasing, bond length is increasing, bond dissociation enthalpy should decrease. But in reality, because fluorine has very small size, small size, and 3 lone pairs. 3 lone pairs. So there will be electron repulsions here. There will be electron repulsions here, and that is the reason, right? It will be not a very stable bond. So that will be correct order will be chlorine, bromine, fluorine, then iodine, right? I have just picked up 2 questions here. Otherwise, all the important exceptions I have given you in that, right? Correct bond association energy order is going to be what? Correct bond association energy order. Chlorine, fluorine. Acha, this is the same question only. So answer will be chlorine, bromine, fluorine, and iodine. So answer will be B is the correct answer here. Right? Okay. Yes, students, by this we also completed inorganic chemistry, right? We also completed inorganic chemistry. Again, I am saying those students who are writing this and that, ma'am, chromatography, beta, I am picking the important topics here, right? Otherwise, we have already completed like everything in class 11th and 12th. I have completed in that marathon, right? I am picking only the important topics for you that are there. Otherwise, I have even not done coordination, chemistry, isomerism, right? I have done it there, right? So I am picking only those things which will give you 130, 140 plus marks, sure shot, right? Okay, yes. Now let us see. I know you need break for physical chemistry here, but before that, students, in the description box, you have this revise-a-thon that is going on currently from 16 to 29 till 29th of April. It is still going on. The PDF session is also in the description box, and test series is also provided to you totally free of cost. That is based on NEET 2025, and there is one study buddy. So you just need to click on this QR scanner that is provided to you here. Click on this and you will get to the study buddy, which will help you in next 1 week, your study plan, everything, right? Then for those students who are looking for NEET PYQs and NEET question paper of 2022 to 2024, then that is also available to you. Just click in the download now button, right? And you will get all the PYQs there. This is also totally free of cost. Okay. Yes, students. And for the offline coaching, you can advise your juniors. And if you are also thinking about 2026, one more attempt, I don't want you to do that. But still, if you think that, okay, my marks, I don't want you to think about negative things here. But yes, if you're right now, you have taken the decision that I'll take NEET 2026 attempt, then these are the offline courses for you in which 40% scholarship is right now going on, right? And when you enroll to IV SAT, then by the test, admission test, okay, what are the marks that you will get? According to that, you can even get 90% scholarship here. Everything is in the description box for you, okay? Everything is in the description box for you. Now, students, we are left with the, okay, ma'am, I doubt more electrons, more ID. No, ma'am. So hard to break down the group. Which you are talking about, right? If you're talking about exceptions, then you can watch it on the other lecture, right? Now, students, I'll take break, right? So, do you want break or not? Firstly, let me know. Physical chemistry we are left with, right? We are left with just physical chemistry, right? It's 4 p.m. I will give you break for 10 minutes, right? I think 10 minutes break is enough, or you want 15 minutes? How much time you want? How much time you want? Everyone, let us see. You have not even completed the target, huh? Ma'am, please, ma'am, break, ma'am. Okay, firstly, what target you want me to set? I see you don't like the sessions, huh? Target is 500 plus likes. Okay, let us see if you're able to achieve that or not. Let us see if you're able to achieve that or not. Sure. 10-minute break, ma'am. Enough? Yes. So I'll give you 10 minutes break. Now the time is 4:01. So I'll see you at 4:10. Okay. At 4:10 p.m. I'll see you all. Then see you after the break, okay? Chal. Eyes paining, ma'am, 15 minutes. Yes, ma'am, little ma'am. Till I'll give 10 minutes break, okay? You can just relax for 10 minutes, right? Okay? Or 15 minutes. Till I'll give 15 minutes only. You can relax. Because, for physical chemistry also, you need, brain should work for physical chemistry, right? Then someone is saying, ma'am, 5 minutes break. So after this, there will be no break. After this, I'm going to end physical chemistry, right? So that is going to be around 1.5 or 2 hour session after this, right? Okay. So I'll see you after the break. Hello, hello. Hi, students. I'm back. So, everybody, yes, I can't see ma'am. I can't. Ma'am is invisible. I can't see ma'am. Beta, I am here, right? Okay. So, now let us start with the physical chemistry questions. Physical chemistry important formulas. So, everybody ready for physical chemistry important formulas? Must do formulas of physical chemistry, right? Let us finish that. And I'll start with the physical chemistry. It is okay, it is here. Right? Let us start with physical chemistry. Right? Okay, everybody. Shall we start with physical chemistry, everyone? 3D series. Array, nothing, no trick I did. I just wrote the electronic configuration here. Let me just see where I wrote that. Wait a minute. Huh. So what you have to remember, this is from 21 to 30. Saktiv, Karman, Fiko, Niko, Jan. Okay, so 2, 1, 2, 1, 2, 2, 2, 2, 2, 3, 2, 3, 2, 4 is exceptional. 2, 5, 2, 5, 2, 6, 2, 6, 2, 7, 2, 7, 2, 8, 2, 8. 29 is exceptional. Then 30 is 2 and 10. That is how to write the electronic configuration. Always take out the electron from 4s first and after that take out the electrons from 3D. Okay, I can't see your energies in the chat box, otherwise I'm going to end the class, right? So if your energy is there, there is no stupid person out there who is standing here for last 5 hours and you guys don't even like have that much energy to type something that yes ma'am we are ready or something, right? What do you expect from me then, right? I'll be very happy over there. I'll be very happy with your behavior or what? Why you want to see this like anger kind of Diksha ma'am? Why you want to see this? Right? Can't you see me smiling, happy? All of that is not. I don't know what is this attitude that you guys are having. That we will not reply this person. You know what? If someone out there is doing some share shairi, anything they are speaking against some breaking news will do, right? Then you will just all randomly come here, right? But when someone is providing you the genuine content, you will be like totally like taking everything for granted. What is this kind of attitude, guys? Like, do I have to scold you to tell you that okay, I want to know if I'm asking you something, right? Is this a recorded version or should I put recorded lives here? Right? How can I smile? I don't know. I just don't understand that thing that sometimes the behavior that you guys show. I always get, yesterday I literally was very, very disappointed by like students, but still I was still sitting till 2 p.m. and making 2 till 2 a.m. and making these PPTs for you. But still, what I feel is all of this thing is useless. And what all you want is you just want to sit, do nothing, right? You don't even have that much respect for the person who is sitting there, who is standing there for hours and hours just to teach you, just to save your time here, right? Otherwise, I have already done these things. I'm still doing the most important topics here. But I would have just told you, class 11 and class 12, take the 8 9 hours you can cover, right? But still I am teaching you the most important topics. I'm not just giving you one simple video on that these are the topics you do. I'm teaching you the topics myself, right? But still you guys have no respect for that thing. If I am asking you one time that okay, shall we start physical chemistry, you guys need to answer yes or no. Yes ma'am, in anything you can answer, right? But what I see is no comments. Whenever I was, in fact, when I was teaching you inorganic chemistry also, you guys were such low energy. Beta, I'm standing here for last how many 11:30 am I'm standing here, right? You guys are sitting. Understand the difference, right? You guys are sitting, I'm standing, and I'm not even well. I just took medicine. But still, ma'am, we are don't have enough. How much time it takes to write yes and no? It just takes just 1 second. How much time it takes to get engaged in the conversation that will be happening here? Just 1 second, right? But still, I see that I don't know here. I don't know what you want me to do. Should I dance here? Should I sing here? Then you all will gather. You'll say, yes, ma'am, oh, we are enjoying. When I talk about, because at this point, I'm totally talking about the content, totally focused on the content. I'm focusing on like making the best PPTs for you, making everything best for you, right? But still taking things for granted, because the problem is that so much content is provided to you on YouTube for totally free of cost, that you think that okay, what if the teacher is standing here, we don't care, right? Let's start the physical. Now see, Mr. Gaming, these kind of people are already there. Okay, dance. You dance here, right? Get millions of views. I'm not kacha badam girl, beta. Okay? I'm a teacher, so I can't do that, obviously. Otherwise, by dancing, though, definitely anyone could have like a lot of views, right? But teaching, that is a task, right? Okay. So now let me know in the chat box if we should start or not, right? Please wait a minute. Let's ignore. No, I don't believe in banning anyone, right? Dogs always bark, so I don't care about them, right? So you can just see this. Now let's start physical chemistry, and I want full engagement in the chat box, okay? Right? Full engagement should be there in the chat box. Otherwise, my energy also starts dropping. By seeing that the chats are constant, my energy drops, and then I don't feel like teaching. You understand one thing? You are not sitting in front of me. I am not seeing your expressions. I don't know if you're able to understand or not. I don't know if you're interested or not. This is the only chat box which actually makes me feel that okay, these guys are listening to this. Right? Only then I'll be able to see that okay, these students are learning something. Otherwise, I have no idea. You may be sleeping there while I'm teaching, right? So that's the reason I'm asking you to be active in the chat box so that I can also know that okay, you guys are able to understand. Okay? Yes. Now, the last chunk of this chapter, this session is physical chemistry. So I'll give you not all the formulas, just very, very important formulas of physical chemistry that are must for you. All the important formulas, all the formulas of physical chemistry, I'll make a different video on that. But here, just important formulas, okay? First is, if you talk about physical chemistry, first is you should know the concentration terms here. So let us talk about percentage weight by weight, percentage weight by volume, volume by volume. It is always solute by solution. If you have weight by weight, this is weight by weight by volume, and volume by volume. Now remember that in this case, weight is always in grams and volume is always in milliliters. That you should remember, right? And because of percentage, that is multiplied by 100 here. If you have parts per million, then this will be multiplied by 10 raised per 6. If you have ppm, then the same thing will be multiplied by 10 raised per 6 instead of 100, right? Next is very important formulas, that is, first we have mole percentage, that is moles of solute by total moles multiplied by 100, that is the mole percentage. Mole fraction is moles of solute by total number of moles, that is the mole fraction, mole of that component divided by the total moles. If you multiply mole fraction with 100, that will be your mole percentage, right? Molarity is number of moles of solute divided by volume of solution, and this volume is in liters. Molality is number of moles of solute divided by mass of solvent, that is in kilograms, okay? And always remember, 2 we represent solute and by 1 we represent solvent, okay? That is how I represent. In most of the books you will see this representation only, right? In most of the books you will see this representation, right? Then the next one is parts per million. I have already told you, you will multiply it by 10 raised power 6, right? Then if you see the important parts here of this thing, concentration terms we have done, right? Next one is strength. So strength is equals to weight of solute by volume of solution in liters. That means if you compare molarity and strength, strength is equals to molarity into mass, molar mass of solute. And the formula between molality and weight by weight percentage, this is the formula between molality and molarity. Okay, this is a very, very important formula that can be directly asked to you. The formula between molality and molarity, that is molality is equals to 1000 into molarity divided by 1000 into density minus molarity into molar mass of the solid. That you can directly tell, right? Next is moles, that is in three parts, given by divided is given weight by molar weight, or you can say given particle by Avogadro's number, or given volume by 22.4. 22.4 is when you have 273 Kelvin and 1 atmospheric pressure, right? That is going to be it. Then when they ask you the empirical formula, empirical mass, remember that molar mass is equals to 2 into vapor density. Vapor density will be given to you. Molar mass you can easily calculate from there. Now let's say percentages are given to you for different elements. So percentage by atomic weight will be the moles. You will calculate this in the simple whole number ratio. That will be your empirical formula. And this molecular mass you have already calculated. From their empirical mass you can calculate. So N is equals to molar mass by empirical mass, and molecular formula is empirical formula and subscript is N. That is your answer for molecular formula you can calculate. Now for limiting reagent question, remember that given by stoichiometry, given is given to you in the question, and limiting reagent questions are when you have all of them are given to you, all the reactants, the moles of all the reactants are given to you. So given by stoichiometry in the balanced equation, the smallest number is going to give you the limiting reagent, right? That is, product depends on the limiting reagent. And then once you calculate the limiting reagent, whatever they ask you will be dependent on the limiting reagent, right? Then next one is then atomic structure. In atomic structure, let us see some of the very important formulas. That is, E is equals to H mu, or you can say Hc by lambda. Now, if you put the value of Hc here, directly you can know that 1240 divided by lambda. Okay, if you put E is equals to 1240 divided by lambda in nanometers, you can get the energy value in electron volt here directly. Okay, so you can directly put the formula here instead of Hc, because H is Planck's constant and C is the speed of light. So you can directly put these values and put the lambda in nanometer. What if they have asked you in meter? You convert nanometer to meter or Armstrong, whatever they have asked you, right? Okay. Next is total energy here. Bohr formula, basically this is from Bohr's atomic model. So this is the formula of total energy, that is in electron volt, right? Minus 13.6 Z square by N square. And potential energy is, if this is 2 times of total energy, right? 2 times of total energy. And kinetic energy is minus of total energy, right? So this is 2 times total energy. You multiply it by 2, you will get the value of potential energy. You just put the opposite sign here, you will get the formula for kinetic energy, right? Okay. Next is for radius, very, very important. This is very frequently asked. Radius of nth orbital is 0.529 multiplied by n square by z. Velocity is 2.18 into 10 raised to 6 z by n. Frequency, you don't have to remember the formula here. Just remember that frequency is directly proportional to z square by n cube. Just remember this thing. Okay. And time period, if you see, that is inversely proportional to this. So it will be n cube by z square. Okay. You should also remember the proportionality here. Right. Okay. Ma'am, sometimes your voice is low. Is it? The voice is low. Is it the thing? Hello, hello, hello. Now is the voice clearly audible? Okay, so this formula, these formulas are very, very important. Okay, most important formulas for Bohr atomic model, right? Then Bohr model, if you see, right? Okay, time, this we have seen. Energy difference. Okay, for this you should know that what is Rydberg equation here? This is the Rydberg equation, that is 1 by lambda RH. This should be directly, you can write it 1 by lambda RH z square 1 by n1 square minus 1 by n2 square, right? Now this RH has directly, it is 109700 centimeter inverse, and 1 by RH is equals to 920 angstrom. I think 902 angstrom, right? You should remember the value of 1 by RH also, so that if they have asked you the value of lambda, let's say, then calculating the value of 1 by 109700 is very difficult. So rather than, you can just put the value of 1 by R here in angstrom and you will get the value of lambda in angstrom. Now, ma'am, what will be the value of N1 and N2 here? For that, what you should remember, that there are series called Lyman-Balmer-Paschen. I'll just show you the series also. There are series called Lyman-Balmer-Paschen and bracket and P1. So Lyman series is n is equals to 1, Balmer series is n is equals to 2, Paschen series is n is equals to 3, bracket Lyman-Balmer-Paschen bracket P1. So it is bracket series is n is equals to 4 and P1 series is n is equals to 5. So here we are talking about N1 here. What is the value of N1 according to the series? Now, Lyman series lies in UV range, so n is equals to 1, and Balmer lies in visible range. This also you should know. What if they don't give you that this is Lyman series, they give you the ranges here, right? Then for N2, remember that if you have alpha line, you will N2 will be N1 plus 1. For beta line, N2 will be N1 plus 2. For gamma line, N2 will be N1 plus 3. Okay, that is the value of N2 here, right? Then there is last line or limiting line here. So what you should remember here, right? If you have limiting line or last line, there N2 will be equals to infinity. And always remember, because E is directly proportional to mu and inversely proportional to lambda here. So if we are saying that minimum energy, that means energy is minimum, right? And lambda is maximum. That is why here we have written maximum wavelength. Okay. So they can also write shorter wavelength. That also correspond to N2 is equals to N1 plus 1. Okay. That is how you're going to tell the value of N2 here. Right. Okay. Then next is, what is the spectral lines? So what if they have given you that the total number of spectral lines from N2 to N1, what will be the total number of spectral lines? That will be N2 minus N1 divided by, wait a minute, this will not be divided, wait a minute, this is wrong, just make it correct. This will be N2 minus N1 multiplied by N2 minus N1 plus 1 divided by 2. For example, they have given you 3, 2, or they have given you 6 to 4. So this will be 6 minus 4. 6 minus 4 plus 1, that is 3. 3 into 2, 6 divided by 2. So that will be 3 spectral lines will be there. Okay. So that is how you calculate the total number of spectral lines. Okay. Right? Okay. Next is that this also we have done. This also we have done. Atomic, yes. Next is photoelectric effect. For this, remember H mu. Just remember that H mu, the incident light, is equals to H mu naught plus kinetic energy. This is called the work function. This is the incident light and this is the kinetic energy here. That is your kinetic energy for the photoelectric effect. Right? Now we know that kinetic energy is also equals to EV. V is the stopping potential. So you can also put the value of kinetic energy as EV, or you can also put it as half mv square. Both the values you can put here, right? Then de Broglie wavelength is lambda is equals to h by mv, where mv is the momentum here, right? So you can just directly put the values here, right? One more thing to remember in de Broglie wavelength, that when you talk about a circle here, okay, we are saying that in a circle, the value is 2 pi r, because circumference of a circle is 2 pi r. This is according to particle nature, this is according to wave nature. And here you have n number of waves, so you can write n lambda. These two will be equal to each other. This is also a very, very important formula here, right? Then, the Heisenberg uncertainty principle is lambda. This is uncertainty in position multiplied by momentum is greater than h by 4 pi. We know that momentum is nothing but mass into velocity. So momentum uncertainty, velocity uncertainty is greater than equals to h by 4 pi. Mass will be in the division here, that is 4 pi m here, right? This is very rarely used, but you can just learn this. I would not advise you, you can just ignore this, right? Okay, because this hardly they will use anywhere, right? Okay, next is Schrodinger equation. Just go through this equation one, that the psi variation with x plus y plus z here, right? This should be y and this should be z here, right? That is equals to E minus V psi. Okay, that will be your random equation here, but you don't have to learn the equation. Remember the quantum numbers, okay, that are important for you. So principal quantum number, that is defined as n, right? Azimuthal quantum number, where its value will be 0 to n minus 1, right? Then magnetic quantum number will be minus L to plus L, that is going to be magnetic quantum number. Spin quantum number will be plus half or minus half always. Principal quantum number tells you the size or the energy, right? Azimuthal quantum number tells you the shape, right? Magnetic quantum number tells you the orientation, whether it's on x-axis, y-axis, z-axis. Spin quantum number tells you the orientation of electron, whether it's clockwise or it's anti-clockwise, right? Then there are some formulas to remember from here, that is orbital angular momentum. Let us see the formula of orbital angular momentum. Okay. Orbital angular, this question they have asked in JEE right now, they can easily ask you this again. So orbital angular momentum is h by 2 pi under root L plus 1. Spin angular momentum is h by 2 pi under root S plus 1. Spin magnetic moment is under root N plus 2 Bohr magneton, it should be, right? If N is the unpaired electron, okay. If N is not the unpaired electron, otherwise it will be N plus 1 under root. Maximum number of electrons in a shell, if they have given you shell, maximum number of electrons will be 2n square. If they have given you a subshell, then it is going to be 2l plus 1. In an orbit, you have maximum 2 electrons in an orbit, right? So these two formulas are very, very important, right? Okay, that when you talk about, let's say, maximum orbitals in a shell, that is n square. So maximum number of electrons in a shell is 2 into n square. Maximum number of orbitals in a subshell is 2l plus 1. Maximum number of electrons in an orbital is 2 into 2l plus 1. Okay. Next is you have total number of electrons here, orbitals in a subshell. Achha, this I have already told you, that is 2l plus 1. Number of subshells in a shell. If they have given you a shell, in that subshells are going to be n, right? Number of orbitals in a shell are going to be n square. Radial nodes are n minus L minus 1, very, very important. Angular node is equals to L and total node is n minus 1, n minus 1. Okay, that is the formulas, very, very important formulas. These all are very, very important formulas, right? Okay. Then next is equilibrium. So first I'll go through all the this is what you have, like I have that for you, don't worry. First I'll go through all the important parts of the physical chemistry, then we'll solve some questions based on that, right? So if you see this here, law of mass section, we know that it is Kc, product raised to power P, product raised to power stoichiometry, reactant raised to power stoichiometry. Now, the important formula here to remember is Kp is equals to Kc, RT raised to power delta Ng. That's a very, very important formula. And then what is the value of R you will put here? That is 1 by 12. Whenever you have liter and atmospheric volume and pressure is given to you, you put the value of R as 1 by 12. Okay, that is going to be the value of R. Next is how the variation of K will depend. Okay, so when, if say the reaction is reversed, K will also be reversed. If you multiply that with something, then that multiplication factor will be in the power. If you divide it with something, that division factor will be in the power. Okay, if you add two equation, their rate constant will be multiplied. If you subtract two equation, their their equilibrium constant will be in the division with each other, right? Next is, this is a very important formula, right, where they can give you the value of log K2 by K1 delta Ng, right? It's a very important formula. They can ask you the value of delta H, or they can ask you the value of T2, anything they can ask you, and they will give you K1 and K2 for two reactions at two different temperatures. For the same reaction, K1 and K2 will be given to you. They can ask you the value of delta H or anything like that, right? Then next is Lee-Chartley principle, which is very important for you. In Lee-Chartley principle, remember that whatever you will do, it will do the opposite of that, right? So let's say you are increasing the concentration. So it will try to decrease the concentration by moving backwards. Okay, that's how it is always opposite. But one point is, no effect on the solid component will be there. If you have any solid component, there is no effect of any solid component here, right? Then you have pressure. Pressure is always inversely proportional to number of moles. So if pressure is, let's say, increasing, then number of moles are less. That means if you increase the pressure, it will go towards that direction where number of moles are less. And it is directly, just remember this thing, that pressure is inversely proportional to number of moles and directly proportional to so if you increase the volume, it will go in that direction where number of moles are more. If you increase the pressure, it will go in that direction where number of moles are less. Okay. Next is with temperature, it varies. If you have exothermic, that means if heat is released here, then as you increase the temperature, equilibrium constant will decrease because they are inversely proportional. That is the reason here it will go in the backward direction. If you decrease the temperature, equilibrium constant will increase and it will go in the forward direction. So that depends upon whether it's endothermic or exothermic reaction. Last is inert gases. At constant volume, nothing will happen, but at constant pressure, number of moles, it will go in that direction. If you add the inert gas at constant pressure, it will go in that direction where number of moles are more. Okay, because you are variating the volume. We know with volume, it is directly proportional to number of moles. So, when you add inert gas, it will go in that direction where number of moles are more. Okay, that was about Lee-Chartley principle. Now, let us see some important formulas of ionic equilibrium, right, for you here. One thing is, you should know that pH concept. pH is equals to minus log of H positive, right? Directly you can know that. And Kw is nothing, Kw is the ionic product, that is equals to H positive concentration multiplied by OH negative concentration at 25 degrees Celsius, the value is 10 raised to power minus 4, right? That means pH plus POH is pKw, that is nothing but it is 14, right? Okay, now next is, let us do some pH calculations here. If you see you have a weak acid, then pH value is half into pKa minus log C. If you have a weak base, this will be half into pKb minus log C, right? This is pK, this is pKb, rest of the things are same, okay? Once you calculate POH here, then pH is equals to POH 14 minus POH. 14 minus POH. Then you can calculate the value of pH here. pH calculations of mixture of weak acid and weak base. Then it is H positive is equals to under root Ka1 C1 plus Ka2 C2. That will be H positive, and pH is equals to minus log of H positive concentration. But mostly what they will ask you, right? Mostly they will ask you either this one or this one, right? This, I don't think so. Very rarely they will ask you this, right? Then one is Let's say, before salt hydrolysis, I'll give you some other formulas as well here, right? So I'll give you some, I'll give it on the next page only. Some other formulas here for pH. Remember that when you have strong acid, right? So if you have strong acid, right, H positive concentration will be H positive from acid plus 10 raised to power minus 7, right? If your acid concentration is very small, then you have to add 10 raised to power minus 7. If it is less than 10 raised to power minus 6, if it is greater than 10 raised to power minus 6, you can ignore 10 raised to power minus 7, which is from water. If you have strong base, then OH negative is equals to OH negative from base plus 10 raised to power minus 7. Okay. Let's say if you have strong acid plus strong, if you have two strong acids, then what you will do? Then H positive will be equals to N1 V1 plus N2 V2 divided by V1 plus V2, or you can directly write M1. Let's say here the N factor is N1, capital N1 V1 plus small n2 capital M2 V2. Okay, because M is molarity here, right? Same is for two strong bases. If you have two strong bases, then answer will be OH negative will be equal to N1 V1 plus N2 V2. Ma'am, what is this N1 V1? See, V1 V2 is the volume, N is the normality. Small normality is equals to N factor into molarity. So that is why N factor. Let's say HCl. HCl has one N factor multiplied by molarity. H2SO4 has 2 N factor multiplied by molarity. So that's how molarity will be, N factor will be asked. Okay. Then if you have, very important, last one is very important. If you have one strong acid plus you have strong base, in that case what you will do? One strong acid and one strong base, then what you will do? See, it will be equals to, if let's say strong acid has more concentration as compared to strong base, in that case you will say H positive is equals to N1 V1 minus N2 V2 divided by V1 plus V2. Let's say if strong base is greater than, that means the N1 V1 value of strong base is greater, then here you are calculating OH negative is equals to same formula, mod of N1 V1 this. Students usually confuse between this, that sometimes strong base has more N1 V1 and they calculate the H positive concentration. See, because strong base has more concentration, so that's why you are calculating OH negative, not H positive, right? According to that you will answer, right? Okay. Understood everybody, right? Next is for salt hydrolysis. pH values you should know directly here. Very, very important, students. Very, very important, right? In detail, I have covered all the formulas, but here I am covering the important formulas only, right? So for salt hydrolysis, don't skip the formulas. If you are thinking of skipping everything, please don't skip these formulas, okay? Please don't skip. Directly, these are direct formula based question. They will give you the value of pKb, log C they will give you. You just have to put the question, put the formula in the question, that's it, okay? So this is pH is equals to 7 plus half pKb minus log plus log C. Weak acid plus strong base is the same. Instead of Kb, you have Ka here. Weak acid and weak base, you have pKa minus pKb here, right? Understood? Then buffer solutions. In buffer solution, when there is no net change, so you have two kind of solution. One is acidic buffer, then basic buffer. In acidic buffer, you have weak acid and basically, let's say you have a weak acid and the salt of that weak acid with strong base, right? Or you can say with basic buffer, you have weak base and the salt of that weak base with the strong acid, right? So they will ask you directly, this is Henderson's equation. They can ask you directly the pH formula here, right? They can give you the concentration of salt and acid and pK or pKb value depending upon which solution it is. And you just need to put this formula directly and you will get your answer, right? These are very direct questions, okay? Very direct questions these are, right? Okay? Right? Okay, students? Okay, next is solubility. Now, this is also very, very highly asked question. Very, very highly asked question. That is, let's say you have solubility. Here, this is X, this is stoichiometry is Y. So, here KSP value is going to be X raised to power X, Y raised to power Y, solubility of X plus Y. That is going to be the value here. Right? Okay, that is the value of KSP here. Right? Then let us talk about thermodynamics here, right? Let us quickly revise the formula of thermodynamics, okay? If you see thermodynamics, intensive extensive property form definition, intensive means independent. Just remember, intensive means independent of the mass. Extensive is dependent on the mass. And whenever you have two, okay, first thing is the intensive property examples are pressure, temperature, density, melting point, boiling point. Extensive is mass, volume, heat, capacity. Now, let's say you have molar heat capacity. This is important. Molar heat capacity. Because from here also they ask you the question. Or you have specific heat capacity. See, heat capacity is extensive, that depends upon the mass. But when you fix the molar, that these are the number of moles, I'm talking about 1 mole. If you fix the mass, then they are not dependent on the mass, right? Okay, because you have fixed the mass here. So they will be independent of the mass, right? Okay. One more thing is density is equals to mass by volume. Now we know that mass is also independent, intensive. This is also intensive. Density, if you see, wait a minute. Mass, volume is extensive. Huh? Mass is extensive because mass depends upon the quality. If you take 5 grams, so 5 gram mass will depend on mass, right? Yes, so mass is extensive, volume is extensive, and density is intensive. So the ratio of two extensive properties is going to be intensive. You should remember this as well, right? Okay. Then these are the processes that you should remember, right? Okay. That is isothermal means dt 0 and du is also 0. Isobaric dp 0. Isochoric dv 0. Adiabatic heat change is equals to 0, right? Okay. Now here we have seen this. Now let us see some formulas here. Like very simple direct question will be asked from these formulas. First is this first law of thermodynamics, that is delta U is equals to Q plus W, where W is equals to minus P delta V. Sign convention is when work is done by the system, it is negative. When you have to do work, you are very sad. When someone is doing work for you, you are happy. When you have to give money, you are sad. You have to release money, you are sad. When you are taking money from someone, you are happy, right? Then this also remember that QP is equals to delta H and QV is equals to delta U. These are some of the very important formulas, okay? Then remember in irreversible process, they will give at constant external pressure. A big external pressure will be there. But when you have reversible reaction, there they will give at variable external pressure. These are some of the hints that you should remember for your numericals, right? Now talking about the work here, just remember that when you have isothermal irreversible, this is the formula that you will use. For isothermal reversible, the formula will be in the integration. Log of V2 by V1 or log of P1 by P2, right? Okay. Then adiabatic is W is equals to N CVM T2 minus T1. But you know what they usually ask from adiabatic? They will give you adiabatic reversible, and these are the formulas that you should remember from adiabatic, right? That TV gamma is constant, TV gamma minus 1 is constant, P gamma 1 minus gamma T gamma is constant. These are very, very important. Now, ma'am, what is the value of gamma here? For that, you should know this thing. If you want to know the value of gamma, for that, you should know heat capacity. Heat capacity is Q by T. Now, we know that at constant pressure, it is Qp, that is delta H by delta T. At constant volume, it is Qv, that is nothing but delta U. So, it will be delta U by delta T. For molar heat capacity, you will divide both of them by number of moles, that is CPM and CVM. You will divide both of them by number of moles, right? So here you can easily calculate the value of delta H here. Here you can easily calculate the value of delta U, right? Delta H, this is also a very important formula, right? So here why I am writing CPM, CVM, because we are representing the number of mole is 1. For 1 mole, we are saying that heat capacity for 1 mole is CVM at constant volume, CPM at constant pressure, right? So these are the two very important formulas. Reason being, because whenever you calculate the value of gamma, that is CPM by CVM, right? And CPM, how we can calculate? See this. CVM is equals to degree of freedom into R by 2. CPM is equals to R plus CVM, right? So directly what you will do? Directly you will see the degree of freedom here, right? For monatomic, degree of freedom is 3. Diatomic or linear polyatomic like CO2, degree of freedom is 5. Non-linear polyatomic like SO2, degree of freedom is 6. You put the value of degree of freedom here and get the value of CVN, then get the value of CPM, divide it, and you will get your value of gamma here. Gamma for monatomic is 1.6, for diatomic is 1.4, for polyatomic it is 1.3. That you should remember, okay? Right? Okay. Then this is the other formulas that you should remember, that for isobaric pressure is constant, general formula is W is equals to minus P delta V. Isochoric volume is constant, so work done is also equals to 0 because delta V is 0. Cyclic process, work done is area under the curve. If it is going in clockwise direction, it will be negative. In anti-clockwise direction, it will be positive, right? If they have given you open vessel and some reaction they have given you, directly you will use minus delta NGRT. For free expansion, all the things will be equals to 0, right? Now, here see, if you ask me most important things, if you have to tell out of this, ma'am, I don't want to learn all of these things, then please remember this thing. This is very, very important. Isothermal, these two formulas are very, very important, right? These two formulas. Then remember this formula, right? Okay. Then these are the general things only. Then remember these two formulas, very, very important, right? Then remember this chart here, right? This chart here, the degree of freedoms, right? Then the last one is these two formulas are most important. Like if you're thinking of leaving thermodynamics, then you should not leave these two formulas. If you're thinking of leaving thermodynamics, then you should not leave these two formulas. Aldehyde ketones, carboxylic acid, hard, ma'am. Beta, you are asking this to a teacher. A teacher will not find it tough. That totally depends upon your knowledge, right? If you find it hard or not, I don't find it hard, right? But if you go through that in detail, you will not find it hard, right? If you have never studied it at this point, so definitely you will find it hard, right? Okay. So remember these two formulas here, that delta H is nothing but it is QP. Delta U is nothing but it is QV. If pressure and volume is given to you, you will use these two formulas. If delta Ng reaction is given to you, this is very important, okay? This is a very, very important formula. If a reaction is given to you, you will use this formula. Delta H is equals to delta U plus delta NGRT, right? Okay. Then this is Gibbs-Helmholtz equation. This is also very, very, very important. This page you should not skip if you are thinking of skipping uh, this, ma'am, I'm class 12th CBSE, ma'am. But I'll talk to you after in the end of the class, okay? For CBSE. Right now, I am in this totally dedicated towards completing this thing. Gibbs-Helmont equation, you should not skip. They will ask you which is spontaneous, non-spontaneous, temperature, all of this they will ask you from here. For spontaneous, delta G is negative. Non-spontaneous, it is positive. At equilibrium, delta G is equals to 0. Okay? Understood? Now, let us quickly revise solution chapters. In solution chapters, one important thing is Raoult's law that you must do. That is, total pressure is equals to partial pressure of A plus partial pressure of B. That is P naught of A mole fraction of A plus P naught of, that is pure vapor pressure, multiplied by the mole fraction. Okay, directly they can ask you questions based on this. Next is molality. Next is, you should not skip colligative properties here. That is, relative lowering in colligative property, relative lowering in vapor pressure is P naught minus Ps by P naught is equals to mole fraction of solute, that is 2. Elevation in boiling point is delta Tb Kb into molality, right? Depression in freezing point is delta Tf Kf into molality. Kb is alebbioscopic constant. This is the formula. Usually we skip it, right? But you know, sometimes they also ask question from here, right? So you must do this formula as well. This is cryoscopic constant and this is the formula of cryoscopic constant. Okay. Next is osmotic pressure, which is pressure pi is equals to CRT. Pi is equals to number of moles of solute by volume in liter RT. That is going to be the full-fledged formula here, right? Let's say you have some external pressure that is greater than osmotic pressure, then that will cause a reverse osmosis. That is, next is, let's say the type of solutions. Isotonic, both are equal. Hypertonic, the one which has, hypertonic, the one which has more osmotic pressure. Hypotonic is the one which has less osmotic pressure. Hyper means more. Just remember that hyper means more. You're saying that hyper means angry, means more, right? So that's how you can remember this, right? Then, when you're talking about Van't-Hoff factor, then all these terms will be multiplied by Van't-Hoff factor. That is I over here, I here, I here, I here. All the concentration terms will be multiplied by Van't-Hoff factor. Right? Most welcome, most welcome. Now here, see this. If they have given you association, this is the formula. This is the association means if it is dimerizing, n is equals to 2. Trimer means n is equals to 3. Tetramer means n is equals to 4. Degree of dissociation will be given to you, right? If it is dissociation, then I is equals to 1 plus n alpha minus alpha. These are the two formulas that you should remember. Okay, these are the two formulas that you must remember, right? Then the next one is nth order of reaction. Let's see chemical kinetics here. So see, for chemical kinetics, either you can remember this general formula here, right? General formula, your choice. I never remember the general formula. Rather, I focus on, because the formulas of the integrated rate law equation and half-life period, the formulas also you should know for each of them. Right? For zero order, it is A is the final temperature at final time. At final time, what is the concentration? AT is equals to A naught minus KT. K is the rate constant here. And T half is initial by 2K. Right? First order is log of initial by final is equals to KT by 2.303. Right? We also write it as K is equals to 2.303 by T log of A naught by AT. This is also how we write it, right? Okay. Then T half is 0.693 divided by K. This is very, very important formula. Right? Definitely they will ask you question, right? Very, very important from first order reaction. Okay. Second order reaction, you can skip this also, right? But zero and first order you must do. Right? Second order, very rare chances they will ask you, but still 1 by final time minus 1 by initial is equals to KT. Right? T half is 1 by K A naught. Now, instead of cramming this general formula, I will ask to learn two important general formulas of rate constant. That is the units and the T half. Okay, the proportionality is enough. You don't need to remember the full formula here. Proportionality. T half is directly proportional to A naught 1 minus N. Then the units of rate constant is mole per liter 1 minus N per second. Okay, mole per liter 1 minus N per second, that is the units. Okay, that you should remember. These are very, very important. Very, very important. Then next is this very important equation, that is K is equals to A e raised power minus EA by RT, right? If you solve this in log, it will come out to be this equation, which is very, very important. See, either numerical based question from here or graphical based question from here they can ask you, right? Numerical means they just need to put the values and calculate it. And graphical based question, I'll do that. I'll take one session of graphical based question. I'll do the graphical question there. But yes, chalo, if you want to see this, you can see when you take the log here, it will be converted to this thing. If you compare this with straight line equation, that is y is equals to mx plus c. So m is coming out to be minus EA by R. C is coming out to be ln of A, that is the intercept. M is the slope here. Okay. Next we have is the last chapter, that is electrochemistry. From here, although this chapter is very big, but there are some formulas that you should not skip. That is, first is this Nernst equation formula you should not skip. E cell is equals to E naught cell minus 0.059 by N log of product by reactant, right? So here E naught cell is nothing but, if you want to ask E naught cell is nothing but this is E naught of cathode minus, I'll just write it here. This is E naught of cathode minus E naught of anode, and the reduction potential of both of them, not the oxidation potential. N is the N factor, the number of electron lost and gained, and log you have oxidation by reduction, or you can say product by reactants. That is the formula, right? Then these three formulas of delta G and E naught cell, right? Delta G and Kc, equilibrium constant, E naught and Kc. These three formulas directly they can ask you the question from here. Very, very important, right? Then right now, earlier times they used to ask question from here. Then the trend shifted to this side. Now the trend is shifting to this conservation of energy, right? So here that means they are revolving somewhere here, right? So that is conservation of energy. Remember that they will give you, let's say A is getting converted to A positive. This is to A2 positive. And here they will ask you from A to A2 positive, what is the E naught value? Remember that E naught is not additive in nature. So what you will do? N1 multiplied by E1 naught, N2 multiplied by E2 naught equals to N3 multiplied by E3 naught, right? So directly you will use this formula. How I derived this formula, that is from conservation of Gibbs energy. Don't get into that. Just remember this formula. Just remember this thing. Okay? Right? Understood? Yes, everybody? Then next is, from here currently they are asking you questions. One is for strong electrolyte, you can find the infinite dilution molar conductivity, right, by the graph. But for weak electrolyte you cannot find. That is the reason you have Corlosh law here. That is, you have these two things here, right? So Coriolis law means that the weak electrolyte infinite conductivity is equals to the sum of the individual conductivities here, right? Okay. Then one important thing, this is very important, that molar conductivity, the exception of H. H has very high molar conductivity, that is an exception, right? But more the size of the ion, more will be the molar conductivity at infinite dilution. This is a very, very important thing. You might ignore this, but they are asking right now question based on this part, right? Okay. Then this I'll tell you after doing this thing, right? So one thing you should know is that resistances are, conductance is D, resistivity is rho, conductivity is kappa, right? Remember that G into G star is equals to kappa, where G star is the cell constant, that is L by A, right? And also remember one thing, if they have given you kappa in meter, then the formula of molar conductivity is kappa by molarity into 1000. Equivalent conductivity is kappa by normality into 1000. But till NEET level, they will give you per ohm and centimeter only. But what if they give you in meter? You should apply this formula, not this. But if they have given you in centimeter, you will apply directly kappa into 1000 by molarity is your answer. Now here you have calculated concentration at C. Here you have calculated molar conductivity at C concentration. And here, if they ask you the value of degree of dissociation, put the value of put the value of molar conductivity at C concentration divided by infinite concentration, right? This you will get for Coriolis law. This you will get from the formula, right? Here you can calculate the value of alpha. And for mono, see, if you have a weak acid which is giving you 1 proton, always the value of Ka is going to be C alpha square. Put the value of alpha here, molarity is given to you, you will get the value of dissociation constant as well. Okay? Understood everybody? Is that clear? Now, this also remember that if you increase the dilution, concentration will decrease, conductivity will decrease, but molar conductivity will increase. Okay? These are some of the relations here. Right? Okay, students? Then Faraday first law. Faraday first law is W is equals to ZIT. Z means you have E by Faraday. E means equivalent weight. Equivalent weight is molar weight by N factor. So directly you can remember W is equals to MIT by NF, molar mass, current, time, N factor and Faraday, 96500. And Faraday's second law states that the ratio of weight of metal A and metal B that are connected in the series is equal to equivalent weight of ratios of equivalent weight of A and B, right? Okay, that is the Faraday's second law here. So these are the formulas, student, that you must remember, must do, right? Now there are some questions related to inorganic chemistry. Let me know in the chat box if you want to do the questions related to physical chemistry. Yes. Let me know in the chat box if you want to do the questions related to physical chemistry or not. Right? If you want to do that, then let me know here. Okay? Then let me know if you want to do that. I have picked up questions for you, but I want to see if you are interested or not. Right? Chalo. Okay. Yes. Now, let us see the questions here. Okay. So, first is, a solution is prepared by dissolving 0.6 of urea. Now, let us see, we have seen the formula. Now, we will see how to apply those formulas. Okay. A solution is prepared by dissolving 0.6 gram of urea and this much of glucose. So this means this is weight of solvent is solute is given to you. This is some other solute is given to you, right? Dissolving this and this, two solutes in 100 milliliter of water. The osmotic pressure they are asking you. We know that osmotic pressure is equals to number of moles of solute by volume in liter RT, right? What if I calculate the total number of moles because of urea and glucose? For that, what I have to do, what we will do here, first we will calculate the total number of moles here for urea. Total number of moles, I'll say, total number of moles is equals to number of moles of urea plus number of moles of glucose. Number of moles of urea is what? Total number of moles, firstly I want to calculate. Number of urea is 0.6 divided by 60 plus glucose is 1.8 divided by 180. These will be the total number of moles that you will put here. Volume is given in 1000 milliliters. You have to convert it into liters, right? That means you will divide it by 1000, right? Whenever you convert more to less, right? That means you less to more, then you divide it, right? So that means volume in liter is going to be 100 divided by 1000, that is 0.1. Okay, that is 0.1. R value is already given to you in the question, that is 0.02. You can also take it as 1 by 12 to make the calculations easy. Temperature is also given to you, that is 27 degree. That means it is 300 Kelvin. Okay, 300 Kelvin. So you need to put all the values here and then you will get your answer here. Okay, then you will get your answer here. Okay, yes everybody, just remember this, if this is in milliliters, you will have to divide it by 1000. Okay, yes everyone. Next is which of the answer is also written here, right? Okay, thank you Patil, that means a lot to me, thank you so much, right? Which of the following set of quantum number is incorrect? So now they are talking about incorrect quantum numbers. So now what you will see, n should not be equals to L. First condition is, because we know that L is equals to 0 to n minus 1. So here n is not equal, here also n is not equal, here also n is not equal. Here it is equal, so that is definitely the incorrect answer. If this does not apply, you will see whether m is equals to minus L to plus L. Then you will see whether S is equals to plus half or minus half. According to these three things, you can answer that which of the following is the incorrect set. So incorrect set will be D, because n can never be equals to L. Okay? Yes, very good. D is the correct answer. Next is number of radial nodes of 3s and 2p respectively. See, radial nodes, we know that it is n minus L minus 1. So if you put this here, this is 3 minus 0 minus 1, that is 2. For 3s, it is going to be 2. For 2p, it is going to be 2 minus C. If L, and this is the value, always remember this is SPDF, right? This is 0, 1, 2, 3, right? For P, the value of S is 1. The value of N is 1. Sorry, L is 1, right? So 2 minus 1, that will be 0. Radial nodes will be 2 and 0. So answer will be first is the correct answer. Okay, right? Yes, definitely you can improve, Sandy, if you watch the full lecture here. Okay, you have to watch the full lecture for that. Right, next is if a molecule of AB undergoes trimerization in benzene, its Van't-Hoff factor is found to be this much, right? Van't-Hoff factor is given to you. Degree of dissociation they are asking you. Trimerization means N is equals to 3. Directly the formula you will apply here. That formula is going to be I is equals to 1 plus alpha. Basically, the formula is equals to I is equals to 1 minus alpha plus alpha by 3. Or you can just put N here. Because the value of N is 3, you will put 3 here, right? Then I is also given to you. That is, I think 0.6 something is given to you. I na 0.6 was given to you. Yes, 0.6 is given to be the value of van 't Hoff factor. Now you just need to solve this, right? Okay. Alpha, you just need to solve. Take the alpha common. This is 0.6. This is 1 minus. This will be, if you take minus alpha as common, this will be 1 minus 1 by 3. From there, you can easily solve the value of alpha here. Right? Okay. Yes. Next is the enthalpy of reaction. So let's say here enthalpy of reaction is given to you is negative. If the enthalpy of combustion of this and this are x and y respectively, select the correct option. See, let us see it like this. Enthalpy is given to you, this reaction is given to you is negative. Enthalpy of combustion of CH4 and CH3OH are this and this. Combustion of CH4. Combustion of CH4 means CH4 plus O2 give rise to CO2 plus H2O, and CH3OH also means you add oxygen, that will be CO2 plus H2. That is the enthalpy of combustion. That means in that case, if this is given to be negative, so simple thing is, if this is given to be negative, that means delta H is negative. That means enthalpy of product minus reactant is negative. That means product is less than reactants. Okay? That means product is less than reactant. For product, it is given to be Y. For reactant, it is given to be X. That means X will be greater than Y. Right? So answer will be yes. So answer will be A is the correct answer here. Right? A is the correct answer here. Now, this question is also very important, students. They are asking you the oxidizing agent. So just remember one thing. Whenever reduction potential is given to you, what you do? It is the more the reduction potential, that means that person wants to get reduced. Okay, so that means it wants to oxidize something else, right? That means its oxidizing power is very high. Oxidizing power is very high. Its reducing power is very low. Okay, so you know this question is repeatedly they ask you these questions. This I can't tell you these kind of questions by any formula. So that's why I picked up a question related to this. Right? So here if you see from 0 to -1, it is decreasing, it is reduction potential. This is also reduction potential. This is +6 to +3. Here you will calculate the oxidation number, that is 2x minus 14 is equals to -2. X will be +6. So it is +6 to +3. All of them are getting decreased. That means reduction potentials you have. So they are asking you the oxidizing power here. More the reduction potential, more is the oxidizing power. So maximum will be for chromium. And the following in oxidizing agents in order. C are that is going to have the maximum. Then there will be Br2. Then there will be Fe3. So answer will be A is the correct answer. Right? Okay. Then there will be Br2. It is 1.09. Then there will be 0.77, which is having the lowest value. So answer will be, students, A is the correct answer. Okay. A is the correct answer here. Next is, which is the correct order of increasing energy of the listed orbitals of titanium? See, here you should apply N plus L rule. More the N plus L rule, more will be the energy. So, beta, formulas I showed you differently. These are the questions that were not direct formula, but they are conceptual questions. Okay, that's why I have taken these questions. Okay, what is the correct order of increasing this? So here what you will see, more the value of N plus L, more is the energy. So you have 3s, 4s, 3p and 3d. Here it is 3 plus 0, that is 3. 4 plus 0, that is 4. 3 plus SP01, that is 4. 3 plus 2, that is 5. Now, if n plus L is same, then more the value of n, more will be the energy. So among these two, 4s is going to have more energy as compared to 3p. So overall answer is going to be 3s, then you will have 4s. Wait a minute. 4s is going to have more energy, right? So 3s, then you will have 3p, then you will have 4s, the last one is 3d. So this is going to be the correct order. So 3s, 3p, 4s, 3d. So answer is going to be D is the correct answer here. Right? Okay. Yes. Next is we have. Sometimes when I see people like Patil, I just laugh at them and think that what must be their like future goals in life, to be to get money from people and to spam in the YouTube. This is actually their career. These are the careers that they are having. Ma'am, I want to be a doctor. No. They want to be spoilers, right? Okay. So this is what they want to be. I don't know what is their aim in life. No idea on that. I think there are some like great people out there who have some like a lot of maybe some money from their father, like all of that, right? Maybe some big hotels they are owning, that they think that they don't need to earn to survive, right? So good, yeah, Patil. If you have such like high amount of money in your account, then also give us some job, right? Because I feel only either you are very rich if you can waste your time like this, or you are very stupid. Two things are there. So which of the following facts regarding ionic conductance of the following ions is correct? See, as I told you, it is directly proportional to the size, right? So here we know that lithium, so we have sodium. We know that down the group, molar size increases. So molar conductivity also increase. Rb, then potassium, then Na. So answer will be D is the correct answer here. Right? Okay. I think that was the last question, is it? Let us see. 3-4 more questions you have. The Bohr radius for hydrogen atom is n is equals to 1. The radius of first excited state they are asking you. So here what you have to do, directly put the formula of radius, because the options are in Armstrong. So we will put the formula also in Armstrong, right? Then we know that if they are talking about the Bohr radius, z is equals to 1. And for first excited state, n will be equals to 1 plus 1, that is 2. So you will put the value here and you will get your answer here directly. Okay. Then next one is standard free energy. Now what they have given you here, standard free energy of formation of AgCl is this. H positive and Cl is given to be this E naught value. This is, I would not advise you to do this question, right? You can just ignore this, right? Let us see this. For an elementary reaction, 2A, this is given to be K1, this is given to be K2. Rate of disappearance they are asking you. So whenever you have these kind of questions where K1, K2, this is there. So remember one thing, the rate in the form of this equation here will be equals to, I'll just write here only, rate in terms of this will be equals to K1 multiplied by A raised to power stoichiometry. Backward it is going to be K2 B raised to power the stoichiometry. We also know that in terms of disappearance of A, the rate will be minus 1 by 2 dA by dt. Right? That is K1. So I'll just put it here only. That is equals to minus 1 by 2 dA by dt. We know that the rate of disappearance, you will not divide it with the moles. For rate of reaction, you will divide it with the moles. So rate of disappearance will be minus dA by dt, that is equals to 2 into K1A square minus 2 K2 into B. So answer is going to be C is the correct answer. Okay. Okay, students, that is how you're going to answer these questions. Next is A to B is given to you, delta H value is given to you, energy of forward, and then they are asking you for the backward. Okay. So delta H is equals to activation energy of backward minus activation energy of forward. Right? So we know that delta H is given to be minus 10, right? Activation energy of forward is given to be 50, and activation energy of backward they are asking you, that is going to be activation energy, this is given to you, no? Wait a minute. Forward minus backward it should be, yes. That's why it should be forward minus backward. Okay. Then they are asking you for the backward. This will be EA of backward. Delta, this will be E of backward, will be EA of forward plus delta H. Delta H, minus delta H. Okay, this is going to be minus of delta H. So EA of forward is going to be, that is going to give you, this is giving you 50 minus of backward is given to be, backward is what they are asking you. So this is going to be 60 here. So answer will be D is the correct answer here. Right? Okay. And next is the ratio of energy of photon of 2000 Armstrong wavelength radiation to 4000 Armstrong wavelength radiation. So now here you have to take the ratio. We know that E is equals to H mu, that is Hc by lambda. That means E is inversely proportional to lambda. So E1 by E2 is lambda 2 by lambda 1 because they are inversely proportional. You put both the values and you will get the answer. Trust me, these simple questions they have asked in NEET. Right? I know you must be feeling, ma'am, these are such simple questions. Do they really ask these questions in NEET? Yes, they ask these kind of questions in NEET. Right? Okay. Understood? Right? Everybody? Everybody? Is that clear? I think I was left with some more questions here. Right? Yes. So let us go through these questions as well. Right? Because I have picked up some more questions for you. I forgot that. I think that was in between somewhere. Acha. Now here they have given when 10.6 gram of non-volatile substance is dissolved in this much of ether delta H. So I'm just giving you that what exactly, how to read the statements, okay. So when this much of non-volatile substance, that means this is added, so this will be W2, right. This much of ether, that means ether is the solvent, that is W1. Boiling point is raised to this, that means delta TB is given to you. Molecular weight of the substance they are asking you, so directly put the value of boiling point delta TB, right. So because here nothing they have told you about want or factor, that means then they are not even asking you that, shall take want or factor as 1 only. So directly you will put this formula, right. Want or factor you have taken 1 because nothing, no knowledge is given to us regarding that, right. So delta TB is given to you. We know that what is the value of molality. See, molality is equals to weight W2 by W1, sorry, M2 multiplied by W1 into 1000. Okay. If weight you are calculating it in grams, right? If I am putting the weight in grams, this is given in, let's say, this is also, both the things are given in grams, so I'll multiply it by 1000, right? Okay. So W2 is given to you, W2 is given to you, W1 is given to you. You'll just need to put it like this. Delta TB is equals to W2 by M2 multiplied by W1 into 1000 multiplied by KB. KB value, it is already given in the question, right? That is a standard value. KB value, beta, they will always give you the value of KB in the question. Molar boiling point constant for ether is given to be 2, right? Okay. So what you have to do here, see, everything else is given to you. Boiling, because KB value, that is your, for water it is 0.56 something, right? For ether it is different, that is 2. That should, they will give you in the question, don't worry about that, right? This is given, this is given, this we have given, this they are asking you, this is also given to you. So you just have to put these values here and you will get your answer here, right? KB is given in the question, right? Sometimes they also ask KB, right? Osmotic pressure of equimolar ratios of urea. Equimolar means number of moles are same. So pi is equals to number of moles by volume RT. If number of moles is same, then what is different? I is different, right? I is different, beta. Bond-Hoffe factor is different here. Here this is divided into 3. This is dissociated into 4, right? Urea is dissociated into 0. That means there is only one molecule after the dissociation, right? So maximum will be for AlCl3, then there will be BCl2, then you have urea. Okay, so this is based on the Bond-Hoffe factor, right? So answer will be C is the correct answer here, right? Okay. Then next question is based on resistance. So now how to solve these kind of questions, that also you should understand. The resistance of conductivity cell containing this much, that means molarity is given to you. At this is this, that means the resistance is given to you. What is the cell constant if this much, okay, they are saying if the concentration this much, if the conductivity, that means kappa is given to you, this is given to be kappa. We know that G is equals to G into G star. G into G star is equals to kappa, right? We know that, right? That means this is 1 by resistance. G star is equals to kappa. Now they are asking the cell constant, that is kappa into resistance. So kappa is given to us, resistance is given to us. You just need to put your value here. G star, kappa will be 0.146 multiplied by 10 raised to power minus 3. Resistance is 1500. You solve this and you will get your answer here. Right? Okay. Okay, students. Now, I think 2 more questions we are left with. We'll do that. Right? 3 more questions we are left with. Let us do that. Okay. If you see this here, calculate the EMF of the cell in which of the following reactions will take place. They're asking you the EMF. Now, I am going to tell you how to apply Nernst equation. Okay. So, this is E cell is equals to E naught cell. So first you should know what is E naught cell. For this is already given to you in the question, that is E naught cell. Correct? It is already given to you in the question regarding E naught cell. Minus 0.059 by N. N factor you can see 2 electrons, 2 Ag positive to Ag, that means 2 electron. Ni to Ni 2 positive means 2 electrons. So N factor is going to be 2. Log of product by reactant. So we will take the concentration of only the ions. So product is what? Nickel, that is 0.160. Reactant is Ag, but the it will be raised to power the stoichiometry, right? E naught value is given to you, that is 1.05. Now you just need to put the values. We have already put it. So you just need to solve this equation here, right? Understood, students? How you are going to apply Nernst equation, right? Next is, for a reaction is given to you. The rate of change of concentration of hydrogen is this. The rate of change of concentration for hydrogen is given to be this. The rate of change of concentration for ammonia, they are saying. See, rate will be equals to, for hydrogen, it is dH2 by dt. Hydrogen is disappearing, so it will be 1 by 3, minus 1 by 3. Ammonia is appearing, it will be plus 1 by 2 dNH3 by dt, right? Now here, what you need to do is, you just need to put the value of, they have given you rate of change of concentration of hydrogen. This is given to you, that is 0.3 into 10 raised to power minus 4. Now, appearance of, whenever we talk about the appearance, just remember, rate of reaction you divide it by number of moles. For appearance, disappearance, you don't divide it by number of moles, right? So this will be equals to minus, or you can say 2 by 3 of minus dH2 by dt. Minus dH2, this is the rate of disappearance, minus dH2 by dt is given to be 0.3 into 10 raised to power minus 4. Okay, so I'll just put this value here, that will be 2 by 3 into 0.3 into 10 raised to power minus 6, and we will get the value here. Right, this also does not have any formula, but yes, this is very important, right? Okay. No, Vishwahar, no, you don't need to study that, okay? You don't need to study that. Focus on something else, right? That will be more beneficial, right? Then the last question of today is based on the order, okay? So this also is not any formula. You just have to follow a simple trick here, okay? So whenever they have given you something like this, some table, experimental values are given to you, they are asking you the rate here. Firstly, what you will do, you will make one concentration as constant, okay? This is constant. Now I'll see what is the change here. When the concentration is multiplied by 2, the rate is also getting multiplied by 2. That means, according to B, with respect to B, what is happening here? Rate, new rate is equals to multiplied by 2, and concentration is getting 2 times, 2 raised to power n times. But just remember one thing. The formula is R dash is equals to x raised to power nr, where n is the order, x is the number of times the concentration is increasing or decreasing, right? So this is increasing by 2. So that means with respect to B, order of this is 1. With respect to B, right? Now, if you talk about, ma'am, let's make the concentration of B constant. B is constant over here. Here, concentration is changing, multiplied by 2. Rate is also getting multiplied by 2. That means again, R dash is equals to 2 into R. When R dash is equals to, concentration is increasing 2 times raised to power nr. That means again, with respect to A also order is 1. So rate of the reaction will be this. B will be your rate of reaction. That's how you're going to solve these questions, okay? That's how you're going to solve these questions here. Understood? This you don't need to do, right? This you don't need to do. Directly solve it with this thing, right? You will get the answer. Okay, students? Okay, I think all the other things we have already completed. Oh my God, that was a big task that we have done today. 262 slides, gosh, that we have completed. But students, you know what? Your work is not just completing this marathon. After this marathon, you can definitely take rest. But just give me a minute. The file is also getting hanged because of so much I have written here. The Revise-a-thon is also going on till 29th of April, totally free of cost by Vedantu. We are providing you the marathon, right? So till 29th of April, free revision is going on, right? You can watch even the PDF is provided in the description box. You can go and see that. And free test series are also provided to you. You can go and see that your test series also in the chat box, in the description box. Test series for NEET 2025 are also provided to you based on the new pattern. Then study buddy, this is also for totally free of cost, that will help you in next 5 to 6 days for your good revision, right? Instant access to daily study material and smart study assistant. You can just need to scan this QR scanner and you will get to the portal there, right? And NEETpedia, where we are providing you NEET previous year question, most important, and NEET 2022 to 2024, right? From 2022 to 2024, we are providing you question papers, right? Okay. So that is all available to you totally free of cost. And for those students who are looking for 2026 offline centers of Vedantu, then students, these are the areas where our offline centers are located. And over here, if you want to get 40% scholarship, that is already being provided to you in our offline JEE and NEET repeater batch that has started from 25th of April, right? And for 90% scholarship, you need to enroll yourself to this MVSAT admission test. Admission test will be taken, and after that, if your marks are up to the mark, then you will get 90% scholarship you can avail from here, right? So totally dependent upon your admission test that you can get 90% scholarship as well. Okay, yes. And students, all the notes also will be provided to you in the description box here only. In the description box, you will see all the notes will be provided to you. You will see nearest Vedantu Center, Revise-a-thon, All India Test Series, your study buddy, NEETpedia, Champion Test Series, then Telegram community, NEET Revise-a-thon PDF is also provided to you, right? Then your IVSAT program, click here. And on the top of it, right after like maybe over here, you will see session PDF link. You will click on this and you will get to the session PDF link here, right? Okay. Session PDF, I think, will be generated. Maybe it will be uploaded by today or maybe by Monday. That will be updated. Okay. Chalo, it was a very, very long marathon. Now, even I am very, very tired, right? So I'll just sleep now. And you can also relax because you have done a lot, right? Those students who were constantly sitting here. And I would definitely I would love to see your comments, guys, because it's not easy to teach for these many hours, right? And it's not also easy to study for those many hours. So I want to see your, like what you're feeling right now, whatever you want to tell me regarding this marathon, was this beneficial for you or not? Everything that you have in your mind to just tell me in the comment section. I'm waiting for your comments. Okay. Okay then. Bye bye. Take care. See you all students in the next class. Bye bye.